गुरविंदर सर हेलो 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 yes, hello everyone, welcome on YourPedia platform. I hope you all are fine, preparing well. So guys, today is very important day for all of you. Tomorrow or day after tomorrow, most of you are having your examination. So today you need to be you need to very much you need to pay attention, you need to be very calm, okay, very much focused also. You need to have very good sleep, take very good sleep today. So guys, add energy. Motivation is very much very important thing for all of you. When today or tomorrow or day after tomorrow you are having your examination, so you need to have energy, you need to full of energy, you need to have that kind of energy. Yes, I'm going to crack this particular examination. That kind of energy, that kind of confidence is required at this particular moment, guys. So let's start with very positive note. Let's start with very this I'm not unaware about the writer. So उनको हम बोलेंगे बिल्कुल. First we will pay thank you to that particular writer. So खोल दे पंख मेरे कहता है परिंदा, अभी और उड़ान बाकी है, जमीन नहीं है मंजिल मेरी, अभी पूरा आसमान बाकी है. So guys, let's start with this very positive note. And guys, this session is very important because through this particular session we will try to revise all important concepts, all important formulas related to mechanical engineering. Okay, actually the purpose is to discuss like what are the important areas, those on which you need to focus actually, because time is very less. Okay, so very casually you need to attend this session, guys. It's my suggestion to all of you. आज आपको ज्यादा स्ट्रेस नहीं देना है दिमाग पे, वेरी कूल कंफर्टेबल होके यू नीड टू अटेंड दिस सेशन. ओके, सो यू देयर इज नो सच काइंड ऑफ पेन पेपर. आई एम नॉट सेइंग टुडे कि सिट विद पेन पेपर, राइट ऑल दोस फार्मूलाज एंड जस्ट पुट ऑल दोस फार्मूलाज इन योर माइंड. नो, ऑल दोस टाइप ऑफ थिंग्स आई एम नॉट गोइंग टू से टुडे. Today you need to be very much comfortable. You can watch this session even if you are sleeping, if you are at your bed also, then also this session you can attend. Okay, but the purpose is to discuss all those important formulas, and if you have earlier covered all those important formulas, guys, then this class is surely going to help you, because in a very short duration of close to 2 hours we will try to cover each and every subject of mechanical engineering. Okay, so important formulas only we are going to discuss, and from our mentor experience we will try to share, we will try to highlight some important formulas on which you need to pay attention, which are very important for the upcoming examination. तो कुछ questions we will try to cover कि जो questions पे आपको focus करना चाहिए, जो questions आ सकते हैं एग्जाम में. So let's start, guys. Yes, Aman, good evening, जय हिंद. चलिए विजय राजू, good evening all of you guys. PDF, yes, at the end of this session, guys, you will be able to download this PDF from YourPedia website. ठीक है, तो पीडीएफ आपको मिल जाएगा, पीडीएफ कोई इशू नहीं है. सो चलिए गाइस, लेट्स स्टार्ट विद थर्मोडायनामिक्स फर्स्ट. थर्मोडायनामिक्स इज वेरी इंपॉर्टेंट सब्जेक्ट, बहुत इंपॉर्टेंट सब्जेक्ट है थर्मोडायनामिक्स. सो इंपॉर्टेंट फार्मूलाज पे मैं फोकस करूंगा. व्हाट इज थर्मोडायनामिक्स, सिस्टम सराउंडिंग क्या होता है. थर्मोडायनामिक्स में एक लाइन बोल के शुरू करता हूं. Guys, thermodynamics is that branch of science which deals with energy interaction. We cannot create energy, we cannot destroy energy. That we know through first law of thermodynamics. So our entire aim is to maximize that conversion. Through second law of thermodynamics, we know the complete conversion of heat into work is not possible, because all real processes, they are having some kind of irreversibility, which is nothing but a loss of available energy. So the loss of potential work, the loss of maximum work, that is known as irreversibility. And irreversibility is there. There are the two main reasons for the irreversibility. One is due to the internal irreversibility, means friction. Okay, and second reason is external irreversibility, means the non-equilibrium between system and surrounding, because the non-equilibrium between system and surrounding that causes external irreversibility. So Otto, diesel, dual, different cycle, Brayton cycle, air standard cycle, all are internally reversible only. They are not completely reversible. Carnot cycle is the completely reversible cycle, and for that Carnot cycle, the efficiency depends on the temperature limits only. It is independent of the working fluid. So this is very, very important subject, guys, which gives us the basic understanding of energy conversion, how and what we need to do to maximize that energy conversion. Through second law of thermodynamics, guys, we get the idea about the entropy also. Entropy of universe keeps on increasing. It is increasing day by day. So lots of problems in our examination, generally in GATE, we found related to find out just to find out the entropy generation. Like if there is some kind of case they are going to give you, it may be mixing case, okay, it may be some kind of solid body. So how to find out entropy generation, that is very, very important. So let's start with this particular subject, guys. Thermodynamics basic cheeze hai. I think you all have studied what is thermodynamics, what are intensive properties which are independent of the size or mass of the system. All specific energies, temperature, pressure, thermal conductivity, density, these are known as intensive property. The properties which depends on the size or mass of a system are known as extensive property. So all energies, volume, mass, these are known as extensive property. Equilibrium, equilibrium is very important in thermodynamics, because if there is no equilibrium, the system and surrounding, they are not in equilibrium, then that is going to cause external irreversibility. That's why in entire thermodynamics, when we are going to carry out any kind of thermodynamic analysis, we assume the system and surrounding, they are in equilibrium. Okay, system and surrounding को हम क्या मान के चलते हैं, equilibrium में मान के चलते हैं, because that is required. If system and surrounding they are not in equilibrium, that is going to cause irreversibility. Okay, so what is equilibrium, guys? What do you understand by thermodynamic equilibrium? If a body is in chemical equilibrium, thermal equilibrium, and as well as mechanical equilibrium, then you can say that that body is in thermodynamic equilibrium, because generally in thermodynamics we assume what you can say single phase substance. Generally we deal with single phase substance. That's why I'm not highlighting that fourth kind of equilibrium, which is known as phase equilibrium. So actually if there is phase equilibrium, chemical equilibrium, mechanical equilibrium, as well as thermal equilibrium, then you can say that system and surrounding, they are in some kind of thermodynamic equilibrium. So this formula, first formula, which is very important for us, Gibbs phase rule. F plus P equal to C plus 2, where P is known as number of phases. Generally there are 3 phases, solid, liquid, gas. तो उसमें से कितने phases आपको उसने दिए हुए हैं. Okay, F is the DOF, degree of freedom, and C plus 2, C is the number of component. Yahan se, guys, let me tell you one important thing. If they will ask you what is degree of freedom for a pure substance, single phase pure substance. So guys, if you are having single phase pure substance, means pure substance, you can write single component. So C equal to 1. P means number of phases 1, single phase pure substance, so P will also be 1. Then F will be equal to 2. Single phase pure substance, F equal to 2. Otherwise, for any other case, if you want to find out degree of freedom, how many number of independent coordinates required to specify the state of a system, that you can easily find out using this Gibbs phase rule. ठीक है, तो इसको कैसे यूज करना है, that you need to be very much aware. What is P, what is F, what is C, and what is this 2. ठीक है, तो चलिए जीरोथ लॉ है. मेरे ख्याल से कोई बहुत ज्यादा डिस्कशन रिक्वायर्ड नहीं है जीरोथ लॉ पे. एक लाइन बोल के मैं जीरोथ लॉ को खत्म करता हूं. लेट मी कंक्लूड जीरोथ लॉ. So guys, zeroth law, if anybody will ask you what information we are getting from zeroth law gives us the portable means of temperature measurement. What do you mean by portable? We can measure our temperature anywhere without bringing that body into the lab. So even before 1934, because zeroth law came into existence in year 1934, before that we know the temperature, we know the definition of temperature, and we defined temperature. We are having the temperature measuring instruments also. But after this zeroth law, we got information that we can measure temperature by using some kind of calibration without bringing that lab body into the lab. So zeroth law gives us the portable means of temperature measurement. Okay, तो चलिए temperature measurement का जो 1934 से पहले हम use करते थे, that was based on the 2 fixed temperature, ice point and steam point. And after 1964, after 1954, the temperature scale which we are using, that is a single point fixed temperature, and that single point fixed temperature is ice point. तो चलो मैं इसमें आपको एक बहुत इंपॉर्टेंट एक बता देता हूं कन्वर्जन के लिए, because in GATE they sometime ask you question related to conversion, like some kind of temperature scale you are having, something like this. It may be degree P, so you are having some scale degree P, okay, And on degree Celsius, you know what is ice point? Ice point is 0 degree Celsius and the steam point is 100 degree Celsius. Okay. And suppose on some degree P scale, they will give ice point as 30 degree P. Okay. And steam point as some suppose 300 degree P. On some random scale, you know, all these temperature scales are random. Okay. We defined ice point as 0 degree Celsius and 100 degree Celsius in degree Celsius scale. Similarly, in Fahrenheit scale and Kelvin scale, we defined those ice points and steam point. So all temperature scale, they are arbitrarily chosen. So then I am taking some random scale which is having ice point 30 degree P, steam point 300 degree P, and suppose I want to find out the temperature corresponding to 100 degree P in degree Celsius. मेरे को टेम्परेचर निकालना है corresponding to 100 डिग्री P in degree Celsius. तो एक बहुत इंपॉर्टेंट कन्वर्जन हम यहाँ पे यूज करते हैं बच्चों. You need to write it here. 100 minus 300 divided by the length of this scale. 300 minus 30. This is not 300. This is 100 minus 30. Okay. So 100 minus 30. This is 30 degree P, guys. ये क्या है? 30 degree P. 30 degree P. Okay. So 100 minus 30 divided by 300 minus 30 equal to x minus 0 divided by 100 minus 0. Solving this easily, you will get the temperature corresponding to 100 degree P. Or he can give you temperature in degree Celsius, then corresponding temperature he can ask you in degree P scale, any random scale, degree P, degree S, degree Q, something like that. So how to find out temperature in any degree P scale corresponding to some degree Celsius temperature, that I discussed with you. I hope you somewhere earlier also you attended, and I think you will be easily able to recall this conversion through this particular discussion. चलिए next हम बात करते हैं बच्चों ideal gas. This equation is very, very important. PV equal to MRT, where P is the absolute pressure, V is the volume in meter cube, M is the mass in kg, R is the characteristic gas constant, and T is the temperature. Everybody knows actually about this equation, but R, you need to put R, which is actually a characteristic gas constant. It is nothing but universal gas constant divided by molecular weight. Okay. So in a particular chamber, if you are having a gas which is actually ideal gas, suppose you are having methane, or suppose you are having argon, or any particular gas you are having. So if you want to find out the mass of that gas in a container, if you know the absolute pressure of the gas inside that, you know the volume of that container. So M is the mass of that gas into the chamber. R is the characteristic gas constant of that gas, that you will be easily able to find out when you will divide the universal gas constant divided by the molecular weight. So universal gas constant is 8.314 kilojoule per kilomole Kelvin. If you will divide it by a molecular weight of that gas, you will be easily able to get this characteristic gas constant. तो इसको यूज करना, ध्यान रखना, what are the different terms in that ideal gas equation. चलिए उसके बाद हम बात करते हैं बच्चों. This is another equation, PV equal to NR bar T. You can write that ideal gas equation in this term also. ठीक है. तो work heat, both are not the properties. Work and heat both are known as what? They are known as transient property. They are known as boundaries phenomena, because heat and work we cannot define at a point. Okay. Energy we can define, like suppose you know energy is a property, we can define energy at a particular point, but work heat, they are not the property, we cannot define work and heat at a particular point. Okay, so they are the path function and they are known as what? They are known as boundaries phenomena. चलिए तो वर्क को हम फाइंड आउट करते हैं by taking the area under the curve projected under the curve on PV diagram projected on the volume axis. So the area under that curve on PV diagram and projected on the volume axis, that is going to give you the work in case of closed system. Similarly, on TS diagram, if you will take the area under the curve on TS diagram projected on the temperature axis, that is going to projected on the entropy axis, that is going to give you what? Heat transfer. Okay, dq equal to what, guys? You know, dq equal to Tds. Okay, so the area under the curve on a temperature versus entropy diagram, that gives us heat transfer. So these two things are very important for in thermodynamics. So these are the different representation for various processes: constant pressure, constant temperature, isentropic. Okay, and then you have anything constant volume process also. So how to represent various processes on PV diagram? This is actually a case of expansion and this is a case of compression. इसमें सबसे important चीज क्या है जो आपको याद रखनी चाहिए? The slope of adiabatic is more as compared to the slope of isothermal and I say polytropic. तो adiabatic का slope क्या होता है बच्चों? This is maximum slope. Okay, here also you can observe this is adiabatic, reversible adiabatic, and this is what isothermal, and in between you are having polytropic. So the slope of adiabatic is maximum. Okay, out of these three. बट वॉल्यूम का क्या होगा? वॉल्यूम स्लोप इज इनफाइनाइट. यू नो वॉल्यूम का स्लोप क्या है? इनफाइनाइट. कांस्टेंट वॉल्यूम, द वॉल्यूम इज नॉट गोइंग टू चेंज, सो यू विल हैव ए वर्टिकल लाइन, इनफाइनाइट स्लोप, एंड फॉर कांस्टेंट प्रेशर यू विल हैव ए हॉरिजॉन्टल लाइन. बट आउट ऑफ दीस थ्री द स्लोप ऑफ रिवर्सिबल एडियाबैटिक इज हाईएस्ट. चलिए नेक्स्ट हम बात करते हैं Cp माइनस Cv. वेरी इंपॉर्टेंट रिलेशनशिप. Cp is known as specific heat at constant pressure. Cv is known as specific heat at constant volume. Amount of heat required to raise the temperature of a unit mass of a substance by unit degree Celsius, that is known as specific heat. तो ये याद रखना वैल्यूज. एयर के लिए कितना होता है Cp, एयर के लिए Cv कितना होता है? These are the SI units guys, जूल पर kg केल्विन. ठीक है. This is molecular weight for air. तो ये बहुत इंपॉर्टेंट चीजें जो आपको याद रखनी चाहिए. गामा वैल्यू फॉर एयर इज 1.4 and these are the Cp and Cv relationship for okay ideal gas. Cp equal to gamma R by gamma minus 1 and Cv equal to R by gamma minus 1. This equation is also going to help you a lot. चलिए, तो how to represent the slope of isothermal process on PV diagram? So minus P by V is the slope of isothermal process on PV diagram, and gamma times slope of isothermal, that is the slope of adiabatic. Reversible adiabatic slope, I already mentioned, it is more than the slope of isothermal and polytropic. Why? Because gamma is more than N. N generally for general polytropic, N value we take greater than 1, less than gamma. So the slope of adiabatic, reversible adiabatic is more. ठीक है, तो ये आप ध्यान रखेंगे. एडियाबैटिक स्लोप इज गामा टाइम्स ऑफ द आइसोथर्मल स्लोप. ठीक है. हीट ट्रांसफर वी रिप्रेजेंट Q इक्वल टू MC dt. ठीक है, ये वही डिस्कशन है. Cp वैल्यू, साइन कन्वेंशन for heat and work, these are also another very simple and important thing. Generally the sign convention which we take in thermodynamics, work done on the system negative, work done by the system positive, heat added to the system positive, heat rejected by the system negative. These are all about the sign convention. How to write the Cp polytropic? Specific heat for the polytropic process, Cp polytropic is nothing but N minus gamma by N minus 1 into Cv, where N is known as polytropic index. So N value is greater than 1, less than gamma. Okay, dq polytropic is nothing but gamma minus N divided by gamma minus 1 into dw polytropic. And what is dw polytropic? It is P1 V1 minus P2 V2 by N minus 1. Chaliye, so this is first law of thermodynamics guys. You know, cyclic integration of heat equal to cyclic integration of work, or net heat transfer equal to work transfer. This is applicable to any cycle, whether you are having a reversible cycle or irreversible cycle. ठीक है. Chali. At the end, Sahil, I will tell you like from where you can download this particular file. On YourPedia website, guys, you will get the link to download. If you will go to our website, you will get the link. So this is first law of thermodynamics, guys. Again, for any process, dq equal to dE plus dW. This is known as first law of thermodynamics for any process, reversible, irreversible, anyone. But if you will replace this dE by du, this you can say it for what? काइनेटिक एंड पोटेंशियल एनर्जी चेंजेस. इसमें हम क्या कर रहे हैं? काइनेटिक एंड पोटेंशियल एनर्जी चेंजेस को हम क्या कर रहे हैं? नेग्लेक्ट कर रहे हैं. दिस इवन यू कैन राइट फॉर ओपन सिस्टम आल्सो. dq इक्वल टू dE प्लस dW. दिस यू कैन राइट फॉर ओपन सिस्टम आल्सो गाइस. सो एनी सिस्टम, any process, dq equal to dE plus dW. This is for any system, any process. But if you will neglect the kinetic and potential energy changes, if you will consider a kind of stationary system, then you will have equation dq equal to du plus dW. So this is applicable to closed system now, only for closed system, but upper one is applicable to close, open, both. Any process, reversible, irreversible. So if you will replace here dW equal to pdV, then this equation is applicable to closed system, reversible. Why? Because dW we are writing it with pdV. Got the idea, guys? So this is applicable to reversible process, closed system. This is any process, closed system. This is any process, any system. Got the idea? So these three equations you need to segregate, which we can apply and where we can apply. Okay. चलिए, so these are the different processes, guys. Constant volume, constant pressure, constant temperature, adiabatic and polyotropic. So constant volume, heat transfer, change in internal energy, that is known as heat transfer. Work transfer equal to 0, and the Gay-Lucas law, which we can write for a constant volume process, that is also you need to know. P volume constant. So for an ideal gas, if you are having a fixed mass of an ideal gas at constant volume, the ratio of P by T equal to constant, means P1 by P2 equal to T1 by T2. Similarly, for constant pressure, you can apply Charles law. For constant temperature, you can apply Boyle's law. Okay, constant pressure, change in heat transfer equal to change in enthalpy, work transfer equal to P V2 minus V1. Similarly, for constant temperature, heat transfer equal to work transfer, and the work transfer equal to P1 V1 ln of V2 by V1 or MRT ln P1 by P2. So these are the simple formulation, guys. I hope somewhere you studied. ठीक है, तो एक बार देख लो इनको so that you will be able to recall. अभी इस टाइम पे याद नहीं करना इन सब चीजों को, because that is not this time I hope this is not possible actually to recall, to remember करना तो possible ही है, but yes, easily you can recall. If somewhere earlier you studied these formulas, then easily you will be able to recall. तो अभी आपको recall ही करना है बच्चों, कूल होके बैठना है, आपको रिकॉल करना है ये सब फार्मूलास. ठीक है, तो पॉलीट्रोपिक प्रोसेस के लिए सेम, हाउ टू राइट हीट ट्रांसफर, हाउ टू राइट वर्क ट्रांसफर. एंथैल्पी क्या होता है बच्चों? एंथैल्पी इज नोन एज द एनर्जी कंटेन्ड बाय फ्लूइड इन ओपन सिस्टम, बिकॉज व्हेन ए फ्लूइड इज देयर इन ए ओपन सिस्टम, it is having some kind of internal energy also, and also with that internal energy it is having some kind of flow energy also, which is known as flow work. So the sum of internal energy plus flow work, that is known as enthalpy, or simply you can say it is the energy contained by the fluid in open system. Internal energy is the energy contained by a fluid in closed system, because in closed system the fluid is not moving, because there is no mass transfer in the closed system, only heat can enter and heat can go out of the control volume या कंट्रोल मास, व्हाट यू कैन से, सिस्टम से हीट ही जा सकता है. तो दिस इज एंथैल्पी गाइस. हाउ वी कैन राइट वर्क फॉर ए ओपन सिस्टम? वर्क इक्वल टू माइनस VdP, neglecting the kinetic and potential energy changes. You know guys, sometimes student ask कि sir this VdP, I observed कि isentropic work for a open system or compressor, we can write something like this also. Yes, you can write for compressor also, this is W compressor. ठीक है, तो कंप्रेसर क्या है? कंप्रेसर इज नॉट ए काइंड ऑफ क्लोज सिस्टम, इट इज अ काइंड ऑफ ओपन सिस्टम. सो फॉर W compressor, if you are considering isentropic compression, then you need to write gamma by gamma minus 1 into P1 V1 minus P2 V2, and that I am getting from minus integration VdP only. So for a reversible adiabatic process, PV की power gamma equal to constant, V की power gamma equal to C by P. Okay, yeah, V equal to this. So if you will put this value here, you will get this important expression. So this is for a open system, W isentropic for a open system. ठीक है, चलिए नेक्स्ट हम बात करते हैं बच्चों इसके बाद फ्री एक्सपेंशन. बहुत बार गेट में यहां से क्वेश्चन पूछा जाता है कि इफ यू आर हैविंग ए काइंड ऑफ फ्री एक्सपेंशन केस, हाउ टू फाइंड आउट एंट्रोपी चेंज इन फ्री एक्सपेंशन. Okay, you know, free expansion, the gas is going to expand against vacuum, so there is no work transfer. In free expansion, no work transfer. Initial internal energy equal to final internal energy, initial temperature equal to final temperature, initial enthalpy equal to final enthalpy. ठीक है, तो फ्लो वर्क क्या होता है? that already I discussed with you. ठीक है, चलिए स्टडी फ्लो का मतलब क्या होता है बच्चों? स्टडी फ्लो मींस there is no accumulation of energy inside the control volume. Whatever energy is entering into the control volume, the same is leaving out of the control volume. Energy in equal to energy out, mass in equal to mass out, or what you can say, the system, the control volume is in some kind of steady state. यस आकाश, बिल्कुल खत्म कर पाएंगे, 2 घंटे में बिल्कुल खत्म कर पाएंगे. सो दिस इज स्टडी फ्लो एनर्जी इक्वेशन, and in this equation guys, lots of students actually they make some kind of mistake while using this equation. So you need to be very much aware about the different conversion. When you are putting this enthalpy in kilojoule per kg, so you need to divide it this specific kinetic energy by 1000 so that units will be balanced. तो एक बार यूनिट देख लेना, अप्लाई करते हुए you need to be aware about units. Okay, so you are putting this in kilojoule, kilowatt, kilojoule per kg या joule per kg, or you are putting this value in kilowatt. Okay, so equation is same, all these equations are same, these are steady flow energy equation only, but in all these equations, different equations, I'm using different units. Okay, तो ये एक बार देख लेना so that you will be able to put all those terms effectively and you will get the right answer. चलिए एप्लीकेशन क्या है बच्चों? स्टडी फ्लो एनर्जी इक्वेशन we can use for nozzle also, diffuser also, we can use it for turbine, compressor, throttling, heat exchanger. Okay, so there are so many devices in which we can realize the steady flow. ठीक है, तो steady flow होगा, so definitely in that case we can apply steady flow energy equation. तो एक बार ये equation देख लो, which actually we got from steady flow energy equation only based on some assumption. तो ये assumptions हैं nozzle के लिए, diffuser के लिए, turbine के लिए. Based on that easily we can develop these kind of equations. ठीक है, चलिए अनस्टडी फ्लो का मतलब क्या होता है बच्चों? अनस्टडी फ्लो मींस देयर इज सम काइंड ऑफ एक्यूमुलेशन ऑफ मास और एनर्जी. तो अनस्टडी फ्लो में दिस इज द एनर्जी मास बैलेंस इक्वेशन, दिस इज द एनर्जी बैलेंस इक्वेशन फॉर ए अनस्टडी सिस्टम. तो वहां पे इंटरनल एनर्जी ये हो जाएगा. इस केस में जो सबसे इंपॉर्टेंट फार्मूला जो आपसे पूछता है, लाइक व्हेन यू आर फिलिंग ए टैंक, ओके, In that tank filling, what is the final temperature? So the final temperature is equal to gamma times of the initial temperature. That derivation also in front of you, how we got this particular formula. But ये एक बार याद कर लेना, यहाँ से एक बार गेट में बहुत बार क्वेश्चन पूछता है वो, ठीक है, बहुत बार क्वेश्चन पूछता है, तो कंटेंट फॉर दिस टाइप ऑफ क्वेश्चन विल बी वेरी मच लेंथी, हाई, आपको लगेगा कि बहुत डिफिकल्ट क्वेश्चन है, but very easily you will be able to solve those questions. Okay, related to filling of tank or emptying of a tank using these mass balance and energy balance equation for a these kind of unsteady state system, you can derive these formulas. ठीक है, बाकी इसको याद रखना, फाइनल टेम्परेचर T2 इक्वल टू गामा टाइम्स ऑफ द इनिशियल टेम्परेचर. चलिए उसके बाद हम बात करते हैं सेकंड लॉ की. मेरे ख्याल से अभी ये डिस्कशन तो रिक्वायर्ड नहीं है. व्हाट आर दीज ओस्टवाल्ड स्टेटमेंट्स, केल्विन प्लैंक स्टेटमेंट क्या है, क्लोजियर स्टेटमेंट्स क्या है. ओके, तो ठीक है, मैं सीधा आता हूं यहाँ पे. रिवर्सिबल प्रोसेस के लिए रिवर्सिबल हीट इंजन, दिस इज द एक्सप्रेशन फॉर द एफिशिएंसी 1 minus T lower by T higher. For heat pump, this is the expression for a COP of a reversible heat pump, T higher by T higher minus T lower, and this is the expression for COP of a reversible refrigerator, T lower by T higher minus T lower. And if heat pump and refrigerator, they are operating between same temperature limit, the COP of heat pump equal to 1 plus COP of refrigerator. तो ये वाले formulas अपने को बहुत ज्यादा हेल्प करते हैं बच्चों in second law of thermodynamics. So you need to be very much comfortable, very much aware about these formulas, कैसे इनको यूज करना है. कार्नोट थ्योरम का क्या कंक्लूजन है, ठीक है, ये भी आप देख सकते हो, एक बार रीड करते रहना मेरे साथ, साथ साथ पढ़ते रहना. चलिए, हीट पंप, एंड दिस इज वेरी वेरी इंपॉर्टेंट गाइस, सेकंड लॉ में यहां से क्वेश्चन आता ही आता है हर बार. थर्मोडायनेमिक टेम्परेचर स्केल Q1 by Q2 equal to T1 by T2. दिस इज एप्लीकेबल फॉर एनी रिवर्सिबल साइकिल. रिवर्सिबल, ठीक है, इसको आप जब अप्लाई करोगे, दिस इज वैलिड फॉर रिवर्सिबल ओनली. अभी इसको इरिवर्सिबल पे मत लगा देना. So if you are having any reversible heat pump engine, definitely you can apply this equation Q1 by Q2 equal to T1 by T2. Okay, because you know Clausius inequality, cyclic integration of dq by t, that is equal to 0 for a reversible cycle, less than 0 for a irreversible cycle, greater than 0 is what, that is a what, इसको हम क्या बोलेंगे, violation. ठीक है, so cyclic integration dq by t greater than 0, that is a violation of second law of thermodynamics. Violation हो जाएगा ये, ठीक है. तो इक्वल टू है तो रिवर्सिबल है, लेस देन है तो क्या है, इरिवर्सिबल है, एंड इफ इट इज ग्रेटर देन 0, दैट इज अ वायलेशन. सो सम टाइम ही आस्क यू in GATE we get about some kind of question in which he asks you like whether that particular kind of heat engine refrigerator is possible or not. So if you want to check that like that engine is practically possible or not, you need to check what, you need to check Clausius inequality only. So if you are getting cyclic integration dq by t equal to 0, means the engine, the refrigerator or heat pump which he has given you, that is a kind of reversible. Okay, but if you are getting cyclic integration dq by t less than 0, means that engine or that particular device is irreversible. But if you are getting cyclic integration dq by t greater than 0, it means that device is impractical, means it is not possible, because that is a violation of second law of thermodynamics. तो इसको आप देख लेना, बहुत इंपॉर्टेंट है, यहां से क्वेश्चन पूछता है वो आपसे. चलिए, तो इसके बाद बात आती है बच्चों एंट्रोपी की. यू नो एंट्रोपी विच इज एक्चुअली ए प्रॉपर्टी and measure of disorder, okay, measure of unavailability, ds equal to dq by t. ठीक है, तो कैसे हम इसको निकालते हैं एंट्रोपी को फॉर सिस्टम, फॉर आइडियल गैस, दैट यू नीड टू नो. ठीक है, तो एंट्रोपी जनरेशन क्या होता है बच्चों, एंट्रोपी जनरेशन इज नथिंग बट एंट्रोपी चेंज ऑफ सिस्टम प्लस सराउंडिंग. ठीक है, सिस्टम प्लस सराउंडिंग, एंट्रोपी चेंज ऑफ द सराउंडिंग विल बी 0 if you are having a adiabatic system, if there is no heat transfer to the surrounding, entropy change of surrounding will be 0. in case of throttling, in case of mixing, एंट्रोपी चेंज सराउंडिंग का क्या होता है बच्चों, 0 होता है. सो सिस्टम का एंट्रोपी इज ऑलवेज गोइंग टू इंक्रीज इन ऑल दोस काइंड ऑफ थ्रोटलिंग एंड मिक्सिंग प्रोसेसेस. चलिए, सो दीज आर द टू टीडीएस इक्वेशन गाइस व्हिच आर एप्लीकेबल टू एनी प्रोसेस. टीडीएस इक्वेशन, टीडीएस इक्वल टू du प्लस pdv, TDS equal to DH minus UDP, these are applicable to any process, whether you are having reversible process or irreversible process. ठीक है, चलिए, why these are applicable guys, because in these terms, in these equations we are having all properties, ds, du, v, sh, p, all are properties, and change in properties will always be same whether you are having a reversible process or irreversible process. Why? Because properties are point function, they are independent of the path. So if you are having two processes, reversible, irreversible, between same states, the change in properties will be same, and the change in properties in a complete cycle will always be 0, because entropies are point function. In a cycle, in a complete cycle, the point from where you are starting, you are ending at the same point. So change in property in a complete cycle will be 0. So entropy generation is nothing but entropy change of the universe, which is entropy change of system plus surrounding, and this will always be greater than equal to 0. This is less than 0 is impossible. ठीक है, तो एंट्रोपी चेंज थर्मल एनर्जी रिजर्वायर के लिए कैसे लिखते हैं? फॉर सोर्स इट इज माइनस Q1 by T1, फॉर सिंक इट इज Q2 by T2. Why? Because in sink we are transferring heat. So when we are transferring heat into the sink, the entropy of the sink is going to increase. When you are taking heat from the source, so the source entropy is going to decrease, so it is minus Q1 by T1. Entropy change for finite body means any kind of liquid or solid. SF, S final minus S initial is equal to MC ln T final by T initial. This is the formula to find out entropy change for any kind of finite body. तो देख लेना एक बार इसको. Properties of pure substance. मेरे ख्याल से आप कंफर्टेबल होंगे टू फाइंड आउट हाउ टू फाइंड आउट एंथैल्पी एंट्रोपी इन वेरियस रीजन. ठीक है, तो एक बार मैं आपको दिखा देता हूं सो दैट यू विल बी एबल टू रिकॉल. ठीक है, तो दिस इज योर सैचुरेटेड लिक्विड लाइन जहां पे ड्राइनेस फ्रिक्शन इज 0. दिस इज योर सैचुरेटेड वेपर लाइन जहां पे x क्या होता है आपका 1, एंड इन बिटवीन the x is going to increase from this 0 to 1. So this is actually a wet region. Wet region में हम कैसे लिखते हैं बच्चों? enthalpy and entropy, that you need idea that you need to have. Enthalpy in the wet region, entropy in the wet region, and internal energy in the wet region. H equal to HF plus X HFG, S equal to SF plus X SFG, and U equal to UF plus UFG. Similarly, for specific volume also you can write same kind of formulation in the wet region. ठीक है, चलिए V equal to VF plus X VFG. तो एंट्रोपी कैसे लिखते हैं हम वेरियस पॉइंट्स पे? लाइक इफ यू वांट टू फाइंड आउट एंट्रोपी इन द सुपरहीटेड रीजन, दैट इज इक्वल टू SF मींस दिस इन द सबकूल्ड रीजन. गाइस, यहां पे अगर आपको सबकूल्ड रीजन में इफ यू वांट टू राइट द एंट्रोपी, सो दिस S1 हियर, दिस इज इक्वल टू SF माइनस SF माइनस S1. तो इसको क्या लिख सकता हूं? दिस आई कैन राइट इट एज CLN T saturation by T subcooled. So this is known as temperature subcooled, and this is known as temperature T saturation. This is known as T superheated, and this temperature both are same. So in this case we are having three temperatures. This T3 is T saturation. इसे मैं क्या बोल सकता हूँ? T superheated. This I can say this is too superheated. Okay. This is T subcooled. Okay. And this one is T saturation. इसे मैं क्या बोल रहा हूँ? T saturation. ठीक है. So this is how you can write entropy in what? Subcooled region. Same how to write entropy in the superheated region. This is the kind of formula which you can use. Sg plus Cp ln T superheated by T saturation. This formula you can use to find out entropy in the superheated region. ठीक है, चलिए. So guys, this PV diagram for water, PV diagram. Okay, a PV diagram में क्या होता है? Solid region, solid plus liquid. What idea you need to have, guys? On PV diagram we are having a triple point line. On PT diagram we are having a triple point. तो कई बार वो आपसे क्वेश्चन पूछता है. यहाँ पे क्वेश्चन क्या पूछता है? Like suppose last time they asked some kind of question, and even in NPTEL assignments also we found some kind of question. If the temperature is more than triple point temperature, can we have some kind of solid? Can you have some solid if the temperature is more than triple point temperature for water? So if you are having water, so this is the curve for water, and if the temperature is more than triple point temperature, then you are not going to have solid above that. Okay, so based on that, if you able to draw this PT diagram, then easily you can answer some kind of objective questions. So similarly, if you are having pressure more than this PTP, can you have solid? Is it possible to have solid if the pressure is more than triple point pressure? Yes, it is possible. How? Guys, this is the region which is also a kind of solid region. ये पूरा region क्या है बच्चों? This entire region is a solid region. This entire is the solid region. So for solid, you can have solid even above PTP, but above TTP you cannot have solid. Got that idea? So these type of questions they can ask you. So you need to be very much aware about this PT diagram and PV diagram. तो based on that they can ask you some question. ठीक है, तो PT और PV diagram आपको पता होना चाहिए. ठीक है, ट्रिपल पॉइंट कितना होता है वाटर के लिए? द ट्रिपल पॉइंट इज 0.01 डिग्री सेल्सियस और 273.16 केल्विन, और द ट्रिपल पॉइंट प्रेशर इज 611 पास्कल और 0.611 किलो पास्कल. तो ट्रिपल पॉइंट टेम्परेचर बोथ यू नीड टू नो. ठीक है, डिग्री ऑफ फ्रीडम एट ट्रिपल पॉइंट इज व्हाट? 0. ट्रिपल पॉइंट पे डिग्री ऑफ फ्रीडम क्या होता है बच्चों? 0 होता है. चलिए, तो मिक्सिंग के लिए लाइक सपोज इफ यू आर हैविंग ए मिक्सचर, डिफरेंट सब्सटेंसेस का आपके पास क्या है? मिक्सचर है. सो हाउ टू फाइंड आउट इक्विवेलेंट कैरेक्टरिस्टिक गैस कांस्टेंट, इक्विवेलेंट स्पेसिफिक हीट, इक्विवेलेंट सीवी फॉर ए मिक्सचर. तो ये ध्यान रखना बच्चों, अगर आपके पास कोई मिक्सचर ऑफ गैसेस है तो उस मिक्सचर ऑफ गैसेस के लिए हाउ टू फाइंड आउट इक्विवेलेंट सीपी सीवी एंड इक्विवेलेंट कैरेक्टरिस्टिक गैस कांस्टेंट. चलिए, अवेलेबल एनर्जी क्या होता है बच्चों? मैक्सिमम वर्क विच यू कैन ऑब्टेन बाय ब्रिंगिंग द सिस्टम टू द डेड स्टेट, दैट इज नोन एज अवेलेबल एनर्जी, एंड द लॉस ऑफ अवेलेबल एनर्जी इज नोन एज व्हाट? Irreversibility or exergy destruction. So you know why is available energy will be high if you're having the source at high temperature. So if you're having heat available at high temperature, the available energy will be more. But if the heat is available to us at low temperature, then available energy will be less. तो available energy हम कैसे निकालते हैं? This formula you can learn. And how we can find out the loss or increase in unavailable energy, loss in available energy or increase in unavailable energy if you are changing the source temperature. When heat is added to a finite temperature difference, so heat added to a finite temperature difference, what is the loss in available energy? That easily you can find out using this direct formula. Okay, so you can try to recall these kind of formulas. Availability, these are the availability function, guys. You know, availability function for open system, availability function for closed system. What is availability? The maximum work which you can obtain between two fixed states. Okay, that is known as availability. So availability function कैसे निकालते हैं हम? This is availability function for closed system, u minus t naught s plus p naught v, and this is the availability function for open system, h minus t naught s. ठीक है, चलिए. This is irreversibility, the loss in work potential, W max minus W actual. This is known as irreversibility. बहुत इंपॉर्टेंट है गेट के लिए. यहां से बहुत सारे क्वेश्चन वो आपसे पूछता है बच्चों, तो इसको एक बार समझ लेना अच्छे से. How to find out irreversibility? W max minus W actual, T naught delta S universe, that is also known as irreversibility, Gauss-Rodolphe equation. And what is delta S universe? Delta S system plus surrounding. Gibbs function, which gives us the maximum work for an open system. Helmholtz function which gives us the work for a closed system. ठीक है, तो चलिए इसके बाद हम बात करते हैं बच्चों थोड़ा सा thermodynamic relations की. आजकल you know nowadays they are asking much questions from these kind of thermodynamic relationships, so you need to be very much comfortable about finding out all these correlations. चार जो मैक्सवेल रिलेशंस है ये हम यूज करते हैं. दिस इज अ शॉर्टकट टू गेट दीज फोर कोरिलेशंस, एसपीवीटी. ठीक है, तो मेरे ख्याल से आपने इसको जरूर यूज किया होगा. Okay, so these are the four relations, guys, Maxwell relationship, which you need to understand. Cp minus Cv, this equation, another very important equation, guys. Cp minus Cv, this is equal to minus T del V by del T at constant P square into del P by del V at constant temperature. And always Cp is greater than Cv. So ये relations हैं, याद रखना, बहुत important relationship है, guys. For beta, isobaric thermal expansion coefficient, volume expansivity, the change in volume per unit change in temperature per unit volume at constant pressure, that is known as isobaric volume expansion coefficient, isothermal compressibility. So these are the two important relationship for beta and K. Okay, this is known as Mayer's equation. Cp minus Cv, this is equal to Tv beta square by Kt. So this equation you can use to find out the difference between Cp and Cv. किसके लिए? For any kind of gas. ठीक है, अब यहां पे if you are having temperature equal to 0 Kelvin, then Cp/Cv will become same. So at absolute 0 Kelvin, okay, at 0 Kelvin the Cp/Cv value will be same. Why? Because if you put it here 0, then this entire term becomes 0. चलिए, तो इसमें आपको नेक्स्ट क्या देखना है? Joule Thomson coefficient. What is Joule Thomson coefficient? It is the slope of the isenthalpic curve on TP diagram. So TP diagram पे जो isenthalpic curve का जो slope होता है, that is known as Joule Thomson coefficient. So if you are having the positive Joule Thomson coefficient, positive slope, then you will have what? वहां पे आपको क्या मिलेगा? You will have a kind of cooling effect. And if you are having negative Joule Thomson coefficient, you will have a heating effect. Okay. For most of the gases, we are having positive Joule Thomson coefficient, like for nitrogen, oxygen. That's why when we carry out throttling of those gases at atmospheric temperature, we get drop in temperature. But for some gases like helium, neon, the Joule Thomson coefficient is negative. So if you will carry out throttling of those gases at atmospheric condition, we will not get drop in temperature. Even we will get increase in temperature. ठीक है, तो the maximum inversion temperature, that point where this inversion curve cuts the temperature axis, that is known as maximum inversion temperature. So this maximum inversion temperature is required to be very high as compared to our operating temperature. So the temperature at which you are carrying out throttling, so if the maximum inversion temperature is more than that, means the operating condition will lie in this region. Operating condition कहां पे lie करेंगे बच्चों? In this region. But for a particular gas, if the maximum inversion temperature is very low, okay, it is lower than the operating temperature, then the operating condition will lie in what? It lie in the right of this inversion curve. And if you're lying right of the inversion curve, and then if you are carrying out throttling, means you are decreasing the pressure, then what, there are chances you will get heating effect. Okay, but if you are in this region, if you are in the left of this region, then surely if you will carry out the throttling, you will move in this direction only, means the temperature is always going to decrease if you are left of this inversion curve. Means if the operating temperature is lower than the maximum inversion temperature, we will lie left of this inversion curve. Okay, so the concept is what, the maximum inversion temperature for a particular gas, if it is very high, you will get drop in temperature, but if the maximum inversion temperature for a gas is lower, then you will get increase in temperature. ठीक है, तो म्यू जेटी के लिए ये सब एनालिसिस है, मैंने आपको बता ही दिया है. क्लोजियस क्लैपेरॉन इक्वेशन गाइस, अनदर वेरी वेरी इंपॉर्टेंट इक्वेशन, क्लोजियस क्लैपेरॉन इक्वेशन. इसको हम यूज करते हैं बच्चों टू फाइंड आउट व्हाट, द प्रेशर. Okay, partial pressure you can find out, pressure of a gas, P saturation or T saturation. If the P saturation at 2 points is given to you, you can find out T saturation. Okay, so it depends. He is going to give you the latent heat. Okay, one temperature he is going to provide you R also. Then based on that information, easily you will be able to find out pressure. Okay, so P to P1, T to T1, he is going to provide 3 out of these 4. He is going to provide you 3. So last remaining 4th, easily you will be able to obtain using this equation. So this equation generally we get after integration. This equation, इस equation को अगर मैं integrate कर देता हूं बच्चों, so you will get this equation. बहुत important equation है, इसको use करना और इसको समझना. Okay, so ln of P2 by P1 equal to minus HFG, which is actually a latent heat. It may be latent heat of vaporization also, and it may be latent heat of fusion also. जो भी case दे दे. Okay, if he is giving you the latent heat of fusion case, vaporization case, sublimation case, any case you can apply. Okay, so ln of P2 by P1 minus HFG by R into 1 by T2 minus 1 by T1. Very very important relationship guys. तो इसको समझ लेना और इससे related questions आपने जरूर practice किए होंगे. चलिए, so another TDS equation guys. TDS equation को हम ऐसे भी लिख सकते हैं. These are different forms of TDS equation. तो इसको याद रखना. ये बहुत इंपॉर्टेंट रिलेशन है बच्चों, एंड आई होप कि दिस टाइम दे आर गोइंग टू आस्क यू सम क्वेश्चन, हाउ टू फाइंड आउट इंटरनल एनर्जी एंड एंथैल्पी फॉर ए रियल गैस. सो दीज आर द एक्सप्रेशन फॉर फाइंडिंग आउट चेंज इन इंटरनल एनर्जी, चेंज इन एंथैल्पी फॉर ए रियल गैस. यू नो गाइस, दिस टर्म will be 0 for ideal gas, because for ideal gas the change in internal energy is Cp dt. Similarly this term will be 0 for a ideal gas. Why? Because change in enthalpy for a ideal gas is Cp dt. ठीक है, तो how to find out change in internal energy, change in enthalpy for a real gas, means he is going to give you some kind of equation. It may be van der Waals equation or it may be any kind of equation. So if he is giving you some equation and then he is asking you to find out the change in internal energy, change in enthalpy for that gas, so for that gas you need to use this equation, and the equation which is given to you, based on that equation guys, you need to obtain this del P by del T at constant V, del V by del T at constant T. You will get the answer. ठीक है, similarly this is mu JT guys. कई बार आपसे वो mu JT पूछ लेता है बच्चों. So mu JT Joule Thomson coefficient, this is very very important relationship guys, जो हम यूज करते हैं mu JT निकालने के लिए. ठीक है, तो इसको भी आप याद कर लेना, समझ लेना. mu JT Joule Thomson coefficient, del T by del P at constant enthalpy, it is 1 by Cp T del V by del T at constant pressure minus V. ठीक है, तो मिक्सिंग में हाउ टू राइट द मास बैलेंस, हाउ टू राइट द एनर्जी बैलेंस. ठीक है, मिक्सिंग के केस के लिए हम क्या करते हैं, कैसे हम एनर्जी बैलेंस लिखते हैं, बिकॉज इफ आफ्टर मिक्सिंग, सपोज इफ यू वांट टू फाइंड आउट द फाइनल टेम्परेचर, तो सपोज इट इज अ मिक्सिंग ऑफ आइडियल गैसेस. अगर आइडियल गैसेस का मिक्सिंग होगा, सो M1 Cp1 T1 हो जाएगा प्लस M2 डॉट Cp2 T2 हो जाएगा. ओके, इक्वल टू M3 डॉट Cp3 T3 हो जाएगा. ठीक है, तो यू कैन फाइंड आउट दिस T3. अगर सेम गैसेस है, इफ दीज आर द सेम गैसेस, देन Cp Cp2 Cp3 all will be same. But if these are the different gases, then you need to find out the Cp1 Cp2, and this Cp3 you will get from what guys, ये कहां से आ जाएगा, this you will get from the M1 Cp1 plus M2 Cp2 divided by M1 plus M2. ठीक है, यहां से क्या आ जाएगा आपका Cp3, इसको हम Cp3 भी बोल सकते हैं, और we can say this is Cp equivalent, Cp3 or Cp equivalent. So Cp3 or Cp equivalent you will get from this equation if these are the different gases. You are having mixing of different gases. तो different gases है, same gases है, you need to check. ठीक है, अगर same gases है, then Cp Cp will be cancel out, then you will have M1 T1 plus M2 T2 equal to M3 T3. So these are very very important equation guys for mixing case, how to write mass balance and energy balance. ठीक है, मिक्सिंग में दो केसेस और होते हैं, लाइक यू आर हैविंग ए मिक्सिंग इन ए काइंड ऑफ क्लोज्ड चेंबर. ठीक है, एडियाबैटिक चेंबर वो देता है बिकॉज मिक्सिंग इज अ वेरी काइंड ऑफ फास्ट प्रोसेस. सो इन दैट केस जनरली वी अज्यूम द प्रोसेस एज एडियाबैटिक. ठीक है, थ्रोटलिंग को, मिक्सिंग को हम क्या मानते हैं? थ्रोटलिंग क्या है? ऑल्दो इट इज a kind of slow process, but in throttling we assume the area of the surface is very negligible. That's why throttling we assume as a adiabatic. Mixing is a kind of fast process. Free expansion is also a fast process, and we assume mixing and free expansion also as a adiabatic process. तो इन केस के लिए how to write the final temperature, final pressure, तो ये फॉर्मूलाज आप देख लेना एक बार, ठीक है? बहुत इंपॉर्टेंट फॉर्मूलाज यहां से बन जाते हैं मिक्सिंग केस के लिए. सो दिस इज फर्स्ट केस, आई एम एज्यूमिंग सेम गैस इन टू डिफरेंट चैम्बर्स, ठीक है? तो इसमें एक डायरेक्ट शॉर्टकट बनता है जिसमें वो आपको केस देके रखता है. इफ यू आर हैविंग ए मिक्सिंग ऑफ gases at same temperature, same pressure, same volume, so these are the two gases, okay, same gas hai, different gas hai, these are the different gases, but they are at same temperature, means here temperature and here temperature is same, here pressure, here volume, and volume is same. So in that case the final temperature will also be same, but the final volume will be 2 times of the initial volume, and this is the formula to find out entropy generation. Okay, entropy change of the surrounding will be 0, so this is the entropy change of the system, and entropy change of system is going to give you the entropy generation because the entropy change of surrounding is 0. ठीक है, तो ये डायरेक्ट फॉर्मूला है जो आपको याद रखना चाहिए फॉर द मिक्सिंग ऑफ टू डिफरेंट गैसेस एट सेम टेम्परेचर एंड सेम प्रेशर. ठीक है बच्चों, चलिए, तो ये मैंने इंपॉर्टेंट केस लिखा है अज्यूमिंग n1 इक्वल टू n2. तो ऊपर वाला आप यूज करोगे, दीज गैसेस आर हैविंग डिफरेंट मासेस, डिफरेंट मोल्स. अगर इनके मोल्स भी सेम हो जाएंगे, सो यू कैन फर्दर रिड्यूस दिस फॉर्मूला टू दिस. ठीक है, सेम फॉर दिस केस आल्सो, हाउ टू फाइंड आउट एंट्रोपी जनरेशन. सराउंडिंग का 0 जगह फॉर फर्स्ट गैस, फॉर सेकंड गैस, इफ यू आर एबल टू फाइंड आउट एंट्रोपी चेंज, यू विल गेट एंट्रोपी जनरेशन. ठीक है, चलिए, कंप्रेसिबिलिटी बहुत इंपॉर्टेंट. आजकल वो यहां से क्वेश्चन पूछ रहे हैं बच्चों गेट में. कंप्रेसिबिलिटी फैक्टर Z आपको कैसे निकालना है? Z इज नथिंग बट इट इज आल्सो नोन एज गैस डेविएशन फैक्टर. ठीक है, सो एक्चुअल वॉल्यूम ऑफ ए गैस डिवाइड बाय आइडियल वॉल्यूम ऑफ ए गैस, दैट इज नोन एज कंप्रेसिबिलिटी फैक्टर. ठीक है, तो कंप्रेसिबिलिटी फैक्टर आइडियल गैस के लिए क्या होता है? 1 होता है. फॉर रियल गैस इट कैन बी ग्रेटर देन 1 और इट कैन बी लेस देन 1 आल्सो. ठीक है, कंप्रेसिबिलिटी फैक्टर, लाइक ये जो लाइन है, दिस इज द लाइन फॉर ए आइडियल गैस. कंप्रेसिबिलिटी फैक्टर Z इक्वल टू 1 किसके लिए बच्चों? आइडियल गैस के लिए. ओके, फॉर रियल गैस इट कैन बी ग्रेटर देन 1 और लेस देन 1. तो आपको एक चीज क्या समझना है, इफ यू आर हैविंग प्रेशर वेरी वेरी लेस देन 1, प्रेशर रेशो, और दिस इज नोन एज रिड्यूस्ड प्रेशर. इसे हम क्या बोलते हैं बच्चों? रिड्यूस्ड प्रेशर. सो इफ यू आर हैविंग रिड्यूस्ड प्रेशर very very less than 1, means the behavior will be very close to the ideal gas behavior. Reduced pressure is nothing but the pressure of a gas divided by the critical pressure of the gas. Similarly, the reduced temperature, which is known as the temperature of a gas divided by critical temperature. ठीक है, तो same for reduced temperature. If reduced temperature is very very high, it is greater than 2, except the reduced pressure is not very high. तो reduced pressure तो बहुत high नहीं होना चाहिए, but if the reduced temperature is very very reduced temperature is close to 2, then the behavior will be close to the ideal gas behavior. और यहां पे क्या था बच्चों? if the reduced pressure is less than 1, reduced pressure is very very less than 1, means you are somewhere here, आप इस रीजन में हैं. so in this region the behavior is also very close to the ideal gas behavior. in this region the behavior is close to the ideal gas behavior. तो ये जो है आपको याद रखना चाहिए. these are the two important conclusions. PR less than 1, PR greater than 2, but except PR not very high. ये except क्या होना चाहिए? PR not very high. ठीक है, नेक्स्ट कंक्लूजन क्या है? TR इक्वल टू 1, PR इक्वल टू 1 मींस क्लोज टू क्रिटिकल पॉइंट द डेविएशन विल बी वेरी हाई फ्रॉम द आइडियल गैस बिहेवियर. तो क्लोज टू क्रिटिकल पॉइंट द डेविएशन इज वेरी हाई. ठीक है, तो वहां पे जो आइडियल गैस बिहेवियर होगा, इट विल बी, यू विल बी वेरी फार अवे फ्रॉम द आइडियल गैस बिहेवियर. चलिए, नेक्स्ट हम बात करते हैं बच्चों आईसी इंजन की. आईसी इंजन से कुछ फॉर्मूलाज हैं जो डायरेक्टली आपको याद होने चाहिए, जैसे स्वेप्ट वॉल्यूम का फार्मूला. हाउ टू फाइंड आउट स्वेप्ट वॉल्यूम? the engine area pi by 4 d square piston area multiply by the swept stroke. okay, engine का stroke क्या होता है? L, that is known as, इसको हम क्या बोलते हैं? stroke length. so d is known as engine bore pi by 4 d square into L, that is going to give you swept volume. so swept volume, if you will multiply by the number of cylinder, you will get what? You will get the cubic capacity. the cubic capacity of an engine is nothing but the swept volume multiplied by number of cylinders. ठीक है, तो सीसी क्या होता है? Vs into N. तो ये बहुत सिंपल फॉर्मूलाज हैं जो हम यूज करते हैं. एक कन्वर्जन याद रखना, 1 लीटर इक्वल टू 1000 cc. so if he has given you the cc, then easily you can convert cc into what? meter cube. compression ratio, which is known as the what? the total volume divided by the clearance volume. ठीक है, तो ये आप याद रखना। कंप्रेशन रेशियो हम कैसे निकालते हैं, बहुत सिंपल चीजें हैं। हीट इनपुट, चलो ये ज्यादा डिस्कशन यहाँ पे रिक्वायर्ड नहीं है। दिस इज अनदर इंपॉर्टेंट फॉर्मूला गाइस। इंडिकेटेड थर्मल एफिशिएंसी क्या होती है? इंडिकेटेड पावर आउटपुट डिवाइड बाय हीट इनपुट। हीट इनपुट क्या होता है? मास ऑफ फ्यूल कंज्यूम्ड मल्टीप्लाई बाय कैलोरीफिक वैल्यू। ठीक है, सो दिस इज अनदर वेरी वेरी इंपॉर्टेंट फॉर्मूला टू फाइंड आउट इंडिकेटेड थर्मल एफिशिएंसी। हाउ वी कैन फाइंड आउट ब्रेक थर्मल एफिशिएंसी, दैट इज आल्सो इंपॉर्टेंट। ठीक है, मैकेनिकल एफिशिएंसी क्या होता है? बीपी बाय आईपी मल्टीप्लाई बाय 100, दिस इज योर ब्रेक थर्मल एफिशिएंसी। तो एफिशिएंसीज को एक बार सभी को देख लेना, हाउ टू फाइंड आउट इंडिकेटेड, ब्रेक थर्मल, मैकेनिकल एंड वॉल्यूमेट्रिक एफिशिएंसी। वॉल्यूमेट्रिक एफिशिएंसी में थोड़ा सा लफड़ा रहता है, कहां पे? कि जब वो आपको दे दे क्या कि यू आर हैविंग सम काइंड ऑफ 2 स्ट्रोक इंजन और 4 स्ट्रोक इंजन, तो वहां पे हम कैसे कन्वर्जन करते हैं, दैट आई हैव शोन यू हियर। ठीक है, तो नंबर ऑफ स्ट्रोक्स कितने हैं आपका, 2 स्ट्रोक्स है या 4 स्ट्रोक्स है, बेस्ड ऑन यू नीड टू पुट ऑल दोस थिंग्स हियर इन वॉल्यूमेट्रिक फॉर्मूला। ठीक है, बहुत डिटेल में बच्चों ये सारी चीजें हमने डिस्कस की है। मिहिर चेक कर लेना, चेक कर लेना थर्मोडायनामिक्स अगर आपको इजी लगता है, लाइक यू आर हैविंग ऑप्शन, तो दिस टाइम आई कैन नॉट से बिकॉज आई डोंट नो लाइक व्हाट यू प्रिपेयर्ड बेस्ट। ठीक है, अभी आपका लेवल थर्मोडायनामिक्स में कैसा है या फ्लूइड मैकेनिक्स में कैसा है, आई कैन नॉट से। सो यू नीड टू चेक, यू कैन चेक द क्वेश्चंस, एक्सी में चेक कर लेना। अगर थर्मो में आसान क्वेश्चन लग रहे हैं तो यू कैन गो फॉर थर्मोडायनामिक्स। मेरे ख्याल से थर्मो फिर भी बेटर रहता है एज कंपेयर टू फ्लूइड मैकेनिक्स। ठीक है, सो ये बहुत इंपॉर्टेंट फार्मूला जो हम यूज करते हैं, प्लान। ठीक है, indicated power equal to indicated mean effective pressure swept volume, because length into area, length of stroke into area, that is nothing but swept volume. So indicated mean effective pressure multiplied by swept volume into n by 60 into a into n, that is divided by 1000, that is going to give you indicated power. ठीक है, तो ये फॉर्मूला बहुत इंपॉर्टेंट है। सिमिलरली हाउ टू फाइंड आउट ब्रेक पावर, तो थोड़ा थोड़ा सा रिकॉल करते रहना बच्चों कि इंडिकेटिव पावर हम कैसे निकालते हैं, ब्रेक पावर हम कैसे निकालते हैं। इफ ही हैज प्रोवाइडेड यू सम इंफॉर्मेशन रिलेटेड टू इंडिकेटेड मीन इफेक्टिव प्रेशर एंड ब्रेक मीन इफेक्टिव प्रेशर। ब्रेक स्पेसिफिक फ्यूल कंजम्पशन क्या होता है बच्चों? इट इज मास ऑफ फ्यूल कंज्यूम्ड पर किलोवाट ऑफ द पावर प्रोड्यूस्ड। सो मास ऑफ फ्यूल कंज्यूम्ड in kg per hour divided by bp in kilowatt, that is going to give you break specific fuel consumption. Similarly, what is indicated specific fuel consumption? The mass of fuel consumed in kg per hour per kilowatt of the ip produced. So mass of fuel in kg per hour divided by ip, that is going to give you isfc, indicated specific fuel consumption. Equivalence ratio, okay, what's the value of equivalence ratio? That you need to check. चलिए, for stoichiometric air fuel ratio you will have phi equal to 1, for rich mixture you will have phi greater than 1, and for lean mixture you will have phi less than 1. ऑटो साइकिल है, बहुत कंफर्टेबल आप होने चाहिए इस टाइम पे ऑटो साइकिल को ड्रॉ करने के लिए। ऑटो साइकिल एफिशिएंसी 1 माइनस 1 बाय आर की पावर गामा माइनस 1। ठीक है, वेयर आर इज द कंप्रेशन रेशियो। ब्रेटन में भी एफिशिएंसी का एक्सप्रेशन सिमिलर होता है, बट वहां पे क्या होता है, आरपी की पावर गामा माइनस 1 बाय गामा होता है। यहाँ पे क्या होता है, आरपी। You know, Otto cycle and Brayton cycle both are having same efficiency. They are operating between same kind of temperature and pressure limits. Because यहाँ पे compression ratio क्या होता है, you know, this relationship T2 by T1 equal to, या T1 by T2 लिखता हूं मैं, so T2 by T1 equal to V1 by V2 की पावर गामा माइनस 1 equal to P2 by P1 की पावर गामा माइनस 1 by गामा। ठीक है, सो दिस इज नथिंग बट दिस इज आर की पावर गामा माइनस 1। सो आर की पावर गामा माइनस 1 इज नथिंग बट आर की पावर गामा माइनस 1 इज नथिंग बट आरपी की पावर गामा माइनस 1 बाय गामा। ठीक है, तो दोनों सेम होती है बच्चों। सो ब्रेटन साइकिल एंड ऑटो साइकिल दे आर हैविंग सेम एफिशिएंसीज इफ दे आर ऑपरेटिंग बिटवीन सेम टेंपरेचर लिमिट्स। ओके, सो फार्मूला याद रखना, मैं इसको क्यों बता रहा हूं, सो दैट यू विल बी एबल टू रिमेंबर। बच्चे कई बार गलत करते हैं, तो ऑटो में ये रखना, ब्रेटन में क्या हो जाएगा आपका 1 माइनस 1 बाय आरपी की पावर गामा माइनस 1 बाय गामा। तो आप सेग्रीगेट कर पाओ, दैट्स व्हाई पैरेलली आई एम डिस्कसिंग ऑटो साइकिल एफिशिएंसी आल्सो एंड ब्रेटन साइकिल आल्सो। ठीक है, गैस टरबाइन में जो हम साइकिल यूज करते हैं ब्रेटन साइकिल, तो वहां पे एफिशिएंसी, दैट इज आल्सो एयर स्टैंडर्ड साइकिल गाइस, तो वहां पे हम ये एक्सप्रेशन यूज करते हैं। चलिए, सो ड्यूअल साइकिल के लिए हाउ टू फाइंड आउट कट ऑफ रेशियो, एक्सपेंशन रेशियो, ड्यूअल साइकिल, तो ये भी आप देख लेना। कट ऑफ रेशियो के लिए ये बहुत इंपॉर्टेंट है, यहां से क्वेश्चन वो पूछता है कट ऑफ रेशियो निकालने के लिए। सो दिस इज वेरी वेरी इंपॉर्टेंट रिलेशनशिप गाइस टू फाइंड आउट कट ऑफ रेशियो। सो कट ऑफ रेशियो इक्वल टू 1 प्लस x by 100 into r minus 1. R is the compression ratio and x is the point where you are carrying out the cutoff. 5%, 10%, 15%. It is that percentage where you are cutting the what? where you are restricting the fuel injection. ठीक है, so if you are restricting the fuel injection after the 10% of the stroke, then this x will be 10%, means 10 by 100, तो ये आपका वो वैल्यू आ जाएगा. ठीक है, so this will be given to you कहां पे आप restrict कर रहे हैं इंजेक्शन को, and rho is the cutoff ratio, and with this relationship easily you can obtain cutoff ratio. ठीक है, तो इसको आप याद रखेंगे. चलिए नेक्स्ट हम बात करते हैं बच्चों. एक्सप्रेशन है आपका डीजल साइकिल के लिए एफिशिएंसी का एक्सप्रेशन. दिस इज द एक्सप्रेशन फॉर डीजल साइकिल एफिशिएंसी. चलिए, ये भी बहुत इंपॉर्टेंट एक्सप्रेशन है. बीपी का ब्रेक पावर measured by any kind of row brake dynamometer 2 pi nt by 60 into 1000. इसको भी याद रखेंगे आप. How to obtain brake power. Okay, 2 pi nt, n is the rpm, t is the torque, जिसे हम बोलते हैं ब्रेकिंग टॉर्क. ठीक है, तो W minus S, W is the load applied, S is the spring balance reading. So W load applied minus spring balance reading into R is the radius of the brake drum. ठीक है, radius of the brake drum, you will get the braking torque, and braking torque multiplied by 2 pi n by 60 into 1000, you will get brake power in kilowatt. ठीक है, चलिए मोर्स टेस्ट जो हम कंडक्ट करते हैं मल्टी सिलेंडर इंजन्स पे टू फाइंड आउट आईपी. तो यहां से भी मैकेनिकल में क्वेश्चन पूछता है. एक्सी में ये नहीं है सिलेबस में, सो एक्सी में तो यहां पे कोई चांस नहीं है, बट मैकेनिकल में दे आस्क सम काइंड ऑफ क्वेश्चन फ्रॉम मोर्स टेस्ट. ठीक है, तो मोर्स टेस्ट में हम जैसे निकालते हैं, पहले हम बीपी टोटल निकालते हैं, फिर बीपी टोटल माइनस बीपी व्हेन सिलेंडर 1 इज कट ऑफ, दैट इज गोइंग टू गिव यू आईपी1. तो आईपी1 क्या होता है? बीपी टोटल व्हेन ऑल सिलेंडर्स आर वर्किंग minus when you cut the BP cylinder 1, so BP of 2, 3, 4, that is going to give you IP1. The difference of BP total minus BP 2, 3, 4, that is going to give you IP1. Similarly, IP2 and IP3 and IP4, and if you add IP1, IP2, IP3, IP4, you will get IP total. So BP total divided by IP total, you will get the mechanical efficiency. तो इसको आप याद रखेंगे, how to use this Morse test. ठीक है, Morse test को कैसे अप्लाई करते हैं और कैसे हम यहां से निकालते हैं. पावर प्लांट है, कुछ बेसिक्स हैं बच्चों. पावर प्लांट का थ्योरी है, ये मेरे ख्याल से हमारे ज्यादा काम का नहीं है कि लोड क्या होता है, बेस लोड क्या होता है, ये मैं इस पे अभी नहीं आऊंगा क्योंकि ये सारा डिस्कशन गेट के लिए एटलीस्ट अभी जरूरी नहीं है. ठीक है, मैं लोड फैक्टर पे आता हूं. लोड फैक्टर क्या होता है? इट इज द एवरेज लोड इन ए गिवन टाइम इंटरवल डिवाइड बाय पीक लोड, दैट इज नोन एज लोड फैक्टर. कैपेसिटी फैक्टर होता है आपका एवरेज लोड डिवाइड बाय रेटेड कैपेसिटी ऑफ द प्लांट. रिजर्व फैक्टर होता है आपका लोड फैक्टर डिवाइड बाय कैपेसिटी फैक्टर. ठीक है, यहां से जो क्वेश्चंस बनते हैं, क्वेश्चंस कहां से बनते हैं? रैंकाइन साइकिल से. ठीक है, पावर प्लांट में जनरली दे आस्क क्वेश्चन फ्रॉम रैंकाइन साइकिल एंड ब्रेटन साइकिल. ठीक है, तो आपको बहुत कंफर्टेबल आप होने चाहिए रैंकाइन साइकिल में. दिस इज द टीएस डायग्राम फॉर ए रैंकाइन साइकिल. 1 to 2 isentropic expansion in the turbine, 2 to 3 constant pressure heat rejection in the condenser, 3 to 4 isentropic compression or isentropic pumping process actually. Okay, 4 to 5 heat addition in the heat addition in the economizer section, 5 to 6 heat addition in the boiler section, and 6 to 1 is the heat addition in the superheated section. So this entire H1 minus H4, that is going to give you heat addition. H1 minus H4, this is heat addition guys. So in this Rankine cycle में जो H1 minus H4 होता है बच्चों, this is heat supplied. H1 minus H4, this is heat supplied. Okay, और H1 minus H2, this is turbine work. ठीक है, and H4 minus H3, this is pump work. ठीक है, और WT minus WP, इसे हम बोलते हैं W net. इसे क्या बोलेंगे बच्चों? W net. ठीक है, and W net divided by heat supplied, this is known as efficiency. Net work divided by heat supplied, this is known as thermal efficiency. ठीक है, थर्मल एफिशिएंसी है, इसको साइकिल एफिशिएंसी भी बोलते हैं. दिस इज द थर्मल एफिशिएंसी और साइकिल एफिशिएंसी. रैंकाइन साइकिल एफिशिएंसी, दिस इज रैंकाइन साइकिल एफिशिएंसी. ठीक है, चलिए, सो आपको बिल्कुल आप कंफर्टेबल होने चाहिए. हाउ टू फाइंड आउट द एफिशिएंसी ऑफ ए रैंकाइन साइकिल, हाउ टू फाइंड आउट डब्ल्यू नेट, हाउ टू फाइंड आउट हीट सप्लाइड. ठीक है, चलो, इसे बोलते हैं हम सुपर क्रिटिकल साइकिल. इफ यू आर ऑपरेटिंग द बॉयलर अबव द क्रिटिकल पॉइंट, दैट इज नोन एज सुपर क्रिटिकल बॉयलर. ठीक है, क्रिटिकल पॉइंट कितना होता है बच्चों वाटर का? इट इज अ पॉइंट वेयर it is very difficult to segregate between liquid and vapor because their volume, specific volume will become same. At critical point or beyond critical point, the specific volume of the liquid and vapor will be same. Okay, and the latent heat will become zero at critical point. Okay, critical point पे भी degree of freedom क्या होता है आपका? Zero होता है. Okay, critical point of water is 221.2 bar means close to 221 atmospheric. The critical point is 221 times of the atmospheric pressure and the critical point temperature is close to 374 डिग्री सेल्सियस. रैंकाइन साइकिल की मैं ऑलरेडी आपसे डिस्कस कर चुका हूं. द रैंकाइन साइकिल एफिशिएंसी इज W net by heat supplied. स्टीम रेट क्या होता है? द हीट रिक्वायर्ड, द स्टीम रिक्वायर्ड टू प्रोड्यूस यूनिट शाफ्ट पावर, दैट इज नोन एज स्टीम रेट. Similarly, the heat required to produce unit shaft power, that is known as heat rate. तो heat rate हम कैसे निकालते हैं, steam rate हम कैसे निकालते हैं, that also you need to aware. चलो चेक कर लेना एक बार. और ये फार्मूलाज हैं, how to find out steam rate and heat rate. ये कुछ एफिशिएंसीज है बच्चों. थर्मल पावर प्लांट में कुछ एफिशिएंसीज हैं, तो कई बार वो आपसे अलग अलग एफिशिएंसी से पूछ सकता है. Sometime he can ask you individually, like cycle efficiency तो आपको पता है. boiler efficiency क्या है? What is boiler efficiency? It is a heat supplied in the boiler divided by heat supplied by the combustion, means the mass. This Q combustion is nothing but, Q combustion क्या हो जाएगा बच्चों? This is nothing but a mass of fuel consumed into calorific value. Okay, so this is Q combustion, heat generated by the combustion. M dot mass of fuel consumed into calorific value. This is Q combustion and this is the heat addition in the boiler. So this ratio is known as boiler efficiency. Similarly, the turbine efficiency is what? Output means BP divided by W net. BP by W net, this is turbine efficiency. Generator efficiency is the electrical power output divided by BP. Because to generator the input is BP, generator is getting the mechanical energy and it is converting that mechanical energy into electrical energy. So the generator output is electrical power and input is BP. Auxiliary efficiency क्या होता है बच्चों? Net generator power output. Net generator power output divided by electrical power output by generator, because the power which we are getting from the generator, the entire is not the W net. Why? Because some part of that we are going to use to run some kind of auxiliary devices. You know, in a thermal power plant there are lots of devices. Lighting system is there inside, lots of ID fans are there, lots of pumps are there which are operating in a typical thermal power plant. So the power required to run all those auxiliary devices, that is a power which you are supplying to those auxiliary devices. So the net generator output divided by electrical power generated by the generator. So suppose you are having a plant which is producing 120 megawatt of electricity, but out of that 120 megawatt, 10 kilowatt, 10 megawatt you are consuming inside the plant only. So the exact net output is 110. So 110 divided by 120, that is known as auxiliary efficiency. अगर मैं इन सबको मल्टीप्लाई कर दूं बच्चों, साइकिल एफिशिएंसी, बॉयलर एफिशिएंसी, टरबाइन एफिशिएंसी, जनरेटर एफिशिएंसी एंड ऑक्सिलरी एफिशिएंसी, देन यू आर गोइंग टू हैव ओवरऑल एफिशिएंसी ऑफ ए थर्मल पावर प्लांट. ठीक है, तो ये कुछ अलग अलग एफिशिएंसीज हैं. हाउ टू फाइंड ऑक्सिलरी एफिशिएंसी, जनरेटर, मैकेनिकल सोर्स या साइकिल का एफिशिएंसी हम कैसे निकाल सकते हैं. ठीक है, सुपर हीटिंग क्या होता है बच्चों? सुपर हीटिंग में क्या करते हैं? वी इंक्रीज द मीन टेम्परेचर ऑफ हीट एडिशन. व्हाई वी इंक्रीज द मीन टेम्परेचर ऑफ हीट एडिशन? सो दैट इरिवर्सिबिलिटीज विल बी लेस. यस, हाँ, खड़गपुर बच्चे जनरली हीट ट्रांसफर थर्मोफार्ट ज्यादा पूछता है. यस, ये जनरल अभी हम ऐसा कंक्लूड नहीं कर सकते, ये बच्चों में थोड़ी सी हवा रहती है. मेरे को भी इसका पता है, परसेप्शन है, एक नॉर्मल परसेप्शन है कि जनरली बॉम्बे क्या पूछता है? बॉम्बे जनरली हम बोलते हैं कि सीएनसी वगैरह वो उस तरह के जो क्वेश्चंस हैं, प्रोडक्शन जो है वो ज्यादा पूछता है. सिमिलरली खड़गपुर जनरली हीट ट्रांसफर, थर्मोडायनेमिक्स, ये जो थर्मल वाला पार्ट है वो ज्यादा पूछता है. अब ऐसा परसेप्शन है तो यू कैन प्रिपेयर. ठीक है, बट आपको गेट के लिए तो सारा ही करना पड़ेगा. ठीक है, ऐसा नहीं कर सकते आप, बट हाँ, कोई पार्ट आपका जो स्ट्रॉन्ग है उसको आप ज्यादा से ज्यादा रिवाइज करेंगे सो दैट यू विल बी एबल टू गेट मार्क्स इन दैट पर्टिकुलर एरिया. ठीक है, सुपर हीटिंग हम करते हैं बच्चों टू इंक्रीज द मीन टेम्परेचर ऑफ हीट एडिशन सो दैट द नॉन इक्विलिब्रियम बिटवीन सिस्टम एंड सराउंडिंग विल बी लेस. आई मेंशन्ड इन thermodynamics guys, the non-equilibrium between system and surrounding causes external irreversibility. So we want less temperature difference between this flue gas and this steam, and if less is the temperature difference between them, the lesser will be the non-equilibrium, the lesser will be the irreversibility, the lesser will be the what? External irreversibility. तो efficiency क्या हो जाएगी अपनी? बढ़ जाएगी. ठीक है, improving the mean temperature of heat addition. But superheating का क्या होता है? एक लिमिट होती है, because there is a limit to the maximum temperature. You cannot go beyond that maximum temperature. इंजन किसी भी पर्टिकुलर थर्मल पावर प्लांट में एक मैक्सिमम टेम्परेचर होता है बच्चों. दिस इज अ मैक्सिमम ऑपरेटिंग टेम्परेचर, जो जनरली इंडिया में जितने प्लांट्स हैं उनके लिए 550 डिग्री सेल्सियस के आसपास होता है. फॉर मोस्ट ऑफ द थर्मल पावर प्लांट ऑपरेटिंग इन इंडिया, द मैक्सिमम ऑपरेटिंग टेम्परेचर इज 550 डिग्री सेल्सियस. तो वी कैन नॉट गो बायॉन्ड दैट. ठीक है, तो फिर अपने को रीहीटिंग करना पड़ता है या रीजनरेशन करना पड़ता है, कुछ इस तरह से अपने को करना पड़ता है. तो रीहीटिंग का एडवांटेज क्या होता है? रीहीटिंग वर्क को इंप्रूव करता है. एफिशिएंसी बढ़ भी सकता है, घट भी सकता है. इट डिपेंड्स ऑन द रीहीट प्रेशर. बट इफ यू आर कैरिंग आउट रीहीटिंग, डेफिनेटली इट इज गोइंग टू इंप्रूव डब्ल्यू नेट, ड्राइनेस फ्रैक्शन बढ़ जाएगा, मींस क्वालिटी ऑफ स्टीम बढ़ जाएगा एट द एग्जिट ऑफ द टरबाइन। ठीक है, इस केस में सबसे इंपॉर्टेंट जो चीज है, यहां से जो क्वेश्चन बनता है, इन केस ऑफ रीहीटिंग डब्ल्यू नेट क्या हो जाएगा बच्चों, यहां पे अगर डब्ल्यू नेट आपको निकालना है बच्चों, इस केस में डब्ल्यू नेट होगा WT1, ये वाला WT1 और प्लस WT2। यहां पे दो स्टेजेस में यू आर एक्सपेंडिंग द स्टीम, फर्स्ट द एक्सपेंशन यू आर कैरिंग आउट इन high pressure turbine and then you are carrying out expansion in the low pressure turbine. So the W net in case of reheating is equal to WT1 plus WT2 minus WP. तो ये याद रखना बच्चों, ये मिस्टेक मत कर देना। If you are using a reheating cycle, reheating Rankine cycle, in this reheating Rankine cycle, WT1 will be H5 minus H6, WT2 will be H6 minus H7. So WT1 plus WT2 minus WP, which is H2 minus H1, you will get the W net. ठीक है, सिमिलरली हाउ टू फाइंड आउट हीट ट्रांसफर, हीट ट्रांसफर क्या होगा इसमें, हीट सप्लाइड इन दिस रीहीटिंग Rankine cycle। तो यहां पे हीट यू आर एडिंग इन टू पार्ट्स, फर्स्ट यू आर एडिंग हीट इन द बॉयलर, सेकंड यू आर एडिंग हीट इन द रीहीटर। तो दोनों को आपको याद रखना है, द हीट एडिशन इन द बॉयलर is nothing but heat addition in boiler is nothing but H5 minus H2. So this is heat addition in the boiler. Heat addition in the reheater, guys. Heat addition in the reheater, ये जो reheater है 6 to 7 is the reheating process. So H7 minus H6, this is heat addition in the reheater. दोनों को add करोगे then you are going to get total heat addition. ठीक है, तो total heat addition क्या हो जाएगा बच्चों, this is H5 minus H2 plus H7 minus H6, this is total heat supplied. ठीक है, सो इफ यू वांट टू फाइंड आउट एफिशिएंसी ऑफ ए रीहीट Rankine साइकिल, तो एफिशिएंसी क्या हो जाएगी, डब्ल्यू नेट, दिस इज डब्ल्यू नेट, ये जो है डब्ल्यू नेट, दिस डब्ल्यू नेट डिवाइड बाय हीट सप्लाइड, दिस हीट सप्लाइड, यू आर गोइंग टू गेट एफिशिएंसी ऑफ ए रीहीट Rankine साइकिल। तो ये थोड़ा सा आप ध्यान रखेंगे बच्चों, कैसे आपको इसको करना है। Rankine साइकिल का एफिशिएंसी ज्यादा होता है बच्चों, Rankine साइकिल का एफिशिएंसी आपका ऑटो डीजल से क्या होता है, ज्यादा होता है। ठीक है, ऑटो डीजल का कंपेयर करने के लिए आपको डिफरेंट क्राइटेरिया चाहिए। इन जनरल डीजल साइकिल इज हैविंग मोर एफिशिएंसी एज कंपेयर टू ऑटो साइकिल। व्हाई? बिकॉज़ द कंप्रेशन रेशियो ऑफ डीजल साइकिल इज मोर। डीजल साइकिल का एफिशिएंसी कंप्रेशन रेशियो क्या होता है, ज्यादा होता है। ठीक है, एज कंपेयर टू कंप्रेशन रेशियो ऑफ व्हाट, ऑटो साइकिल। सो इन जनरल डीजल विल हैव मोर एफिशिएंसी। मैंने आपको बताया ऑटो ब्रायटन दे विल हैव सेम एफिशिएंसी इफ दे आर ऑपरेटिंग बिटवीन सेम टेंपरेचर लिमिट। सो डीजल, ऑटो ब्रायटन नीचे आ जाएगा, Rankine सबसे ऊपर चल जाएगा। Rankine का एफिशिएंसी क्या होता है, इट इज द मैक्सिमम आउट ऑफ दीस। ठीक है, तो Rankine साइकिल थर्मल पावर प्लांट का जनरली, बिकॉज अगर हम बात किसके लिए कर रहे हैं, पावर प्रोडक्शन के लिए बच्चों, दिस डिपेंड्स ऑन द पर्सपेक्टिव। हम अगर पावर प्रोडक्शन की बात करेंगे, लाइक लार्ज साइज प्लांट्स की बात करेंगे, इन दोज लार्ज साइज प्लांट्स लाइक 100 मेगावाट 200 मेगावाट, देन एफिशिएंसीज ऑफ Rankine साइकिल मींस विल बी हाई। It's not a kind of IC engine, it is a EC engine, but the efficiency will be more. IC engine for small power production. ओके, तो वहां पे ऑटो डीजल का एफिशिएंसी क्या हो जाएगा, डीजल का क्या हो जाएगा, ज्यादा हो जाएगा। बट इफ आई टॉक अबाउट पावर प्लांट्स, इन पावर प्लांट्स Rankine साइकिल सबसे ऊपर रखोगे, देन यू कैन गो फॉर सेकंड डीजल, देन थर्ड यू कैन गो फॉर व्हाट, ब्रेटन ऑटो। चलिए, सो रीजनरेशन में हम क्या करते हैं, अगेन इन रीजनरेशन आल्सो वी इंक्रीज द मीन टेंपरेचर ऑफ हीट एडिशन। तो सम पार्ट ऑफ स्टीम वी एक्सट्रैक्ट फ्रॉम द बॉयलर एंड दैट स्टीम, टरबाइन से कुछ स्टीम को एक्सट्रैक्ट करते हैं, दैट स्टीम वी मिक्स डायरेक्टली इन द फीड वाटर टू इंक्रीज इट्स मीन टेंपरेचर ऑफ हीट एडिशन। ठीक है, तो वहां पे हम कैसे एनर्जी बैलेंस लगाते हैं ये देख लेना बच्चों एक बार। सो m इज द फ्रैक्शन ऑफ स्टीम यू आर एक्सट्रैक्टिंग फ्रॉम द टरबाइन। m क्या है, फ्रैक्शन मींस परसेंटेज ऑफ स्टीम यू आर एक्सट्रैक्टिंग फ्रॉम द टरबाइन आउट ऑफ टोटल 100%। टोटल 100% में से कितना परसेंट आपने एक्सट्रैक्ट कर लिया। सो m into H2 minus H6 equal to 1 minus m, 1 minus, अगर आप इसको परसेंटेज में यूज करोगे देन यू नीड टू राइट 100, और अगर आप इसको फ्रैक्शन में यूज करते हो सो यू कैन राइट इट एज फ्रैक्शन ऑफ स्टीम एक्सट्रैक्टेड, सो इट विल बी 0.2 0.3 समथिंग लाइक दिस। ठीक है, और 1 क्या है, 1 इज द टोटल फ्रिक्शन। So m is the fraction of steam you are extracting from the turbine. So m into H2 minus H6 equal to 1 minus m into H6 minus H5. So this is very important to find out the fraction of steam extracted from the turbine. कई बार आपसे पूछ लेता है कि कितना फ्रैक्शन हम एक्सट्रैक्ट कर रहे हैं। तो ये एंथैल्पी है H6 H5 डिवाइड बाय H2 माइनस H5। H6 क्या हो जाएगा, जिस प्रेशर पे आप क्या कर रहे हो, रीजनरेशन कर रहे हो। ओके, सो दिस इज अ प्रेशर वेयर यू आर एक्सट्रैक्टिंग दैट स्ट्रीम, वहां पे ये क्या हो जाएगा, HF। ठीक है, तो ये इजीली आपको नोन होगा बेस्ड ऑन द गिवन कंडीशंस। यू विल बी इजीली एबल टू फाइंड आउट H6 H5 H2 and H5, and if you know all these values you will be easily able to find out the mass of the steam extracted, fraction of the steam which you are extracting from the turbine. तो रीजनरेशन का क्या एडवांटेज होता है, दैट आल्सो आई मेंशन हियर. ठीक है. सो गाइस दिस इज अबाउट पावर प्लांट. नेक्स्ट हम थोड़ा सा ब्राइटन साइकिल देख लेते हैं. देखो ब्राइटन साइकिल विच इज आल्सो अ काइंड ऑफ एयर स्टैंडर्ड साइकिल. ठीक है. ब्राइटन साइकिल में हाउ टू फाइंड आउट एफिशिएंसी, द एक्सप्रेशन आई ऑलरेडी मेंशन. ब्राइटन साइकिल का एफिशिएंसी एक्सप्रेशन क्या होता है, इट इज वेरी मच सिमिलर टू द एक्सप्रेशन ऑफ द ऑटो साइकिल. ऑटो साइकिल में क्या होता है, कंप्रेशन रेशियो होता है 1 - 1 बाय r की पावर गामा -1. दिस इज एफिशिएंसी ऑफ ऑटो साइकिल, एफिशिएंसी ऑफ ऑटो. ओके, एंड दिस इज एफिशिएंसी ऑफ ब्राइटन साइकिल. ठीक है. चलिए, तो प्रोसेसेस आपको पता ही है दो क्या होंगे, कांस्टेंट प्रेशर, कांस्टेंट प्रेशर, कंप्रेशन, कांस्टेंट प्रेशर प्रोसेस. ओके, ये क्या है आपका, दिस इज काइंड ऑफ व्हाट, दिस इज रिजेक्शन प्रोसेस. ओके, दिस इज रिजेक्शन. This is isentropic compression in the compressor. This is heat addition at constant pressure. Here in combustion chamber you are adding heat at constant pressure, then you will have isentropic expansion process. Okay, generally you for most of the Brayton cycle gas turbine you will have this kind of open cycle. वहां पे ये process क्या होगा, ये नहीं होगा. Okay, but in case of closed cycle, closed Brayton cycle, you will have this process also. वहां पे आपको यहाँ पे क्या लगाना पड़ेगा, एक heat exchanger लगाना पड़ेगा. So this is a kind of heat exchanger. यहां पे आप क्या कर रहे हो, you are rejecting the heat. Okay, so 4-to-1 is a kind of heat rejection process. Okay, in case of what, closed Brayton cycle. ठीक है, ओपन में ये प्रोसेस नहीं होगा. सिंपली द एग्जॉस्ट गैसेस यू आर गोइंग टू रिजेक्ट इन द एटमॉस्फेयर. तो मैक्सिमम एफिशिएंसी क्या होता है बच्चों, ब्राइटन का साइकिल का मैक्सिमम एफिशिएंसी. ओके, सो मैक्सिमम एफिशिएंसी हो तो सकता है कार्नोट के ऊपर, बट वहां पे वर्क क्या हो जाएगा बच्चों, डब्ल्यू नेट विल बी 0. सो वी आर नॉट इंटरेस्टेड इन मैक्सिमम एफिशिएंसी. We are not interested in maximum efficiency, we are interested in the optimum efficiency. Okay, so if you will go for maximum efficiency, you will get W net 0, W net will be 0. Okay, so RP maximum for a Brayton cycle is equal to this T max by T minimum power gamma by gamma -1, but वहां पे W net क्या हो जाएगा, 0 हो जाएगा. And RP optimum, it is a pressure ratio where you are going to get a maximum work output. We are interested in the operating condition where we are going to get a maximum work output. We are interested in maximum work output. So to get the maximum work output, RP optimum equal to under root RP max. और RP max क्या था बच्चों, T max by T minimum power gamma by gamma -1. और उसका अंडर रूट करोगे, you will get T max by T minimum power gamma by 2 times gamma -1. Okay, so this is the expression for RP optimum. बहुत इंपॉर्टेंट है ब्रेटन साइकिल के लिए, याद रखना how to find out RP optimum. Okay, and this is the condition guys to get the maximum work output. T2 equal to T4, which is equal to under root T1 minus T2. W max equal to this expression, and this is the optimum efficiency. Optimum efficiency of Brayton cycle 1 minus under root T minimum by T maximum. Maximum efficiency क्या होता है, maximum efficiency is 1 minus T minimum by T maximum, which is equal to Carnot, but work output क्या हो जाएगा 0. To get the maximum work output, the optimum efficiency is 1 minus under root T minimum by T max. तो याद रखना एक बार, optimum pressure ratio, how to find out optimum efficiency and maximum work output. तो बच्चों ये था सब कुछ हमारे पास पावर प्लांट और थर्मोडायनामिक्स के बारे में. हीट ट्रांसफर को जल्दी से क्विकली देख लेते हैं. ठीक है, हीट ट्रांसफर के फार्मूलाज भी रिकॉल कर लेते हैं. ये थ्योरी है कुछ, ये हमारे ज्यादा डिस्कशन में. हीट ट्रांसफर, कंडक्शन, कन्वेक्शन क्या होता है. पहला फार्मूला जो हमारे पास हीट ट्रांसफर में आता है, दैट इज Q इक्वल टू माइनस KA dt by dx, जहां पे ये क्या होता है, फोरियर लॉ ऑफ हीट कंडक्शन. K is the thermal conductivity and dt by dx is known as temperature gradient in the direction of heat transfer. ठीक है, माइनस साइन लगाते हैं बिकॉज heat always flow from high temperature to low temperature, and in the direction of heat transfer the temperature, this gradient, okay, is always negative. In the direction of heat transfer ये टर्म हमेशा क्या होती है, नेगेटिव होती है. So to make it positive we placed one more negative sign. तो ये फॉर्मूला याद रखना, Q conduction equal to delta T divided by summation of R thermal. ठीक है, R thermal कैसे कैसे लिखते हैं हर केस के लिए वो एक बार देख लेते हैं. न्यूटन्स लॉ ऑफ कूलिंग भी ध्यान रखना. For convection we use Newton's law of cooling. Q convection equal to HA delta T, where H is the convection heat transfer coefficient, A is the area of exposure, and delta T is the temperature difference. चलिए, रेडिएशंस के लिए, for radiation we use hemispherical emissive power. So for a black body, hemispherical emissive power is directly proportional to the fourth power of its absolute temperature, which is known as Stephens-Boltzmann law of thermal radiation. ठीक है, so E is the hemispherical emissive power of a black body and E is the hemispherical emissive power of a non-black body, and the ratio of hemispherical emissive power of a non-black body to the black body, that is known as emissivity. तो emissivity generally इसका वैल्यू क्या होता है, इट्स वैल्यू इज ग्रेटर देन इक्वल टू 0, लेस देन इक्वल टू 1. फॉर ब्लैक बॉडी एमिसिविटी इक्वल टू 1. ब्लैक बॉडी के लिए क्या होता है, इक्वल टू 1. ब्लैक बॉडी एमिसिविटी इक्वल टू 1, एब्जॉर्बिविटी इक्वल टू 1. द ब्लैक बॉडी इज an आइडियल एमिटर एंड आइडियल एब्जॉर्बर ऑफ थर्मल रेडिएशंस. चलिए, तो ये कुछ अलग अलग केसेस है बच्चों जो आपको हीट ट्रांसफर के लिए पता होना चाहिए. लाइक फॉर प्लेन स्लैब हाउ वी राइट दी थर्मल रेजिस्टेंस. प्लेन स्लैब के लिए थर्मल रेजिस्टेंस हम कैसे लिखते हैं, बी बाय के. बी क्या है, उसका विड्थ है इन द डायरेक्शन ऑफ हीट ट्रांसफर. ए इज द एरिया परपेंडिकुलर टू डायरेक्शन ऑफ हीट ट्रांसफर. ए कौन सा एरिया लेते हैं बच्चों, एरिया परपेंडिकुलर टू डायरेक्शन ऑफ हीट ट्रांसफर. ठीक है, सो बी बाय के दिस इज द थर्मल रेजिस्टेंस ऑफ ए प्लेन स्लैब. और अगर प्लेन स्लैब किस में है बच्चों, सीरीज में, यू आर हैविंग मल्टीपल स्लैब्स इन सीरीज, so the total resistance equal to R1 plus R2. How to find out equivalent resistance if you are having, ठीक है, how to find out total resistance if you are having slabs in series. चलिए, इंटरमीडिएट टेम्परेचर कैसे निकाल सकते हैं, दिस इज अ फॉर्मूला, रिलेशनशिप टू फाइंड आउट इंटरमीडिएट टेम्परेचर. तो बहुत बार पूछता है आपसे, इंटरमीडिएट टेम्परेचर पूछ लेता है आपसे. तो कुछ नहीं, उसके लिए आपको क्या करना है, Q इक्वल टू डेल्टा T मींस T1 माइनस T3 डिवाइड बाय टोटल रेजिस्टेंस. दैट यू कैन राइट इट एज T1 माइनस T2 डिवाइड बाय R1. और इसको आप ये भी लिख सकते हो, यू कैन राइट दिस एज इक्वल टू T2 माइनस T3 डिवाइड बाय R2. So it totally depends on you. Q, because in steady state there is no accumulation of heat. Q you can write it as delta T by total resistance. So delta T, if you are taking this and this, so you need to write all resistance between this and this, which is equal to R1 plus R2. If you are taking this temperature difference T1 minus T2, so you need to write only resistance R1. And if you are taking this temperature difference T2 minus T1, then you need to write only R2. Got this idea, guys? So this is the formula to find out intermediate temperature. ठीक है, स्लैब्स अगर पैरेलल में है, इन पैरेलल, दिस इज द फॉर्मूला टू फाइंड आउट इक्विवेलेंट रेजिस्टेंस. सीरीज में तो डायरेक्टली ऐड कर सकते हो, बट इन केस ऑफ पैरेलल यू नीड टू यूज दिस रिलेशनशिप टू फाइंड आउट इक्विवेलेंट रेजिस्टेंस इन पैरेलल. ठीक है, तो आई होप यू ऑल हैव स्टडीड these kind of things. So how to find out thermal resistance of a cylinder? पाइप के लिए कैसे लिखते हैं बच्चों, फॉर पाइप और सिलेंडर द थर्मल रेजिस्टेंस इक्वल टू ln of R2 by R1 divided by 2 pi KL, where K is the conductivity, L is the length of the tube, R2 is the outer radius, R1 is the inner radius. ठीक है, स्फीयर के लिए क्या हो जाएगा, फॉर स्फीयर द थर्मल रेजिस्टेंस इज R2 minus R1 divided by 4 pi K R1 R2. R2 is the outer radius, R1 is the inner radius, K is the thermal conductivity, and you know Q equal to delta T divided by summation R thermal. ठीक है, अगर मल्टीपल आपके पास लेयर्स हैं, then there will be summation of R thermal. So you need to check you are having a single layer or multiple layer. So in case of pipe or sphere, you are not going to have any kind of parallel case. इसमें सीरीज केस ही मिलेगा बच्चों. ट्यूब में यहाँ पे ये कोई पाइप का केस हो या कोई स्फीयर का केस हो, यू आर नॉट गोइंग टू हैव पैरेलल केस, वहां पे सीरीज का केस ही होगा. सो Q इक्वल टू डेल्टा T डिवाइड बाय समेशन ऑफ R थर्मल मींस R1 plus R2 plus R3, something like this. Okay, so if you are having a composite tube or composite sphere, then you can use this relationship to find out Q. Okay, चलिए नेक्स्ट हम बात करते हैं combined conduction convection, because if you are having a tube in which internal is taking place convection and external also convection is taking place, then you need to consider the convection resistance also. So 1 by HA, this is known as convection resistance. 1 by HIAI, this is internal convection resistance. 1 by HOAO, this is known as external convection resistance. So if you are having a combined case of conduction and convection, you need to consider all resistance, conduction as well as convection. ओके, एक बहुत इंपॉर्टेंट रिलेशनशिप है बच्चों ओवरऑल हीट ट्रांसफर कोएफिशिएंट के लिए. सो दिस इज अ रिलेशनशिप व्हिच यू नीड टू रिमेंबर. 1 by UA equal to summation of all resistances. 1 by UA equal to summation of all thermal resistances, conduction plus convection all, because this is actually a parameter which we introduce to take into consideration all resistance into a single entity. So 1 by UA equal to summation of all thermal resistances. ठीक है, तो ये आप याद रखना. हाउ टू फाइंड आउट दिस. क्रिटिकल रेडियस क्या होता है बच्चों, इट इज दैट रेडियस ऑफ इंसुलेशन वेयर द हीट ट्रांसफर इज मैक्सिमम. ये वो रेडियस है जहां पे हीट ट्रांसफर क्या होता है आपका मैक्सिमम होता है. और क्रिटिकल रेडियस ऑफ इंसुलेशन फॉर ए ट्यूब और सिलेंडर इक्वल टू K by H. ट्यूब या सिलेंडर के लिए होता है K by H. ठीक है, एंड फॉर स्फेरिकल डिवाइसेस दिस इज इक्वल टू 2K by H. ठीक है, अगर क्रिटिकल थिकनेस पूछता है तो क्रिटिकल थिकनेस के लिए आपको क्या करना पड़ेगा, क्रिटिकल थिकनेस TC इज इक्वल टू RC माइनस RO. ये याद रखना, क्रिटिकल थिकनेस ऑफ इंसुलेशन, क्रिटिकल थिकनेस ऑफ इंसुलेशन आपका यहां से आएगा बच्चों, दिस इज द क्रिटिकल थिकनेस, क्रिटिकल थिकनेस ऑफ इंसुलेशन TC इज नथिंग बट RO, दिस इज RO, यहां पे अगर मैं यहां लिख देता हूं, दिस इज RO, ठीक है। सो RC क्रिटिकल रेडियस, RC में से इफ यू सबट्रैक्ट RO यू विल गेट द क्रिटिकल थिकनेस। तो यू नीड टू चेक, ही इज आस्किंग यू द क्रिटिकल रेडियस और क्रिटिकल थिकनेस, ठीक है। क्रिटिकल रेडियस पूछेगा, you can use these formulas, and if he is asking you the critical thickness, then you need to subtract the outer radius out of the critical radius to get the critical thickness. It is that thickness of insulation where the heat transfer is maximum or the total resistance is minimum. वहां पे total resistance क्या होती है, सबसे minimum होती है, और heat transfer क्या होता है आपका, maximum होता है. So these are the generalized heat conduction equation guys in Cartesian coordinates and cylindrical coordinates. तो इक्वेशन याद रखना बच्चों, दिस इज नोन एज फोरियर्स इक्वेशन, जहां पे हम विदाउट हीट जनरेशन मानते हैं, नो हीट जनरेशन, फोरियर इक्वेशन। स्टेडी स्टेट विद हीट जनरेशन, दिस इज नोन एज पॉइसन्स इक्वेशन। लैप्लास इक्वेशन क्या हो जाएगी, स्टेडी स्टेट विदाउट हीट जनरेशन, दैट इज नोन एज लैप्लास इक्वेशन, ठीक है। तो ये आपको पता होना चाहिए, दिस इज द जनरलाइज्ड हीट कंडक्शन इक्वेशन इन सिलेंड्रिकल कोऑर्डिनेट्स, ठीक है। तो ये कुछ फॉर्मूलेज हैं टू फाइंड आउट वन डायमेंशनल हीट जनरेशन। इफ यू आर हैविंग ए केस where there is a case of one dimensional heat conduction with heat generation, then how to find out maximum temperature? Okay, so this is a formula which you can use to find out maximum temperature. बहुत डिटेल में हमने ये चीजें पढ़ी हैं, आई होप यू ऑल आर कंफर्टेबल विद दीज काइंड ऑफ फार्मूलाज, ठीक है। तो ये बहुत इंपॉर्टेंट फार्मूला है बच्चों फॉर प्लेन स्लैब। प्लेन स्लैब के लिए दिस इज वेरी वेरी इंपॉर्टेंट फार्मूला, दिस वन एंड दिस वन, ठीक है। सो T इज द टेम्परेचर एट एनी डिस्टेंस, ठीक है। TO इज द मैक्सिमम टेम्परेचर, TO क्या है आपका, मैक्सिमम टेम्परेचर। बट इसके लिए याद रखना आप, इसमें जो केस क्या है, हम जब डिस्टेंस मेजर करते हैं, डिस्टेंस वी टेक फ्रॉम द सेंटर। बच्चे इसमें सबसे बड़ी मिस्टेक क्या करते हैं बच्चों, फार्मूला तो ये यूज करते हैं, बट जहां पे वो L को पुट करते हैं, अब L में वो लेंथ ऑफ प्लेट फिक्स कर पुट कर देते हैं। सो दिस इज नॉट विड्थ ऑफ प्लेट, दिस इज नॉट थिकनेस ऑफ प्लेट, L इज नॉट द थिकनेस ऑफ प्लेट गाइस। L क्या है आपका, थिकनेस डिवाइडेड बाय 2, दिस यू नीड टू रिमेंबर गाइस। Okay, so when you are writing these formulas, the thickness of the plate, suppose he has given you some kind of 20 mm thick plate in which there is a kind of heat generation is taking place, okay, one dimensional heat generation, steady state. So when you are using this formula, so L will be thickness divided by 2, because when we are deriving these kind of formulas, we are assuming the distance, we are taking the distance from the center of the plate. So this is minus L, this is again L, okay. So this L is nothing but thickness divided by 2, that you need to understand, ठीक है। तो बस ये वाला मिस्टेक मत करना, रिमेनिंग दिस फॉर्मूला यू कैन यूज, Q इज द वॉल्यूमेट्रिक हीट जनरेशन, ठीक है। सो ये सब आपको गिवन होगा, बेस्ड ऑन दैट यू कैन फाइंड आउट वोल्ट टेम्परेचर ऑल्सो। Q कंडक्शन, Q जनरेशन इक्वल टू Q कंडक्शन इक्वल टू Q कन्वेक्शन, ठीक है, इन केस ऑफ स्टेडी स्टेट। चलिए, सिमिलरली फॉर प्लेन स्लैब ऑल्सो गाइस, प्लेन स्लैब के लिए हम यूज करते हैं, एंड सिलेंडर ऑल्सो, ठीक है। सिलेंडर के लिए ये डिफरेंस रहता है, वहां पे 2K होता है, एंड इन दैट केस ऑफ सिलेंडर वी आर हैविंग 4K। तो ये अनदर इंपॉर्टेंट फार्मूला है फॉर द केस ऑफ सिलेंडर, हीट जनरेशन इन केस ऑफ सिलेंडर, ठीक है, हीट जनरेशन इन केस ऑफ सिलेंडर। तो दोनों ही बहुत इंपॉर्टेंट फार्मूले हैं, सिलेंडर वाला एंड दिस वन फॉर द स्लैब, ओके, दिस वन फॉर द स्लैब, दिस वन। सो दोनों को रिमेंबर कर लेना, बहुत इंपॉर्टेंट है। नेक्स्ट हम बात करते हैं बच्चों, मेरे ख्याल से फिन आ जाएगा, फिन का केस आ जाएगा अपने पास, यस। So for fin we need to have some kind of basic understanding how to find out fin heat transfer. So if you are having a very long fin, these are the expression to find out heat transfer for a very long fin. Q fin equal to under root HP K theta naught. Similarly, if you are having a finite fin with the tip insulated, this is a formula. And similarly, if you are having a fin of finite length and heat is also transferring from the tip also, so L will be replaced by the you need to take the corrective length, okay. So corrective length you need to take, okay. यहाँ पे L क्या है आपका, this L is the original length, okay, and this is the corrected length, ठीक है। चलिए, and this corrected length is nothing but original length plus area by perimeter, cross sectional area divided by perimeter। corrected length लेना पड़ता है अपने को थर्ड केस में, and these are some of the formulation guys to find out corrected length in case of rectangular fin or pin fin. If you are having a pin fin, what is your corrected length, and if you are having a rectangular fin, what is your corrected length, ठीक है। fin efficiency, the actual heat transfer by maximum heat transfer, that is known as fin efficiency. So actual heat transfer तो हम लिख रहे हैं, this is the case, second case हम ले रहे हैं fin tip insulated, okay, and this is Q max when the entire fin is at root temperature. Similarly, fin effectiveness is the heat transfer with fin divided by heat transfer without fin. Heat transfer with fin, without fin, that ratio is known as fin effectiveness. So I hope you all have revised and you are very much comfortable with these kind of formulation. रिलेशन क्या होता है बच्चों इफेक्टिवनेस में और एफिशिएंसी में? सो एफिशिएंसी ऑफ फिन डिवाइड बाय इफेक्टिवनेस, दैट इज इक्वल टू द एरिया क्रॉस सेक्शनल एरिया डिवाइड बाय द सरफेस एरिया. ये क्या है बच्चों? दिस इज द क्रॉस सेक्शनल एरिया एंड दिस इज द सरफेस एरिया. क्रॉस सेक्शनल एरिया डिवाइड बाय सरफेस एरिया. सरफेस एरिया इज नथिंग बट पेरीमीटर इनटू लेंथ. So this relation is also very, very important. The efficiency of fin divided by effectiveness of fin, this is equal to A cross sectional area divided by surface area. Unsteady state case, transient heat conduction, you know, बहुत इंपॉर्टेंट केस है, बहुत बार गेट में क्वेश्चन पूछा जाता है यहां से. Lumped parameter analysis, you need to check Biot number, you need to check first less than 0.01. तो if it is less than this, okay, अगर ये इससे कम है तो आपका एनालिसिस क्या होता है? आपका एप्लीकेबल होता है. लंप्ड पैरामीटर एनालिसिस क्या होता है? आपका एप्लीकेबल होता है. ठीक है. सो लंप्ड पैरामीटर एनालिसिस एप्लीकेबल, देन यू कैन अप्लाई दिस फॉर्मूला टू फाइंड आउट द टाइम ऑफ कूलिंग. सो ई की पावर HA by rho v Cp into time equal to Ti minus T infinity by T minus T infinity, where Ti is the initial temperature, T infinity is the surrounding temperature, and T is the final temperature. Okay, so if he has given you this T, you can find out time, or if he has given you the time, you can find out the final temperature using this formulation. तो बहुत इंपॉर्टेंट है बच्चों, ये रिलेशन याद रखना. E की पावर HA by rho v Cp into time T equal to Ti minus T infinity by T minus T infinity. बाइट नंबर क्या होता है? ये आपको पता है, इंटरनल कंडक्शन रेजिस्टेंस बाय एक्सटर्नल कंडक्शन रेजिस्टेंस. एंड इफ द इंटरनल कंडक्शन रेजिस्टेंस इज ओनली 10% ऑफ द एक्सटर्नल कंडक्शन रेजिस्टेंस, देन द लंप्ड पैरामीटर एनालिसिस क्या हो जाती है? एप्लीकेबल हो जाती है. वी कैन नेग्लेक्ट द इंटरनल टेम्परेचर ग्रेडियंट. We can assume uniform temperature inside that particular body, same temperature. Okay, so उस केस में we can go with this relationship. Time constant क्या होता है बच्चों? This is a time taken by body to reach 63.2% of its initial temperature difference. That is known as time constant. Time constant कम होना चाहिए बच्चों, because if less is the time constant, the response will be very fast, and that device is known as sensitive device. And if the time constant is high, तो उसको हम बोलते हैं slow. स्लो रिस्पॉन्स हो जाएगा. सो टू गेट द लेस टाइम कांस्टेंट, H क्या होना चाहिए? ज्यादा होना चाहिए. एरिया क्या होना चाहिए? ज्यादा होना चाहिए. सो ही कैन आस्क यू हाउ यू कैन इंक्रीज द टाइम को हाउ यू कैन डिक्रीज द टाइम कांस्टेंट. सो टाइम कांस्टेंट को डिक्रीज करने के लिए H क्या होना चाहिए? ज्यादा होना चाहिए. सरफेस एरिया क्या होना चाहिए? आपका ज्यादा होना चाहिए. चलिए, response of a thermocouple, that also I have mentioned. So that same relationship you can write in terms of Biot and Fourier number also. जो रिलेशनशिप हमने पहले लिखा था, E की पावर HA by rho v C into T, that relationship you can write in terms of Biot and Fourier number also. ठीक है, तो इसको आप ऐसे भी याद कर सकते हो, where Fourier number equal to alpha T by S square. S is nothing but your characteristic dimension. ठीक है, so alpha T, Q conduction by Q storage, that is known as Fourier number. And very important relationship guys, you need to remember. Heat exchanger बहुत important है, क्वेश्चन आता है यहाँ से. LMTD निकालना, energy balance. How you can write the energy balance for a heat exchanger guys? Heat exchanger is a steady flow device, and for any steady flow device you can apply steady flow energy equation. So if you neglect the kinetic and potential energy changes, then you can write the decrease in enthalpy of the hot fluid is equal to increase in enthalpy of the cold fluid. ठीक है, so this is a temperature profile for parallel flow and counter flow. आपको आना चाहिए कि कैसे हम टेम्परेचर प्रोफाइल ड्रॉ करते हैं काउंटर फ्लो के लिए, पैरेलल फ्लो के लिए, and what is the expression for LMTD of what parallel and counter flow. The expression will be same. LMTD expression is same, but the value will be different. LMTD of counter flow क्या होता है बच्चों? It is generally more than the LMTD of a parallel flow heat exchanger. That's why the area required for the counter flow heat exchanger is less as compared to the area required for parallel flow heat exchanger for same amount of heat transfer. And if you want to transfer the if you want to have same amount of area, then heat transfer will be more in counter flow. Why? Because LMTD of counter flow is more as compared to LMTD of parallel flow. Q equal to UA delta Tm. Delta Tm is known as LMTD. U is the overall heat transfer coefficient, which is equal to 1 by H1 plus 1 by H2 plus fouling factor. ठीक है, तो बहुत इंपॉर्टेंट ये रिलेशंस है आपके हीट एक्सचेंजर के लिए। कुछ इंपॉर्टेंट केसेस बनते हैं बच्चे, इफ यू आर हैविंग ए बॉयलर और इवोपरेटर, इन केस ऑफ बॉयलर और इवोपरेटर डेल्टा टीएम पैरेलल काउंटर बोथ आर सेम। सो इफ यू आर हैविंग ए बॉयलर मींस कंडेंसर या बॉयलर है आपके पास, सपोज यू आर हैविंग ए इवोपरेटर, इवोपरेटर को हम क्या बोल सकते हैं, इट्स अ काइंड ऑफ बॉयलर ओनली बिकॉज द रेफ्रिजरेंट इज कन्वर्टिंग फ्रॉम लिक्विड टू वेपर। Okay, so the vaporization is going to take place in the evaporator. So if you are having a evaporator or condenser, it is immaterial to say कि यार it is better to go for parallel or counter, because in both the cases you are going to have same performance. The performance of parallel flow evaporator is same as like the performance of a counter flow evaporator, because both are having same LMTD, both are having same effectiveness also. ठीक है, तो कुछ स्पेशल केसेस बन जाते हैं इसमें काउंटर फ्लो हीट एक्सचेंजर के लिए। इफ सी इक्वल टू 1, हीट कैपेसिटी रेट रेशो सी अगर 1 हो जाता है तो इन दैट केस डेल्टा टी आई इक्वल टू डेल्टा टी, और वही क्या बन जाता है अपना डेल्टा टी एम फॉर द केस ऑफ काउंटर फ्लो हीट एक्सचेंजर व्हेन सी इक्वल टू 1। तो वहां पे टेम्परेचर प्रोफाइल कुछ आपका ऐसा बनता है बच्चों, इन केस ऑफ काउंटर फ्लो हीट एक्सचेंजर इफ बोथ द फ्लूइड आर हैविंग सेम सी, तो वहां पे कुछ ऐसा टेम्परेचर प्रोफाइल बन जाता है। ओके, कुछ ऐसा टेम्परेचर प्रोफाइल बनेगा। ये मैं हॉट ले लेता हूं, तो हॉट का टेम्परेचर मैं डिक्रीज कर देता हूं, कोल्ड का इंक्रीज कर देता हूं। सो दिस इज डेल्टा टी आई और डेल्टा टी बोथ आर सेम एंड बोथ आर इक्वल टू डेल्टा टी एम। इफेक्टिवनेस क्या होता है, इट्स अ एक्चुअल हीट ट्रांसफर बाय मैक्सिमम हीट ट्रांसफर, दैट इज नोन एज इफेक्टिवनेस। और बहुत इंपॉर्टेंट फॉर्मुलेशन है बच्चों, आपको आना चाहिए हाउ टू फाइंड आउट इफेक्टिवनेस ऑफ ए हीट एक्सचेंजर। Effectiveness of a heat exchanger. So this is the case when cold ka heat capacity rate is lower than the heat capacity rate of hot fluid. So this is the formula which you can use. ठीक है, और ये वाला जो ऊपर है, this is the case when hot having less, hot का C hot is less than C cold. C क्या है, C is m dot h into Cph. अगर hot का कम होगा, so this is the formula which you need to use. And if cold is less, this is the formula you need to use for the effectiveness. NTU, which is actually known as number of transfer unit. Okay, it tells us about the size of heat exchanger. More is the NTU, more is the effectiveness, more is the heat transfer. Okay, NTU क्या होता है, UA by m dot Cp minimum. U is the overall heat transfer coefficient, A is the area of heat exchanger, m dot Cp is what, the product of mass flow rate into specific heat. Okay, तो जो भी small होगा like hot or cold, that you need to take. Heat capacity rate ratio is what, m dot Cp minimum, m dot Cp small by m dot Cp big. So the performance of a heat exchanger is directly proportional to NTU and it is inversely proportional to C. Okay, effectiveness or performance of a heat exchanger is directly proportional to NTU. NTU बढ़ेगा तो effectiveness बढ़ेगी, but अगर C बढ़ेगा effectiveness will decrease. Effectiveness maximum कब होगी बच्चों, the effectiveness will be maximum. Okay, the effectiveness will be maximum with C equal to 0. With C equal to less 1, the effectiveness will be lower. So effectiveness is inversely proportional to C and it is directly proportional to NTU. C क्या है, C is the ratio of m dot Cp small divided by m dot Cp big या large आप बोल सकते हो big. ठीक है, this is known as heat capacity rate ratio. So this is another expression for the effectiveness of parallel and counter flow. तो ये भी आपको याद होना चाहिए बच्चों, एक्सप्रेशन ऑफ इफेक्टिवनेस फॉर पैरेलल एंड काउंटर फ्लो हीट एक्सचेंजर। इसमें एक इंपॉर्टेंट केस बन जाता है इफ यू आर हैविंग ए इवोपरेटर और कंडेंसर। सो इवोपरेटर और कंडेंसर के लिए सी क्या हो जाएगा बच्चों, सी विल बी 0. व्हाई, बिकॉज सी इज नथिंग बट m dot Cp स्मॉल बाय m dot Cp बिग। और ये क्या होगा बच्चों, दिस इज इनफाइनाइट। ये क्या है, इनफाइनाइट है, बिकॉज ड्यूरिंग फेज चेंज द मैक्सिमम हीट कैपेसिटी इज इनफाइनाइट। फेज चेंज किस पे होता है बच्चों, फेज चेंज तो होता है कांस्टेंट टेंपरेचर पे। फेज चेंज टेक्स प्लेस एट कांस्टेंट टेंपरेचर। सो C is equal to 0 फॉर फेज चेंज। फॉर फेज चेंज, जब भी फेज चेंज होगा, whether you are having a boiler or condenser, for the phase change C equal to 0. Okay, so if you are having C equal to 0 means you are having a case of evaporator or condenser, the effectiveness of parallel counter both will be same and that is equal to 1 minus e की power minus NTU. ठीक है, तो ये याद रखना। And when you are having a counter flow heat exchanger, C equal to 1, this is the another expression. C equal to 1 for parallel flow, this is the expression for effectiveness, and this is the expression for effectiveness of a counter flow heat exchanger when heat capacity rate ratio equal to 1. Both hot and cold fluid, they are having same heat capacity rate ratio. ठीक है, चलिए रेडिएशन में ये कुछ बेसिक चीजें बच्चों जो आपने जरूर पढ़ा होगा। एमिसिविटी क्या होता है, मैं इस पे टाइम वेस्ट नहीं करूंगा अभी। ओके मैं सीधा कुछ इंपॉर्टेंट फॉर्मुलेशंस पे आ जाता हूं. फॉर एनी जनरल सरफेस द सम ऑफ एब्जॉर्टिविटी रिफ्लेक्टिविटी प्लस ट्रांसमिसिविटी क्या होता है बच्चों, दैट इज इक्वल टू 1. ओपेक सरफेस के लिए हाउ वी कैन राइट transmissivity will be 0 for an opaque surface. For black surface absorptivity equal to 1. White surface is what ideal reflector, so reflectivity equal to 1 for a white surface. Kirchhoff's law tells us ideal absorber is also a ideal emitter of electricity, ideal emitter of heat. So alpha absorptivity equal to emissivity for a body in equilibrium. Planck's law क्या कहता है, the spectral emissive power of a body is a function of wavelength and temperature. शेप फैक्टर बहुत इंपॉर्टेंट है गेट के लिए, यहां से क्वेश्चन पूछता है बच्चों. तो दो इंपॉर्टेंट रूल है, वन इज द रेसिप्रोसिटी रूल, अनदर वन इज द समेशन रूल. समेशन रूल याद रखना, हाउ वी कैन यूज समेशन रूल, और रेसिप्रोसिटी रूल भी आप याद रखना फॉर द शेप फैक्टर. फ्लैट प्लेट के लिए, कन्वेक्स सरफेस के लिए सेल्फ शेप फैक्टर क्या होता है, 0 होता है बच्चों. और कनकेव सरफेस के लिए सेल्फ शेप फैक्टर क्या होता है, इट इज ग्रेटर देन 0 लेस देन 1. ठीक है, बट कोई भी फ्लैट सरफेस है या कन्वेक्स सरफेस है, सेल्फ शेप फैक्टर क्या होता है वहां पे, 0. तो बहुत इंपॉर्टेंट ये रिलेशन काम आते हैं हमारे पास गेट में रिलेटेड टू शेप फैक्टर. रेडिएशन नेटवर्क, हाउ वी कैन राइट द रेडिएशन नेटवर्क बिटवीन टू प्लेट्स. ये कोई एक प्लेट है, कोई दूसरा प्लेट है, इसका एमिसिविटी है एप्सिलॉन 1, रिजर्विंग एमिसिविटी एप्सिलॉन 2, इट इज एट टेंपरेचर T1 T2. तो दिस इज द एक्सप्रेशन गाइस. कितना रेजिस्टेंस होंगी, देयर विल बी टोटल 3 रेजिस्टेंस. वन इज द surface resistance of 1, surface resistance of 2, and third one is the space resistance between 1 and 2. So this is the expression for the surface resistance, 1 minus epsilon 1 divided by epsilon 1 A1. This is known as surface resistance of surface 1. This is the surface resistance of surface 2, and this is the space resistance between 1 and 2. तो टोटल देयर आर 3 रेजिस्टेंसेस. अगर आप शील्ड लगा दोगे तो टोटल रेजिस्टेंस हो जाएंगी 5. शील्ड लगाने से रेजिस्टेंस हो जाएंगी कितनी, 5. ओके, तो एक सरफेस, 2 सरफेस, 3, 4 तो हो जाएंगी सरफेस रेजिस्टेंस. ओके, 4 हो जाएंगी आपकी, टोटल रेजिस्टेंस हो जाएंगी 6. सो ए शील्ड, एडिशनल शील्ड इज गोइंग टू ऑफर 3 एडिशनल रेजिस्टेंसेस. तो टोटल रेजिस्टेंस कितनी हो जाएंगी, 1 2 3 4. 4 विल बी द सरफेस रेजिस्टेंस, बिकॉज सरफेस रेजिस्टेंस क्या होगी, 4 होगी बच्चों. व्हाई, because surface resistance of 1, surface resistance of 2, surface resistance of shield this side, surface resistance of shield this side. So there will be total 4 surface resistance and 2 space resistance. This one is the space resistance between 1 and 3, and this is the space resistance between 3 and 2. So total a shield is going to offer additional 3 resistances. So normally there will be 3 resistances, but additional shield is going to offer additional 3. So total resistance will be 6 when you are having a shield between 2 plates. ठीक है, चलिए तो ये क्यू नेट है, कैसे हम लिख सकते हैं याद रखना. सो केस, पहला केस है प्लेट के लिए, बहुत इंपॉर्टेंट फार्मूला है बच्चों. जब हम क्या मान के चलते हैं कि इनफाइनाइट लॉन्ग प्लेट्स है, इनफाइनाइट लॉन्ग प्लेट्स, तो F11 F12 क्या हो जाएगा, दैट इज इक्वल टू 1. तो वहां पे दिस इज द एक्सप्रेशन व्हिच वी यूज टू फाइंड आउट क्यू नेट बिटवीन 1 and 2. Q net equal to sigma T1 की पावर 4 minus T2 की पावर 4 divided by 1 minus epsilon 1 plus 1 by epsilon 2 minus 1. Okay, तो बस ये केस किसका है, when you are having infinite long plates separated by a very small gap. Infinite long plates separated by a small gap. देखो NTU अप्रोच, देखो इतना ही आपको याद रखना है बच्चों. अगर आपको 3 टेम्परेचर गिवन है, लाइक सपोज द डेटा विच इज गिवन टू यू, यू आर हैविंग 3 नोन टेम्परेचर्स. ओके, हॉट का, कोल्ड का, तेरा टोटल 4 टेम्परेचर्स ना, हॉट फ्लूइड इन, हॉट फ्लूइड एग्जिट, cold fluid in, cold fluid exit. So out of those 4, if 3 temperatures are known to you, you can go for LMTD approach. But if only 2 temperatures are known to you, then first you need to obtain the effectiveness. आपको effectiveness निकालना पड़ेगा. Okay, आपको क्या निकालना पड़ेगा, effectiveness, Q actual by Q max. Okay, Q max क्या हो जाएगा, m dot Cp minimum into THI minus TCI. Okay, ये तो हो जाएगा आपका Q max. ओके, ऊपर क्या आएगा, ऊपर यू कैन राइट हीट Q एक्चुअल. अब Q एक्चुअल आपका इट में भी m डॉट C CPC into TCE minus TCI भी लिख सकते हो, और यू कैन राइट इट एज Q एक्चुअल, यू कैन राइट इट एज m डॉट C CPC into TCE minus TCI, ये भी लिख सकते हो, और यू कैन राइट इट एज m डॉट H CPH into THI minus THE. Okay, so in this expression, any one if you are using this or this, कोई भी आप यूज करोगे, so only you require two temperatures. Like suppose you are having two temperatures and effectiveness is known to you, then easily you will be able to find out third temperature. कैसे? देखो अगर आप ये वाला यूज करते हो, so suppose m dot cp c is lower, तो अगर आप मान ले कि m dot cp c is less than m dot h cp h, तो वहां पे इफेक्टिवनेस क्या हो जाएगी बच्चों? इफेक्टिवनेस इज इक्वल टू TCE minus TCI divided by THI minus TCI. So if two temperatures are known to you, और वो दो टेम्परेचर कौन से होने चाहिए बच्चों? Those two temperatures are the inlet temperature of hot and cold fluid. So if you are having two known temperature, hot fluid in, cold fluid in, and if you know the effectiveness, then easily you will be able to obtain the third temperature. Fourth, you will be able to find out using the energy balance equation. So this is known as NTU method. So first, you need to obtain the NTU. Based on the NTU, you need to obtain the effectiveness, and using the effectiveness relationship, you need to obtain the third temperature. ठीक है? Third से, if you are having three temperature, then you can find out fourth temperature also using the energy balance equation, and you can find out the LMTD, you can find out the heat transfer also. ठीक है? तो you need to check what data is given to you. You are having three known temperature or you are having only two known temperature. ठीक है? तो उसे हम बोलते हैं effectiveness NTU method. चलिए, तो ये केस है किसका? फॉर ए केस ऑफ लॉन्ग सिलेंडर, इनफाइनाइट लॉन्ग सिलेंडर, दिस इज द फॉर्मूला. तो F12 इक्वल टू 1, F21 इक्वल टू 1. तो इसको आप कहीं भी अप्लाई कर सकते हो जहां तक आपके पास F12 क्या हो? 1 हो, और F21 क्या हो? लेस देन 1. तो बहुत इंपॉर्टेंट केस बन जाता है हमारे पास बच्चों, एंड दिस वी कैन फर्दर रिड्यूस assuming A1 very less than A2. So if you are having a very small body in a large room, like a bulb in a room, okay, so very small body in a room, then the A1 will be very less than A2. तो ये जो formula है, this formula you can further reduce. Okay, so if this term is approaching zero, ये term अगर approach करेगा zero को, then you can reduce this formula something like this. Sigma T1 की power 4 minus T2 की power 4 into A1 into epsilon 1. So this is a case of small body in large enclosure. याद रखना, ये कब आप अप्लाई कर सकते हो? When A1 is very less than as compared to A2. Okay, चलिए, तो ये याद रखना बच्चों. These are the important formulas. This is another important formula to find out error in temperature measurement. So the temperature of the gas minus temperature of the thermocouple, that difference is known as error of the thermocouple. And the error of the thermocouple, error of the temperature measurement is nothing but sigma temperature of thermocouple की power 4 minus duct की power 4 divided by H multiplied by emissivity of the thermocouple. तो दिस इज नोन एज एरर इन टेम्परेचर मेजरमेंट. बहुत इंपॉर्टेंट फॉर्मूला है, यहां से इसको आप याद रखेंगे. द टोटल रेडिएशन विच इज लिविंग फ्रॉम ए पर्टिकुलर सरफेस, दैट इज नोन एज इरेडिएशन. ठीक है? टोटल रेडिएशन coming on a particular surface, total radiation which is incident on a particular surface, that is known as irradiation. Total radiation, total energy leaving from a particular surface, that is known as radiosity. तो इन दोनों के बीच में एक बहुत इंपॉर्टेंट रिलेशनशिप है, ये आपको याद रखना चाहिए. रेडियोसिटी J इक्वल टू E plus rho G. Okay, इसको आप ऐसे भी लिख सकते हो. Okay, and this you can further write. So this expression sometime we can use to find out emissivity. ठीक है? तो याद रखेंगे इसको आप. रेडिएशन शील्ड, मैंने आपको बताया शील्ड, समटाइम वी प्रोवाइड सम काइंड ऑफ शील्ड बिटवीन द रेडिएटिंग सरफेस टू रिड्यूस द हीट ट्रांसफर. बिकॉज विद शील्ड देयर विल बी एडिशनल 3 रेजिस्टेंसेस. यू कैन काउंट इट हियर. देखो टोटल कितना रेजिस्टेंस है? 6 रेजिस्टेंस है. 1 2 3 4 5 6. ओके, तो दिस इज द फॉर्मूला गाइस. यहां पे एक स्पेशल केस बन जाता है इफ यू आर हैविंग ए शील्ड which is having emissivity equal to the emissivities of surface. So all 3 radiating surfaces, shield and other 2 surfaces, they are having same emissivities. तो वहां पे you will have Q net with shield equal to 1/2 of the Q without shield. So अगर एक शील्ड लगाओगे with one shield, the heat transfer will reduce by 50%. हीट ट्रांसफर आपका 50% कम हो जाएगा बच्चों. With one shield, heat transfer will reduce by 50%. But the case is what, guys? All the 3 surfaces, you are having a case of flat plate, infinite long plates, okay, separated by a very small gap. And the second most important case is all surfaces like the shield and the radiating plates, they are having same emissivities. So in that case, heat transfer with shield equal to 1/2 heat transfer with shield. या इसको आप ऐसे भी कर सकते हो, हीट ट्रांसफर 1/2 विद शील्ड इक्वल टू 1/n plus 1 into Q without shield, where n is the number of shield provided. Okay, तो कई बार वो ऐसा पूछ लेता है, if you want to reduce the heat transfer by 90% आपको हीट ट्रांसफर रिड्यूस करना है. You want to reduce the heat transfer by 90%. Then how many shields you need to provide? So you want to reduce the heat transfer by 90% means this will be only 10%. ये क्या रहेगा आपका 10% हो जाएगा. This will be 10% of this. So you will have a formula something like this: 0.1 equal to 1 by n plus 1. ठीक है, या n plus 1 equal to 1 by 0.1. तो इसको मैं कर सकता हूं 10. मतलब आपको कितना शील्ड लगानी पड़ेगी? You need to attach 9 शील्ड. आपको 9 शील्ड लगानी पड़ेंगी बच्चों. इफ यू वांट टू रिड्यूस द हीट ट्रांसफर बाय 90%, तो इस तरह से आपको यूज करना पड़ता है. ठीक है, अगर वो आपको बोले कि इफ यू वांट टू रिड्यूस द हीट ट्रांसफर बाय 75%, so 75% रिड्यूस करना है, so 0.25 इक्वल टू 1 बाय n प्लस 1, so n प्लस 1 इक्वल टू 4, मतलब n इक्वल टू 3. आपको कितना शील्ड लगानी पड़ेगी? 3 शील्ड लगानी पड़ेगी. रिड्यूसिंग हीट ट्रांसफर बाय 50%, you need to attach 1 शील्ड. रिड्यूसिंग हीट ट्रांसफर 75%, you need to attach 3 शील्ड. 90% के लिए क्या करना पड़ेगा? 0.1 इक्वल टू 1 बाय n प्लस 1. इस तरह से आप निकाल सकते हो नंबर ऑफ शीट्स. चलिए, यहां से मेरे को लग रहा है बच्चों इस बार वो क्वेश्चन पूछेगा. ओके, लास्ट में मैंने ये ऐड किया है. यहां से देयर आर हाई चांसेस ऑल सब्जेक्ट्स, सभी सब्जेक्ट्स मेरे बाद अभी नेक्स्ट 15 मिनट्स के बाद, मेरे ख्याल से 15-20 मिनट में आई विल ट्राई टू कवर. फिर सकलानी सर आएंगे एंड ही विल कवर द सोम एंड प्रोडक्शन पार्ट आल्सो. सोम, प्रोडक्शन, इंडस्ट्रियल, सकलानी सर विल केम एंड ही विल कवर दैट पार्ट आल्सो गाइस. तो टोटल हम कवर करने वाले बच्चों ऑल मैकेनिकल इंजीनियरिंग सब्जेक्ट्स वी आर गोइंग टू कवर. ठीक है, तो इसको देखो बच्चों, यहां पे मेरे को लग रहा है कि इस बार एक क्वेश्चन यहां से आना चाहिए. एमिसिविटी, हाउ यू कैन फाइंड आउट एवरेज एमिसिविटी. एवरेज एमिसिविटी आप कैसे निकाल सकते हो? दिस इज अनदर फार्मूला वी डिस्कस्ड इन वेरी डिटेल अबाउट दिस फार्मूला गाइस. एनपीटीईएल की क्लासेस में हमने इसके बारे में डिस्कस किया था. चलिए नेक्स्ट हम बात करते हैं. नेक्स्ट सब्जेक्ट है हमारे पास, अच्छा कन्वेक्शन बचा है. कन्वेक्शन हीट ट्रांसफर, क्यू कन्वेक्शन, हाउ वी कैन राइट क्यू कन्वेक्शन, न्यूटन्स लॉ ऑफ कूलिंग, बकिंघम पाई थ्योरम, रेनॉल्ड्स नंबर. देखो डिफरेंट नंबर्स हैं जो आपको पता होना चाहिए. रेनॉल्ड्स नंबर हम कैसे निकालते हैं? लैमिनार फ्लो के लिए इट इज लेस देन 2000 फॉर द फ्लो इनसाइड पाइप. ओके, एंड फॉर लैमिनार फ्लो ओवर फ्लैट प्लेट रेनॉल्ड्स नंबर इज लेस देन 5 lakhs. रेनॉल्ड्स नंबर इज नथिंग बट इट इज रेशियो ऑफ इनर्शिया फोर्सेस बाय विस्कस फोर्सेस. प्रेंडल नंबर क्या होता है? न्यू बाय अल्फा. Prandtl number is equal to 0.7 for air, 7.5 for water. Liquid metal के लिए it is very low and for heavy oils it is very high. Nusselt number, which is function of Reynolds number and Prandtl number in case of forced convection. In case of free convection, Nusselt number is a function of Grashof number and Prandtl number. Or you can say Nusselt number is a function of Rayleigh number because the product of Grashof and Prandtl that is known as Rayleigh number. ठीक है, तो चलिए ये याद रखने पड़ेंगे आपको सभी फॉर्मूलाज. ग्राशॉफ नंबर क्या होता है? इनर्शिया इनटू बायंसी बाय स्क्वायर ऑफ विस्कस फोर्सेस व्हिच इज नथिंग बट जी बीटा डेल्टा टी एल क्यूब बाय न्यू स्क्वायर. ठीक है, तो इन केस ऑफ फ्लो ओवर फ्लैट प्लेट ऑल प्रॉपर्टीज आर ऑब्टेन्ड एट फिल्म टेम्परेचर एंड इन केस ऑफ फ्लो इनसाइड पाइप वी ऑब्टेन ऑल प्रॉपर्टीज एट व्हाट? बल्क मीन टेम्परेचर. फोर्स कन्वेक्शन में जनरली वी एज्यूम ए काइंड ऑफ पैराबोलिक वेलोसिटी प्रोफाइल. पैराबोलिक वेलोसिटी प्रोफाइल एज्यूम करते हैं और ये कुछ रिलेशनशिप हम यूज करते हैं. तो आपको कन्वेक्शन के लिए कुछ घबराना नहीं है. दे आर गोइंग टू प्रोवाइड सम रिलेशनशिप and you need to use that relationship only. So you need not to worry, sir I need to remember formulas related to convection. नहीं, कुछ याद नहीं रखना, बस बेसिक अप्रोच आपको याद रखनी है. how to utilize that formula means what is what do you mean by local Reynolds number या आपका एवरेज कन्वेक्शन हीट ट्रांसफर कोफिशिएंट क्या होता है. इफ यू आर अवेयर अबाउट दोज काइंड ऑफ यू नो those kind of rules or those kind of the different terms in those formulas, then easily you will be able to get the answer. But अगर आपको terms ही नहीं पता है, then obviously you will not be able to utilize the formula which they are going to provide you in the question. तो convection के लिए, because in earlier also the questions which they asked, they are going to provide you some kind of correlation. Okay, laminar, turbulent, हर केस के लिए they are going to provide you correlation. तो फ्लो फ्लैट प्लेट के लिए द एवरेज कन्वेक्शन हीट ट्रांसफर कोफिशिएंट इज 2 times of the local heat transfer coefficient, but for case of turbulent flow the average convection heat transfer coefficient is 5/4 of the local convection heat transfer coefficient. ठीक है, तो ये रिलेशन आप थोड़ा सा देखेंगे. फॉर turbulent flow in pipe we use Dietz-Boelter equation where n equal to 0.4 for case of heating, n equal to 0.3 for case of cooling. ठीक है, चलिए laminar flow in pipe दो केसेस होते हैं. कांस्टेंट हीट फ्लक्स, नसल नंबर 4.36, कांस्टेंट वोल्ट टेंपरेचर, नसल नंबर 3.66. ठीक है, So you are having a constant wall temperature case or constant heat flux case. Based on that, you need to use the Nusselt number, and Nusselt number is nothing but hd by k. So if you're having a laminar flow inside pipe with the constant heat flux, then Nusselt number 4.36 you can equate it with hd by k, and easily you can enjoy the value of h in that case. Free convection, जब कोई एक्सटर्नल कोई एजेंसी नहीं है, there is no such external agency which is forcing the air or fluid over the surface, that is known as natural convection. The motion will be due to what? Density difference, okay, or due to natural gradients, that is known as natural or free convection. ठीक है, तो फ्री कन्वेक्शन में फॉर द केस ऑफ वर्टिकल प्लेट h बार एवरेज कन्वेक्शन हीट ट्रांसफर कोएफिशिएंट इज 4/3 HL. This is for laminar flow. Turbulent flow के लिए average convection heat transfer everywhere it will be same. This is the case of laminar flow over vertical plate. Convection में, because in free convection also you can have laminar flow and turbulent flow. You know, if Rayleigh number is less than 10 की power 9, Rayleigh number अगर आपका less than 10 की power 9 है, you will have laminar flow. If it is Rayleigh number is greater than 10 की power 9, you will have a turbulent flow. ठीक है, Rayleigh number is nothing but it's a product of Grashof into Prandtl. तो Grashof Prandtl का प्रोडक्ट अगर 10 की पावर 9 से कम है, you will have laminar flow over the vertical plate. ठीक है, and in that case this is h bar average convection coefficient, and this is h bar for the case of turbulent flow over vertical plate. तो ये कुछ आप modified Grashof number है जो हम यूज करते हैं for the case of vertical plate with constant heat flux case. ये कुछ सेट रूल्स है बच्चों, हाउ टू फाइंड आउट कैरेक्टरिस्टिक डायमेंशन फॉर वेरियस केसेस. लाइक यू आर हैविंग ए रेक्टेंगल, तो रेक्टेंगल के रेक्टेंगुलर डक्ट, यू आर हैविंग ए रेक्टेंगुलर स्क्वायर डक्ट, सो कैरेक्टरिस्टिक डायमेंशन इक्वल टू 4 क्रॉस सेक्शनल एरिया डिवाइडेड बाय वेटेड पेरीमीटर. दिस फार्मूला जनरली वी यूज फॉर फाइंडिंग आउट व्हाट द कैरेक्टरिस्टिक डायमेंशन इन केस ऑफ इंटरनल फ्लो. सो इंटरनल फ्लो के लिए हम ये वाला फार्मूला यूज करते हैं बच्चों, वेदर यू आर हैविंग इंटरनल फ्लो थ्रू डक्ट, इंटरनल फ्लो थ्रू पाइप. ओके, so same formula we use. External flow के लिए you need to check external flow over flat plate. If the flow is along the width, then width is the characteristic dimension. If the flow is along the length, then length is the characteristic dimension. So these are the different cases. Like cylinder case, the flow is outside the cylinder, so the length of the cylinder is the characteristic dimension. The flow is across the cylinder, out external flow across the length, then the diameter is the characteristic dimension. ठीक है, चलिए ये कुछ जनरल रूल्स हैं. यू नो, लैमिनर फ्लो और फ्लैट प्लेट, जैसे जैसे x बढ़ता है, डेल्टा बढ़ता है, हाइड्रोडायनामिक बाउंड लेयर थिकनेस इंक्रीजेस, द थर्मल बाउंड लेयर थिकनेस इंक्रीजेस, रेनॉल्ड्स नंबर भी बढ़ता है, बट कन्वेक्शन हीट ट्रांसफर कोएफिशिएंट डिक्रीज करता है, एंड टाउ वाल भी क्या करता है आपका, डिक्रीज करता है. x के बढ़ने से, जैसे जैसे x बढ़ेगा h विल डिक्रीज एंड टाउ वाल विल आल्सो डिक्रीज, बट द रेनॉल्ड्स नंबर, थर्मल बाउंड लेयर थिकनेस एंड डेल्टा all are going to increase. The bound layer thickness will be something like this. Okay, ये कुछ डायग्राम है जस्ट टू शो यू ए काइंड ऑफ डेवलपिंग फ्लो. अभी मेरे ख्याल से इसका ज्यादा डिस्कशन रिक्वायर्ड नहीं है. चलिए अब हम थोड़ा सा बात करते हैं बच्चों थ्योरी ऑफ मशीन का. ठीक है, थ्योरी ऑफ मशीन की बात करते हैं. थ्योरी ऑफ मशीन में सबसे पहले तो आपको पता होना चाहिए कि डिग्री ऑफ फ्रीडम कैसे निकालते हैं. ठीक है, सो ये फार्मूला है जो हम यूज करते हैं टू फाइंड आउट डिग्री ऑफ फ्रीडम 3 into n-1, वेयर n आर द नंबर ऑफ लिंक्स एंड n आर द नंबर ऑफ लोअर पेयर एंड n2 आर द नंबर ऑफ हायर पेयर. तो बहुत इंपॉर्टेंट फार्मूला थ्योरी ऑफ मशीन में सबसे पहला आपको पता होना चाहिए टू फाइंड आउट द डिग्री ऑफ फ्रीडम. ठीक है, डिग्री ऑफ फ्रीडम, if it is 0 you are having a structure, degree of freedom equal to 1 you will have a mechanism. Negative degree of freedom means you are having a superstructure. ठीक है, गियर ट्रेन के लिए डिग्री ऑफ फ्रीडम विल बी 2 also. Joint pair, binary pair, ternary pair, quaternary pair, what is the relationship between ternary and quaternary pair? With binary pair that relation is in front of you. Lower pair का मतलब क्या होता है? Lower pair means surface contact, higher pair means line or point contact. ठीक है, so different pairs है आपके पास. Grashof criteria क्या होता है बच्चों? Grashof criteria, the length of the shortest and the longest link. Length of the shortest and the longest link, if it is if it is greater than the length of the other two links, if it is greater than the length of other two links, you will have a double rocker mechanism. अगर ये उससे कम होगा, you will have different inversions. If the length of the shortest and longest is less than the length of other two links, you will have different inversions based on which link you are fixing. Okay, based on which link you are fixing. तो जैसे जैसे अगर आप D को फिक्स करोगे, अगर आप जो आपका longest था, because D is the longest, D is the smallest link, if you are fixing the smallest link, स्मॉलेस्ट को अगर आप फिक्स करोगे देन यू विल हैव डबल क्रैंक. अगर बी को फिक्स करके अपोजिट टू द शॉर्टेस्ट देन यू विल हैव डबल रोकर. इफ यू विल फिक्स ए और सी एडजेसेंट टू द शॉर्टर देन यू विल हैव क्रैंक रोकर. ठीक है. इफ बोथ आर इक्वल द लेंथ ऑफ द लॉन्गेस्ट एंड शॉर्टेस्ट दैट इज इक्वल टू लेंथ ऑफ अदर टू लिंक यू विल हैव डबल क्रैंक मैकेनिज्म. स्टोन क्रशर टॉगल पोजीशन में मैकेनिकल एडवांटेज क्या होती है आपकी? इनफाइनाइट होती है. 4 बार मैकेनिज्म यू आर हैविंग डिफरेंट इन्वर्जन्स, डबल क्रैंक, क्रैंक रोकर, डबल रोकर. ठीक है, बेस्ड ऑन दी लिंक विच यू आर फिक्सिंग. थोड़ा सा लाइट है ये बिकॉज थोड़ा सा लाइट है, आपको मैनेज करना पड़ेगा थोड़े टाइम के लिए बिकॉज एक दो स्लाइड्स हैं, थोड़ा सा जो लाइट आएंगे अपने पास. क्विक रिटर्न मैकेनिज्म के लिए हाउ टू फाइंड आउट द क्विक रिटर्न मैकेनिज्म, क्विक रिटर्न मोशन. ठीक है, सो क्विक रिटर्न रेशियो कई बार आपसे पूछ लेता है क्विक रिटर्न रेशियो, तो वो आपको आना चाहिए. क्विक रिटर्न रेशियो हम कैसे निकालते हैं? ये कुछ इन्वर्जन्स हैं डबल स्लाइडर के. ओके, these are some of the inversions of double slider like elliptical tremors, Scotch yoke, Oldman's coupling. Okay, these are the inversions of double slider. Single slider के और double sliders के आपको दोनों के पता होना चाहिए what are the different inversions. Instantaneous center, you know, instantaneous center, how to find out number of instantaneous center? तो n into n minus 1 divided by 2. This is the formula to find out number of instantaneous center. कुछ रूल्स भी होते हैं इसके लिए, वो भी आपको पता होना चाहिए. लाइक यू आर हैविंग ए पीवियट और पॉइंट काइंड ऑफ पीवट लिंक, रोलिंग बॉडी है, या यू आर हैविंग ए काइंड ऑफ सरफेस मूविंग ऑन ए फ्लैट बॉडी. सो स्लाइडिंग पेयर बना रहा है या रोलिंग पेयर है या आपका पिन जॉइंट है, तो बेस्ड ऑन दैट देयर आर सम सेट रूल्स. ठीक है, फॉर द आई सेंटर, इंस्टेंटेनियस सेंटर. कैनेडीज थ्योरम, बिल्कुल. अगर आपके पास 3 लिंक्स है बच्चों इन ए प्लेनर मैकेनिज्म व्हिच आर हैविंग सम काइंड ऑफ रिलेटिव मोशन अमंग देम, देन देयर आई सेंटर मस्ट लाई ऑन द स्ट्रेट लाइन. तो कैनेडीज थ्योरम को भी हम यूज करते हैं टू फाइंड आउट दीज काइंड ऑफ आई सेंटर्स. सो दीज आर द फॉर्मूलाज गाइस टू फाइंड आउट द वेलोसिटी, एक्सेलरेशन, पिस्टन एफर्ट. ठीक है, so I hope you all have revised these kind of formulas. तो अभी just I'm showing guys so that you will be able to recall these formulas. ठीक है, you know time is very much important and we are having very less time also, so I hope you all are revising these important stuff. तो flywheel के लिए how to find out the mean speed of flywheel, यहां से क्वेश्चन पूछता है आपसे. वो flywheel के लिए यहां से बहुत बार क्वेश्चन पूछा जाता है. लास्ट टाइम भी गेट में क्वेश्चन आया था लाइक हाउ टू फाइंड आउट द फ्लक्चुएशन ऑफ एनर्जी. फ्लाईव्हील के लिए फ्लक्चुएशन ऑफ एनर्जी कैसे निकालना है, मीन स्पीड एंड कोफिशिएंट ऑफ फ्लक्चुएशन ऑफ स्पीड. W max minus W min divided by mean speed, that is known as coefficient of fluctuation of speed. तो coefficient of fluctuation, okay, coefficient of fluctuation of energy, ये सब आपको पता होना चाहिए. Flywheel generally we consider it as a disk. So disk के लिए inertia क्या होता है? It is mr square by 2 or you can write it as mk square also. ठीक है, so these are very very important formulas guys for flywheel. Flywheel के लिए बहुत बार क्वेश्चन यहां से पूछा जाता है, तो आपको ये ध्यान रखना चाहिए. ठीक है, तो नेक्स्ट मैं बात करता हूं गियर ट्रेन की. गियर ट्रेन में वेलोसिटी रेशियो, गियर रेशियो. ठीक है, सिंपल ट्रेन बहुत बार क्वेश्चन पूछता है आपसे. गियर ट्रेन के लिए मॉड्यूल अगर आपको पता है d1 by d2 equal to t1 by t2 which is equal to n2 by n1. तो कई बार क्वेश्चन पूछा जाता है सिंपल गियर ट्रेन से, या यू आर हैविंग ए काइंड ऑफ एपिसाइक्लिक गियर ट्रेन. तो एपिसाइक्लिक गियर ट्रेन से बहुत बार क्वेश्चन पूछे जाते हैं, तो वो क्वेश्चंस आपको आने चाहिए. ये मैं थोड़ा सा स्किप कर देता हूं क्योंकि ये पार्ट थोड़ा सा विजिबल नहीं है. ठीक है, थोड़ा सा विजिबिलिटी इशू आएगा. मैं वाइब्रेशन वाले पार्ट पे आता हूं. यहां पे vibration, you know guys, different bodies they are having some kind of mass, they are having stiffness, and due to mass and stiffness if some kind of external force you apply, that is going to induce vibration inside the body. So generally we assume kind of harmonic vibrations. So in that kind of case of harmonic vibrations, the displacement x we can write it as a sine omega t plus phi. Okay, where omega is the natural frequency, a is the amplitude of vibration, phi is the phase difference. ठीक है, तो यहां से बहुत बार हम फॉर्मूलाज यूज करते हैं टू फाइंड आउट द डिस्प्लेसमेंट, वेलोसिटी एंड एक्सेलरेशन. ठीक है, सो स्प्रिंग मास सिस्टम के लिए द नेचुरल फ्रीक्वेंसी वी कैन राइट इट एज अंडर रूट k by m और वी कैन राइट इट एज अंडर रूट g by delta आल्सो, वेयर डेल्टा इज द स्टैटिक डिफ्लेक्शन. डेल्टा को क्या बोलते हैं हम? स्टैटिक डिफ्लेक्शन. ओके, ओमेगा is equal to under root k by m where k is the spring stiffness, m is the mass of the spring, mass of the body attached. ठीक है, g by delta, delta is the static deflection. सो यू नो वन मोर रिलेशनशिप ओमेगा इक्वल टू 2 पाई एफ, या इसको आप ऐसा भी लिख सकते हो 2 पाई बाय टी, वेयर एफ इज द फ्रीक्वेंसी एंड टी इज द टाइम पीरियड. Omega is the natural frequency, this is f, the frequency in hertz, and this is 2 pi t, where t is the time period. ठीक है, तो कई बार वो आपसे फ्रीक्वेंसी पूछ ले या आपसे टाइम पीरियड पूछ ले, तो यू कैन यूज दिस रिलेशनशिप टू फाइंड आउट टाइम पीरियड और फ्रीक्वेंसी. ओमेगा के लिए हम याद रखते हैं, बट इफ यू वांट टू फाइंड आउट f, so f will be 1 by 2 pi omega, so 1 by 2 pi in root k by m, that is the expression for frequency. Similarly for time period, t equal to 2 pi by omega means 2 pi divided by m by k, that is this is the expression for time period. Time taken to complete one cycle, that is known as time period. The number of cycle per second, that is known as frequency. So if you are having spring in parallel, then directly you can add their stiffness. Springs in parallel, equivalent stiffness equal to k1 by plus k2. If you are having springs in series, then equivalent stiffness will be 1 by k equivalent equal to 1 by k1 plus k2. So sometimes he can give you some cases of springs in series or springs in parallel. ठीक है, तो देखो आपको पता है, इफ यू आर हैविंग ए केस ऑफ समथिंग लाइक दिस, आपने यहाँ पे कोई केस लगा दिया, यू नो आपका जो डिफ्लेक्शन होगा, ओके, डेल्टा, दैट इज इक्वल टू PL by AE, और इसको आप कैसे लिख सकते हो, यू कैन राइट इट एज WL by AE आल्सो. दिस इज नोन एज स्टैटिक डिफ्लेक्शन ऑफ दिस बॉडी, एंड यू नो ओमेगा इक्वल टू अंडर रूट G by डेल्टा. ओके, दिस इज इक्वल टू अंडर रूट G by delta is nothing but WL by AE. Okay, तो AE ऊपर चला जाएगा, so you will have a formula something like this, AE by ML. So this is the expression to find out the natural frequency in these kind of cases. So you need to have some expression for the static deflection, and if you know the static deflection easily by using under root G by delta, you can write the expression for natural frequency. So अगर आपके पास कोई floating body है, floating in a water, और आप इसको डिस्टर्ब कर देते हो, so what will be the natural frequency for that kind of floating body, that also you can write omega n equal to under root rho Ag by m. Okay, density area, this cross sectional area multiply by G acceleration due to gravity divided by mass of the body. ठीक है, चलिए, damped vibration, how to find out damping factor, this which is equal to C by Cc. C by Cc, that is known as damping factor. तो ये आपको पता होना चाहिए. डैम्प्ड वाइब्रेशन में हाउ टू राइट द डैम्प्ड नेचुरल फ्रीक्वेंसी. सो डैम्प्ड नेचुरल फ्रीक्वेंसी इज इक्वल टू ओमेगा n स्क्वायर अंडर रूट 1 माइनस जीटा स्क्वायर. दिस इज नोन एज डैम्प्ड नेचुरल फ्रीक्वेंसी. लोगरिथमिक डिक्रीमेंट, अगेन अनदर इंपॉर्टेंट फॉर्मूला. ठीक है, क्रिटिकल डैम्पिंग जीटा इक्वल टू 1, ओवर डैम्पिंग जीटा ग्रेटर देन 1, एंड अंडर डैम्पिंग जीटा लेस देन 1. ठीक है, थोड़ा सा लाइट है, इसलिए मैं इस पे ज्यादा अभी आपका वो नहीं करूंगा, क्योंकि आई थिंक दीज आर नॉट वेरी मच क्लियरली विजिबल. ठीक है, तो ये फाइल यू विल गेट, आप इसको जरूर रिवाइज करना. वेल्डिंग में मैं थोड़ा सा और डिस्कस करता हूं, देन आई विल एंड, एंड सकलानी सर विल टेक अप दिस सेशन फर्दर. ठीक है, तो ये आर्क वेल्डिंग में बच्चों, इन आर्क वेल्डिंग यू नो वोल्टेज एंड करंट कैरेक्टरिस्टिक, दिस फॉर्मूला यू नीड टू नो. Voltage and current characteristic. OCV, open circuit voltage, short circuit current, where V and I are the operating voltage and this is the operating current. So this is known as voltage current characteristic. ये आपको पता होना चाहिए. ठीक है, another formulas for the efficiency in welding, heat transfer efficiency. This is known as heat transfer efficiency. So heat transfer efficiency, how much heat transferred to the weld joint and how much heat you have supplied. So heat supplied is nothing but I square RT. इसे हम क्या बोलते हैं, heat supplied. इसको बोल सकता हूँ VI. So VI is the heat supplied, but out of that heat supplied, how much is heat is transferred to the body, that is known as heat transfer efficiency. कितना एक्चुअल में ट्रांसफर हुआ, कितना आपने सप्लाई किया, सप्लाई कितना किया I square RT, कितना ट्रांसफर हुआ, that is known as heat transfer efficiency. Melting efficiency क्या होता है बच्चों, out of the total heat transferred, how much heat is going into the melting of a particular material. कितना हीट बॉडी में जा रहा है उसको मेल्ट करने के लिए, because the total heat which you are supplying, out of that some you are going to lose. Okay, कुछ ना कुछ हीट आप क्या करोगे, लूज करोगे. So the total heat which is going to melt the material divided by total heat you are supplying, total heat you are transferring, that is known as melting efficiency. So heat transfer efficiency, melting efficiency आपको पता होना चाहिए कैसे हम निकालते हैं. ठीक है, ड्यूटी साइकिल क्या होता है, I square D. अब ये कई बार क्वेश्चन पूछ लेता है आपको, कई बार क्वेश्चन आपको पूछ लेता है, करंट दे देता है कि 6 एम्पियर पे ड्यूटी साइकिल इतना है, अगर आप करंट चेंज कर देते हो तो ड्यूटी साइकिल क्या हो जाएगा. तो वहां पे हम कई बार ऐसे यूज करते हैं I1 स्क्वायर D1 इक्वल टू I2 स्क्वायर D2. ओके, So at a particular current, what is the duty cycle? And if you are changing the current, duty cycle आपका कितना change हो जाएगा? They can ask you these type of questions. कास्टिंग में आपको कुछ बहुत इंपॉर्टेंट फार्मूलेज हैं बच्चों. कास्टिंग में बहुत इंपॉर्टेंट फार्मूलेज हैं गेटिंग सिस्टम से रिलेटेड. टाइम फिलिंग के लिए कितना टाइम लगना है आपको, ठीक है, गेटिंग सिस्टम के लिए. तो ये बहुत इंपॉर्टेंट फार्मूलेज आपको बन जाते हैं कास्टिंग में. टाइम ऑफ फिलिंग, बॉटम गेटिंग सिस्टम है आपके पास, ठीक है, तो किस तरह से आपको निकालना है, या टॉप गेटिंग सिस्टम है, हाउ टू फाइंड आउट द टाइम फॉर फिलिंग. शेप ऑफ स्प्रू के लिए आपको रेशियो पता होना चाहिए. R इज द रेशियो विच इज ए रेशियो ऑफ द A3 by A2. दिस A3 लोअर by A2, दैट रेशियो इज R. ओके. राइजर के लिए आपको क्या होना चाहिए, यू नो, टाइम, सोल्डिफिकेशन टाइम इज रिक्वायर्ड टू बी वेरी हाई. तो मॉडुलस क्या रखना पड़ता है अपने को, मॉडुलस इज रिक्वायर्ड टू बी वेरी हाई फॉर ए राइजर. राइजर के लिए मॉडुलस अपने को बहुत ज्यादा रखना पड़ता है. जनरली वी कीप इट 1.2, मींस 20 टाइम्स मोर देन द मॉडुलस ऑफ कास्टिंग. द मॉडुलस ऑफ राइजर वी कीप 20 टाइम्स मोर देन द मॉडुलस ऑफ कास्टिंग. मॉडुलस क्या होता है, इट इज द रेशियो ऑफ द वॉल्यूम टू द सरफेस एरिया. ओके, वॉल्यूम टू द सरफेस एरिया. मॉडुलस राइजर का क्या रखते हैं हम, ज्यादा रखते हैं, सो दैट it will take much time. अगर मॉडुलस ज्यादा है तो V by A will be high, so the riser is going to take much time in the solidification. ठीक है. So top riser के लिए find out volumes and area, that is also given to you. Top riser के लिए how to find out volume, how to find out area, so these formulas you need to have. Modulus already I discussed, the ratio of volume by area, that is known as modulus, and for riser it is required to be 20% more than the modulus of casting. ठीक है बच्चों. सो ये कुछ फॉर्मूलाज हैं जो हमने डिस्कस किए. अभी फ्लूइड मैकेनिक्स है, तो आप फ्लूइड मैकेनिक्स के बच्चों अगर आप ये सिर्फ फॉलो करते हो, लाइक आई डोंट नो यू हैव स्टडीड फ्लूइड मैकेनिक्स, देन दिस स्लाइड 4 पेजेस स्लाइड ऑफ फ्लूइड मैकेनिक्स इफ यू विल कवर, देन इजीली यू विल बी एबल टू रिकॉल ऑल फार्मूलाज रिलेटेड टू फ्लूइड मैकेनिक्स. ठीक है, तो जल्दी से सिर्फ इसको ऊपर कर रहा हूं बिकॉज आई नीड टू एंड इट हियर. आपका टाइम भी बहुत इंपॉर्टेंट है आज. ओके, एंड Suklani sir is also waiting. So I'm going to just slide over these kind of important formulas from fluid mechanics. Bulk modulus, ठीक है, Mach number, Newton's law of cooling, you know, shear stress directly proportional to shear strain. So where to use this F equal to mu A V by V, linear velocity profile, that also you need to know. Excess pressure, jet में कितना होता है 2 sigma by D, bubble में, drop में कितना होता है 4 sigma by D, and in bubble the excess pressure is 8 sigma by D. Okay, तो ये फार्मूलाज आपको पता होना चाहिए. कैपिलरिटी राइज क्या होता है, ग्लास ट्यूब में 4 सिग्मा cos थीटा by WD, where W is the weight density, rho g. Buoyancy force, the weight of the fluid displaced, that is known as buoyancy force. Hydrostatic force, the force exerted by the fluid over any kind of surface when it is immersed in a body, in a fluid, that is known as hydrostatic force. Okay, so hydrostatic force horizontal, vertical या inclined surface पे, the formula is WA x bar. Okay, where x bar is the distance of CG from the free surface, W is the weight density, A is the area. Okay, चलिए, so location of the center of pressure H star, that also important formula for us. How to find out location of the center of pressure. Stability criteria guys, for completely submerged body and for floating body. For completely submerged body, center of buoyancy, if it is greater than, if it is above G, you will have stable equilibrium. If center of buoyancy and this center of gravity both lies at the same point, you will have neutral equilibrium. And if center of gravity lies above the center of buoyancy, you will have unstable equilibrium. But in the case of floating body, meta center lies above G, you will have stable equilibrium. Meta center and G, they lies at same point, neutral. Meta center lies below G, you will have unstable equilibrium. So stability condition very very important. How to find out metacentric height guys? बहुत इंपॉर्टेंट फॉर्मूला है BM minus BG, where BM is I by V, where I is the moment of inertia, V is the volume displaced या volume immersed. V कौन सा वॉल्यूम है, volume displaced या volume immersed, ये वाला जो वॉल्यूम है बच्चों, this is volume displaced या volume immersed. Okay, so this is this volume, ये वाला जो वॉल्यूम है ये है, I is the moment of inertia. So BGM easily you can find out अगर आपको BG पता है. Okay, so BM minus BG you will get from the geometry. Okay, BG आपके पास कहां से आ जाएगा, ज्योमेट्री से. Okay, because location of the G you know, location of G you know from the geometry of the body, location of B you know from the geometry of the displaced volume. And if you know the location of G and B, you will get the value of X also, you will get the value of Y also, and X minus Y, that is what, that is the difference between B and G. So if you know this, अगर आपको ये पता है, then easily you can find out metacentric height. इक्वेशन ऑफ स्ट्रीमलाइन, जनरलाइज कंटिन्यूटी इक्वेशन, कंप्रेसिबल फ्लो, ये सब आपको पता होना चाहिए बच्चों। मैं बहुत ज्यादा इसमें टाइम नहीं लूंगा। आई होप यू ऑल आर अवेयर अबाउट दीज काइंड ऑफ फॉर्मुलेशंस। ठीक है, रोटेशनल कंपोनेंट, स्ट्रीम फंक्शन, साई वेलोसिटी पोटेंशियल फंक्शन। ठीक है, चलिए बर्नौलीज इक्वेशन, यू नो इट्स अ काइंड ऑफ मैकेनिकल एनर्जी बैलेंस इक्वेशन। ठीक है, which tells us about the total energy is constant for a kind of steady, incompressible and in viscous flow. For steady, incompressible, in viscous flow, the total energy is constant. So these are the assumption and the flow along a streamline. ठीक है, चलिए वेंचुरीमीटर, these are the formulas guys, बहुत इंपॉर्टेंट फार्मूला है to find out the discharge, theoretical discharge. Okay, and actual discharge is nothing but CD times of the theoretical discharge, where CD is the coefficient of discharge, which is actually a product of CC into CV, coefficient of contraction, coefficient of velocity. Q actual by Q theoretical, that is known as coefficient of discharge. अब इसमें एक चीज ध्यान रखना, H क्या है? H जो हम लेते हैं, H equal to X times of rho m by rho minus 1. X क्या है? Manometric difference. So here this H is not the manometric difference. So H equal to X times rho m by rho minus 1, where rho is the density of the measuring fluid, rho is the density of the flowing fluid. So density of the measuring fluid divided by density of the flowing fluid minus 1 multiplied by manometric head, you will have head loss in terms of the flowing fluid. So this H you need to mention in terms of the flowing fluid. तो ये वाला याद रखोगे। बाकी A1 क्या है आपका पाइप एरिया, A2 इज द थ्रोट एरिया, और वेंचुरी का जो आपका थ्रोट सेक्शन होता है, A2 इज द एरिया ऑफ दैट थ्रोट सेक्शन। पिटो ट्यूब हम यूज करते हैं बच्चों टू मेजर द वेलोसिटी, एंड यू नो द डिफरेंस ऑफ द स्टैग्नेशन हेड माइनस स्टैटिक हेड, दैट इज नोन एज काइनेटिक हेड। सो स्टैग्नेशन हेड माइनस स्टैटिक हेड, दैट इज इक्वल टू व्हाट? काइनेटिक हेड, v स्क्वायर बाय 2g। बट यहां पे h क्या हो जाएगा? अगेन h हेड इन टर्म्स ऑफ द फ्लोइंग फ्लूइड, दैट h इक्वल टू x टाइम्स rho m by rho minus 1. ये फॉर्मूला यूज करेंगे if rho m is what? Measuring fluid density is more than the density of the flowing fluid. So this formula generally we use when rho m is greater than rho. तो ये भी बहुत इंपॉर्टेंट फॉर्मूलाज है जो हम यूज करते हैं। विस्कस फ्लो में बहुत इंपॉर्टेंट फॉर्मूला हमारे पास आता है, विस्कस फ्लो और लैमिनर फ्लो थ्रू पाइप, रेनॉल्ड्स नंबर लेस देन 2000 फॉर पाइप के लिए, फ्लो और फ्लैट प्लेट रेनॉल्ड्स नंबर लेस देन 5 lakhs। तो हम बात कर रहे हैं हाइगन पोस्टली फ्लो, मींस स्टेडी फुल्ली डिवेल्प्ड फ्लो थ्रू पाइप्स। सो फॉर स्टेडी फुल्ली डिवेल्प्ड फ्लो थ्रू पाइप्स, वेलोसिटी प्रोफाइल पैराबोलिक होता है, शियर स्ट्रेस कैसा होता है आपका? लीनियर होता है, एंड दिस इज द एक्सप्रेशन फॉर द शियर स्ट्रेस, टाउ इक्वल टू माइनस del p by del x into r by 2। तो at center it will be 0, tau wall equal to 0 at center। सेंटर पे क्या हो जाएगा बच्चों? 0 हो जाएगा। यू कैन चेक here, सेंटर पे क्या होगा? इट विल बी 0 because r will be 0 at the center। radius we are going to measure from the center only, and wall shear stress is maximum at the surface। सरफेस पे कितना हो जाएगा? tw equal to minus del p by del x into r by 2। तो बहुत इंपॉर्टेंट फॉर्मुलेशन हमारे पास बन जाती है फॉर हैगन पोस्टली फ्लो, u equal to umax into 1 minus r square by capital R square, where r is the distance where you want to measure the velocity and r is the radius of the pipe। ठीक है, umax equal to minus 1 by 4 mu del p by del x into r square, q equal to umax by 2 into pi r square। another important relationship, how to find out discharge। लैमिनर फ्लो में ये बहुत इंपॉर्टेंट फॉर्मूला है बच्चों, p1 minus p2 pressure drop in a pipe 32 mu vl by d square, or head loss if you want to write, head loss equal to 32 mu vl by rho g d square, because head loss is nothing but pressure drop divided by rho g। ठीक है, तो इसको यू कैन राइट इन टर्म्स ऑफ डार्सी-वेचबैक इक्वेशन आल्सो। डार्सी-वेचबैक इक्वेशन, हेड लॉस इक्वल टू FL v स्क्वायर बाय 2GD, और अप्रोक्सीमेटली यू कैन राइट इट एज FL q स्क्वायर बाय 12.1 d की पावर 5, वेयर F इज नोन एज व्हाट? फ्रिक्शन फैक्टर। इसे हम क्या बोलते हैं? फ्रिक्शन फैक्टर। फ्रिक्शन फैक्टर, फ्रिक्शन कोएफिशिएंट इज you know it is 1 by 4 of F। so F dash means friction coefficient is equal to F by 4, या friction factor is 4 times of the friction coefficient। friction coefficient which is also known as fanning coefficient। friction coefficient को हम क्या बोलते हैं? fanning coefficient। this friction factor is also known as Modi's coefficient। ठीक है, तो बहुत इंपॉर्टेंट फॉर्मूलेज हैं, मेरे ख्याल से आपने जरूर ये पढ़े होंगे एंड यू विल बी इजीली एबल टू रिकॉल। तो शियर स्ट्रेस का, वेलोसिटी प्रोफाइल, प्रेशर ड्रॉप, हेड लॉस, these are the very very important formulas for laminar flow in pipe, Hagen-Poiseuille। steady flow, Steady incompressible flow in pipe. Pipe in series, when you are having a case of pipe in series, the discharge will be same through all different points. So Q equal to Q1 equal to Q2 equal to Q2, but the total head loss equal to head loss in 1 plus head loss in 2 plus head loss in 3, and this is the formula which we use to find out equivalent length. Le by de की power 5 equal to L1 by d1 की power 5, L2 by d2 की power 5 plus L3 by d3 की power 5. बहुत इंपॉर्टेंट फॉर्मूलाज है which is known as Dupuit equation. इसे हम क्या बोलते हैं? Dupuit equations. चलिए, pipes in parallel case में we generally assume similar pipe, like this pipe both are similar in all manners. हर manner में pipes क्या हैं? Similar है, diameter, their length, their types both are same. So that case generally we assume. So in that case, if you are having similar pipes, head loss 1 equal to head loss 2, and the total discharge equal to discharge through 1 plus discharge through 2. So Le by de की power 5 equal to 1 by n square, number of pipes in parallel, similar pipes in parallel, into d की power 5. So this is again very important formula to find out equivalent length in case of pipes in parallel. हेड लॉस हम कैसे निकालते हैं? मेजर हेड लॉस तो यहां से निकालते हैं, डार्सी-वैशवर्थ इक्वेशन. सडन एक्सपेंशन, दिस इज अ फार्मूला टू फाइंड आउट हेड लॉस ड्यू टू सडन एक्सपेंशन. सडन कॉन्ट्रैक्शन के लिए ऐसे निकालते हैं. एग्जिट लॉस and entry loss and bend loss. So these are important formula, slightly less important as compared to Darcy-Weisbach equation. How to find out head loss? Sudden expansion, contraction, exit, entry. Power transmission through pipes. You know, sometimes we use pipes for power transmission. तो जब इनको हम power transmission के लिए use करते हैं बच्चों, for maximum efficiency of power transmission is 66.67%. Why? Because you are going to get maximum efficiency if head loss, the total head is 3 times of the head loss. ठीक है, तो ये भी कुछ फार्मूलाज है जो हमें हेल्प करते हैं. सभी फार्मूलाज नहीं है इसके फ्लूइड्स के, कुछ इसके मिसिंग है. ओके, सो नेक्स्ट Saklani sir will came and he is going to discuss with you the important formulas from production. तो production, strength of material, okay, and design, that Saklani sir will cover. Okay, so guys, thank you very much. देखो, we tried, you know, it is in that period 2 hours it is very difficult to cover all subjects. तो अभी तक अगर आप देखोगे, even you know, even if you will just turn the slides, it is very difficult to cover turn the slides in that much period. So I tried to discuss all important stuff so that you will be able to recall all those formulas. ठीक है, because at this moment guys you need to have that kind of confidence energy. देखो, हमने जो शुरू किया था, actually we started this all exercises from last year. जून से ही हमने जैसे ही गेट का शुरू किया था, we started all those things, but very critically we started from last 2-3 months when we started NPTEL assignment series, and I hope you all have participated, you all have enjoyed and practiced different questions through that NPTEL series. अभी के लिए आपको करना क्या है? जो भी आपने पढ़ा है, like you have studied some less part or या आपने पूरा पढ़ लिया है, just forget about all those things. बस आपको जितना आपने पढ़ लिया है, now it is sufficient. Go with full of energy, full of confidence. वो इस टाइम पे होना चाहिए. So some kind of confidence energy is required at this moment. जो भी score आए, okay, we will try to convert, we will try to, you know, utilize that score, because you know there are lots of opportunities in coming days for all of you. तो बिल्कुल भी आपको निराश नहीं होना है. Like you feel कि sir I have not covered the entire syllabus, I only covered 30 or 40%. So you then also you need to perform in the, you need to go in the examination with full of energy and you need to try to at least qualify that particular exam. तो बिल्कुल भी आपको घबराना नहीं है इस टाइम पे कि सर मैंने कम पढ़ा है, क्या मैं देने जाऊं ना जाऊं. तो बिल्कुल भी ऐसी नेगेटिविटी आपको छोड़ देनी है. Surely you need to appear in that exam guys. Even if you are in your final year, you need to appear in this final year and you need to try to score best. Okay, jitna bhi aa jaye that you need to accept, and then we will focus, we will on this YouTube only guys, and you know at our also we will discuss with you again after your GATE examination, like what are the opportunities available for all of you and how we can utilize that low GATE score also. But at this moment you need to target high and high. You need to give your best guys. There is no such comparison. आप दूसरे से comparison नहीं कर सकते. You need to give your best. ठीक है, and you need to decide what is your best. Okay, so best of luck and go with full of energy, full of you know confidence. Forget about your preparation. अभी की मेरा कम है ज्यादा है. Go with full of energy. ठीक है, thank you very much and keep preparing. Again we will meet after your GATE examination. Discussion करेंगे NPTEL series से क्या आपको help मिला उसमें, and what are the different opportunities available for all of you. Now you can wait for 3-4 minutes. मैं 3 मिनट लिख देता हूं यहाँ पे. So within 3-4 minutes you can have a break. 3 to 5 मिनट्स का ब्रेक मैं लिख देता हूं एंड देन सकलानी सर विल ज्वाइन. ठीक है, चलिए. सो गाइस, थैंक यू वेरी मच एंड हैव ए नाइस डे. गुड लक, बेस्ट ऑफ लक फॉर योर एग्जामिनेशन. थैंक यू. बच्चों पीडीएफ आपको वेबसाइट से मिल जाएगी. ऑन योर पीडीएफ वेबसाइट इफ यू विल गो, यू विल फाइंड द लिंक टू डाउनलोड दिस पीडीएफ. ठीक है, अभी मैं लिंक में कुछ इसका डिस्क्रिप्शन में जो आपका कमेंट सेक्शन है, मैं इसमें कुछ लिंक शेयर करवा देता हूं, सो दैट डायरेक्टली बाय क्लिकिंग ऑन दैट लिंक यू विल बी एबल टू डाउनलोड दिस पीडीएफ. ठीक है, या आपको एटलीस्ट प्रोसेस बता देते हैं हाउ टू डाउनलोड द पीडीएफ ऑफ दिस क्लास. थैंक यू.
Okay, so good evening, everyone. So let's now go ahead with the remaining portion of this that we are discussing. As you know, the formulas that we are discussing, which are going to be quite important from your exam point of view. It's a kind of a revision, right? So let's get started. So first, I will be discussing with the production engineering portion, metal cutting, metal forming portion, and then I'll be moving on to industrial portion also, some of the industrial portion, and then finally I will be discussing the machine design, right? And you're mentioning about this PDF link. I think you will be getting at the that comment box section. So immediately once this session is over, so I think you will be able to download. Right now, as the session is going on, you will not be able to download, right? So please wait for till that time. Okay. So I hope I'm audible, right? Okay. So if I'm not audible, you can let me know. So but what I understand is I will be audible. I may be audible. Okay. Let's go ahead with this particular section now. So here we have this starting with your rolling. As you know, this is a flat rolling sheet metal rolling portion. As you know, so normally there are two areas from where these questions are framed. One is that, okay, the simple process of this flat rolling, that is one area from where the question will be framed, like this geometry portion, and the other portion is related to power, uh, how to calculate the power and all that. So this is a geometry portion. As you know, you may have already gone through it. So these are some of the areas which you have to take note of. In this case, for example, what is the draft that you should know. Then obviously, definitely, as this is being processed or as rolling is being carried out, then you must be able to make use of the this volume flow rate equation, from where you can get the velocity at that particular, at any particular section. So at any two sections you can apply that volume flow rate equation, and these particular equations that you can obtain easily, right? They're going to be quite helpful for you in the examination. And one thing that you need to know, as the rolling goes on, then at the strip velocity goes on increasing, and there's going to be one point at the neutral point where velocity of the roll is going to be equal to the velocity of the strip, right? Then this is the most important equations that you have to keep note of, that what is the required condition, that for the unaided entry of the strip inside the roll, what is that condition which must be fulfilled so that this strip goes inside the roll. So as you know, this the mu should always be greater than the tangent alpha. So, and also if you write it in mu in terms of tangent phi, that is the angle of friction, then angle of friction should always be equal to the angle of contact at the that is strip roll contact at the center of this. Then finally, what is the maximum value of the this from here only? If you can just take note of, from here only, as you know, this is the end equation that you need to remember. That is the maximum thickness reduction possible, that depends upon the coefficient of friction and the roll radius. So I think one equation to calculate this equation that you need to remember, like how to calculate that value of alpha over here. Tangent alpha is equal to this, and then this equation of what is the maximum possible reduction in a single pass in case of a rolling operation. So directly questions are framed from here based upon these formulas, how to calculate alpha and how to calculate maximum thickness reduction, or maybe mu, or R may be asked. So as you move on, then these are the different terms that you must be clear about. For example, what is the draft, what is the relative draft, absolute elongation, and all those things. So they should be pretty clear to you. They are simply the kind of formula that you can say, simple formulas that you need to know. And one more formula which is going to be quite important for you from the exam point of view is the slip. How to calculate the slip in case of rolling process. So as you know, roll velocity remains constant. So all this slip, whether forward slip or backward slip, that is in terms of roll velocity. That is in denominator, you're going to have the roll velocity, and over there, this is the difference of the velocity between inlet and the outlet. Inlet and that at neutral section, or the roll velocity over here also it is the same way. So just remember these formulas of forward and backward slip. Directly question could be framed, right? That calculate the backward slip or calculate the forward slip. Then as we move on, then this is the another area which is the most important. So those three areas I told you. One is, for example, this is okay. Anyway, forward backward slip. The first one is this one, this equation, this area, this one, and this final equation, and this one. And the third area from where the question is framed is this particular calculation of the power. So how much power basically, or the force is, that is the first one is the how much force is required to deform that sheet metal, so that you can calculate from here. For example, that is the force required to deform will be equal to the true value of the stress and the area which is getting deformed. So where you know width, basically this is the projected area. As you know, you calculate projected length of arc of this contact, and this is the width of that particular strip. And projected length of arc of contact, just remember this one is this one, this is. So how you can calculate? So this is the projected length of arc of contact, this one from here to here, so that you can calculate very easily. And this is the true value of the stress, mean flow stress, what we call it. And so if you know that the stress, so mean flow stress multiplied by the area, just do that, and that becomes the force. So stress into area, in this case projected area. And from here also you can calculate that particular power also. As you know, how to calculate power, you have the basic power formula over here, that is 2 pi nt divided by 60. So only thing is that you need to know n is the speed of the rolls, you need to know the torque. So torque you can calculate very easily. That is a separated roll separating force, or the force that you just calculated, multiplied by that with this half of the distance. If nothing is given, half of the distance, this distance, that is a roll strip contact length or projected length of arc of contact that we said. So multiply with that, so you are going to get the torque. So force into, we call this as a lever arm, lambda. So normally if it is not given, then you are going to take it as a 0.5, half of LP, as simple as that. If it is given, then obviously he is going to specify the value. So just go through this PDF once this session is over and it is with you. So we will get to know. So that is all. So if you will talk to me about this rolling only 2-3 different kinds of questions broadly if we speak about, and these are the areas where you need to focus. Now let's go to the wire drawing. Now wire drawing, as you know, is related with your SOM also, where you have that stress, strain, and related concepts which are going to be helpful over here. So in wire drawing, first is these concepts that you have already studied. That is what is true stress, true strain, and what is the relationship between them, and that is given to you. So just remember the true stress and convention stress relationship, and that is true strain, and also how it is related to the convention strain, and this formula, this diagram that you may be knowing between this, so that you have already studied in case of what do we call it as a, in case of this SOM also. So these formulas are going to be helpful over here. The most important formula that you are going to make use of, जिसके ऊपर your questions are going to be framed in this particular section of wire drawing. Not only wire drawing, but others are extrusion drawing and extrusion and forging also. That is a Hollow-Mond relationship, which is given by this particular to define this portion of the curve in the plastic zone. That is, true stress is equal to K into epsilon raised power n, and you should know the value of what is the value of n. He may have given some kind of a relationship, and basically the slope, if we draw this, the same thing, this portion in the log graph, and corresponding to this maximum value of this, you're going to have this particular value, that is epsilon, it becomes equal to n. So this interpretation, very important, corresponding to maximum load, corresponding to this point, and this is a basic formula to define this. So I think if you are clear about these terms, what is the meaning of K, what is the meaning of N, and obviously this is a true strain, then I think you will be able to solve any question from this particular section. So just remember this Holomon relationship, very important from this particular topic point of view. Now there is another formula that is going to be quite important. We call it as a work formula for the homogeneous deformation, and this formula is used across all the plastic deformation processes, whether it is rolling, forging, or maybe you call it as the wire drawing, or maybe the rolling process that we have discussed. So this formula, just remember how to calculate the work formula for homogeneous deformation. So when you are deforming any material, then how much work you are spending in order to deform that material. So work done per unit volume is given by the area under the true stress, true strain diagram between the two strain limits. For example, deforming from here to here. So how you can calculate? You can calculate by integrating this one. So, or if you can just modify this formula, and if instead of this variable value of this, if you take the average value of the mean flow stress in this formula, and this becomes the true strain, so it becomes very easy. Work done per unit volume, true mean flow stress, and this becomes a true strain. So remember this formula, going to be very helpful in all the processes. And how to calculate this particular value of true? We are saying that, okay, if you see over here, we have used the term mean flow stress. Over here also we have used the term okay, right, not here, but if we go back to this particular rolling process also somewhere there, yes, if you see here also mean flow stress appeared. Mean flow stress in this finding of how much is the force required to deform the material in case of rolling process. Same way over here also in this formula, work done for the homogeneous deformation, there you are going to have this particular value, mean flow stress, which is appearing over here. So how to calculate? You can make use of this particular formula to calculate it. This is the formula that you may have gone through. Simply the area under the diagram divided by the that is the difference in the strain value between which you are deforming, that is epsilon 2 divided minus epsilon 1. So area under the diagram divided by this. From here, if you will integrate it, you're going to get this value, and if initial strain is not given, then you can use this formula directly over here. In most of the cases this is going to be. So if you want to calculate the mean value of flow stress, directly make use of this formula to calculate it, right? Now see, this is the how. Now what he will ask you in case of a wire drawing operation, he will ask you to find out the work done or force required to deform that particular wire, or the stress induced in the wire while deforming it. So drawing force, we call it as a drawing force. In case of a in this case, how much force you need to apply to draw that wire, so that you can calculate by remembering this formula, or if you're comfortable in equating this external work done in deforming the material by equating this with the work done in homogeneous deformation, I think you can do that. So if you don't want to do that, you can directly just remember this formula, make use of this formula. Either he can ask you to calculate the stress, then take this A2 to this side, PD by A2, then this becomes the drawing stress, and remaining terms will be over here. But if he's asking you to calculate the force required to deform, then simply make use of this equation. So remember this equation, quite important from this particular wire drawing section, where he very frequently asks you to calculate the value of this particular drawing force. So either calculate drawing force if you are remembered for the drawing force, then you can very easily calculate for the drawing stress, because PD divided by A2 will become the drawing stress. Now, and this is simple, like what is the degree of drawing? You should know the terms, that is kind of percentage drawing, changing cross-sectional area to the original. And then, so there is another way of, like, this is one way of just finding the drawing force or the drawing stress by making use of this concept. There is another way of, like, if you analyze the same process by different methodology, then this is a kind of formula that you can remember, where this is the what we call that. This is a basically a local stress evaluation method, where you can do the same thing. For example, if I want to find out the drawing stress, so how this is the variable, like at any particular point, if you want to find out while being deformed. But if you want to find what is the drawing stress over here at the end, you can find out from this particular formula. Just remember this formula, and he may give you the values of different parameters, and based upon that you can calculate the drawing stress. So one way of calculating the drawing stress is like homogeneous deformation, and that the formula that I show you. Another way of calculating is this, but particularly this formula is applicable when we are having the this coefficient of friction. So this formula is valid when coefficient of friction is given between this interface, and that formula that we discussed earlier is related when there is no kind of it's a ideal process and there is no friction. So directly remember these formulas, and you can. So there is high possibility that in he may ask the question based upon this also, right? He has asked earlier also directly. He gave you the formula, gave you all the values, and asked you to calculate. Now what he can do, he can give you the values, and he may not give you the formula, and you may have to use the formula and calculate this. Same thing can be done. For example, this is a round bar which from where you are drawing that particular wire of round cross section. Same can be done if, let us say, you are having a cross sectional area of like square cross section, and it is you are reducing its particular cross section. So for that, terms will change. For example, it was radius over here, it will be replaced by the height or thickness that you can talk about. So see, this formula and this formula looks like quite similar. Only difference is going to be, see, here it was 2b, here it is only b. Rest exactly same formula, only difference being that over there we are making use of the radius, here we are making use of the thickness of height, right? So you can correlate it. So these are some of the areas from where the question will be framed. These are not the sum of the, this is the totality of that particular topic. These are the only areas from where the question could be framed from this particular topic, if you are clear about them. Okay, so now let's move on to the next section. That is the forging. See, in forging, it's a kind of true strain. Very frequently he has asked the question based upon simple understanding of forging, particularly the open die forging, right? Where you are having a particular bar of particular height and you are deforming it to a lower height. So if you see true strain, how you can write? This is how you write it, right? In terms of length, you used to write it as this way, that is final length to the original length. But in terms of area, how do you write? Natural log of initial cross-sectional area divided by final cross-sectional area. But here it is not the length, we are talking about in terms of height. So we are reducing the height. So these values, instead of length, we will put in terms of height over here. So either this way, if you remember this formula this way, so in terms of length, if you want to write, you can write it this way, and in terms of height, if you want to write it, you can write this way. So from the volume consistency that you can make use of. So this is the formula that you have to remember. So it will be pretty easy for you to do that. On the similar lines, for example, if you want to calculate find out the load estimation, if you want to carry out. So I will not this, you should not at this moment go through all this, how we have founded it. Again, the concept is same. Work done now, done in homogeneous deformation and equating it to the external work done. That is the basic methodology that we will adopt. But how much force is required to deform the material, you can directly calculate from this particular formula. That is the force will be equal to mean flow stress multiplied by the cross-sectional area which is getting deformed. So if you remember the formula, cross-sectional area, which cross-sectional area? This cross-sectional area over here, which you are deforming to the final cross-sectional area. If you will simply, if I ask you how much is the force, you will say force required to deform this will be equal to the mean value of the force flow stress multiplied by the cross-section, this cross-section area which I am deforming. So in all these processes, if you see rolling, we will try to estimate how much load is required to deform the material. We see the formula. Same way in case of wire drawing, we see the formula how to when the material is deformed, a wire is drawn, then how much force we need to apply at the exit in order to draw that. Same way over here also in case of forging, if I want to estimate how much is the load required to deform the material, you can make use of this simple formula to find out the relevant values. Now let's go to the extrusion. Now in case of extrusion, as you know, here you are having this process is extrusion. Particularly I have shown this as a forward extrusion process. You are having backward extrusion process also. You know, the movement is in different direction. Movement of the ram is different to that of the movement of the extruded product. Over here also in extrusion, he is going to ask you what? He's going to ask you the work required to deform the material. Same process. See this formula and the work required to force required to deform the material, they are more similar with the wire drawing. What was the formula in wire drawing? Drawing force was equal to the exit diameter, cross-sectional area, mean flow stress into A1 by A2. That was the formula, right? See this formula and this formula, are they different? So work done to deform the material in case of forward extrusion process is the same formula, only difference being instead of A2 it is A1. That is the only difference, right? So very much related. So if you have remembered this formula for the wire drawing, just replace it with the initial cross section of this particular billet over here and your job will be done. Now this is the, whether this formula or this formula, they are for the ideal process where you are ignoring what? Coefficient of friction. You are ignoring, this is the ideal process. So this formula is for the ideal process. But let us say if you want to use the same formula in case of wire drawing, we had another formula when I was having coefficient of friction. But in this case, what we have done is we have modified this same formula when I'm considering the coefficient of friction also to account for the actual process. So what I have done is, if you see, this is the formula that you need to remember. So when you are using, what is the difference of using this formula and this formula? This formula is for actual process where you are going to have the coefficient of friction also. In homogeneous process deformation, this is for ideal process. So in case of forging, when you have to estimate the force required to deform the material, then you will use this formula. And let's say this is the actual process where he has given you the coefficient of friction and all that, you have to make use of a term called as K, where K we call it as a extrusion constant that you may be knowing. So extrusion constant. So instead of this, how you have to modify this formula? Just remove this value and use the extrusion constant. Rest formula remains same. So K will take into account the effect of friction and inhomogeneous deformation also. So these are the two formula that you have to remember in case of extrusion. Keep it in mind. One is for ideal process. This is for the actual process in which there is friction is also present and inhomogeneous deformation is also there. Then okay, on the similar lines, for example, there is another from the local stress evaluation method like we did in case of wire drawing. You can use that approach also. So here's the formula. This formula also looks like the same formula that you had in wire drawing. So there could be a possibility in this case, because from extrusion he has not framed the question from this section, but definitely he can explore into this area also. Just remember this formula, how to calculate, rather how to calculate that particular extrusion pressure. Rather, this is the formula, final formula, right? Just remember this formula, final formula to calculate the extrusion pressure or extrusion stress, that you can say this. Just remember this formula, have a lot of similarity with the wire drawing formula over there to find out the value of the stress, extrusion stress that you are applying over here. Am I clear? Terms that you have to keep note of and all that is given over here. Okay, so this was the bulk deformation processes that we discussed. Now we can move on to the next one, that is the sheet metal operation, sheet metal, this metal forming operation. So in this case, if you see, here is a deep drawing, right? So sheet metal deep drawing. So first and foremost, there is only one formula in this case, in this whole chapter, that you should know about from the exam point of view. That is to estimate the size of the blank, diameter of the blank required to make that cup shaped article. That is all. If you know that formula, then I think your job will be done. So this is the only formula that you have to remember, and pretty simple formula if you know the terms. For example, if I want to make a cup of this particular height and this much thickness in this much diameter, then what is the diameter of this blank required to make the dimensions of this cup or cup of this particular dimension? So this is the formula that you have to remember, as simple as. But the only thing is that you have to take note of this particular normally just cross check the value of that particular d by r ratio. D is the diameter and r is the corner radius over here. So if this corner radius is very small, then or diameter is very large compared to this corner radius, that is d is greater than equal to 20r, then you will make use of this formula. And if there is a small variation, for example, if d by r ratio is between 15 to 20, then just small modification minus 0.5 r. And if this d by r ratio is between this, then you will make use of this formula, and d by r is less than 10, then you will make use of this formula. But advisable, don't remember this formula. He's not going to ask this question from this particular section. Okay, if this is this, most probably you are going to get the question. Just check the d by r ratio, either this one, so easy to remember. In first one, this was not there, and now when you are having d by r ratio, then you will include this, and if d by r ratio is between this, then you will use this. So these three formulas are pretty easy to remember, and you can use. Don't go with this, don't remember this. This is just for the sake of your reference, that's all. So pretty simple to remember this formula. In any case, you may have remembered, And just remember these additional terms if d by r ratios are over there in order to estimate the diameter of that particular blank required to make the cup of that particular shape. That's all. Nothing more is required. Only one term is that you need to know. What is the meaning of draw ratio and what is limiting drawing ratio? That is draw ratio, diameter of the blank to the diameter of the cup, and limiting drawing ratio is the maximum diameter of that blank that you can make to make that cup without a wrinkle free cup, you can say, and to the diameter of the cup that you want to make. This was just for the explanation purpose, not required as of now. Just remember these formulas because he may ask you the draw ratio and all that. These are the some of things if you can remember. As you know, when we have to draw a deep cup, we cannot draw in a single stage. We have to go for the multiple steps. So maximum percentage reduction that you can obtain in each step is something this way. Then in first draw you can obtain only this much, in second draw. So as you will go on for multiple draws, number of draws will go on increasing, then the percentage reduction will also go on decreasing because material will get strain hardened. So reference value, he is going to give you the value in the that particular question, but this is for your reference only. You are not going to take these values from your side in the examination. That is important. Defects in this topic, from the different defects that you are having, he frames the question from this particular section, theoretical question. So just read this particular that what are the various defects and all that in case of deep drawing parts. Okay, so now, so in sheet metal, one is the drawing, only one formula as I told you and all that. Then we go to the metal forming processes, that means the shearing, blanking, punching, right? These are the three topics over here in this particular section. And shearing, you know, simple cutting of the sheet in this way. If you are having, you are cutting it simply. And blanking and blanking and punching, these are the operation, you know, blanking and punching operation. In case of blanking, the material which has come out of this we call it as a slug. Slug is the useful product, whereas in case of punching, the material which has come out is a waste, whereas the hole in the part in which we have created the hole, that is the useful product for us. So punching, hole making process. Blanking, making a blank, process of making blanks which are useful to us and we have to make use of in case of somewhere in other application like deep drawing and all that. Now important for you from the exam point of view is the how to calculate the clearance and all that. You know, obviously when we have to create a hole or we have to create a blank, definitely you need to have a punch and a die. And since punch is going to cut it, and that means edges of the punch and the die are going to cut that particular part, so they need to have a very small clearance. That is why if you will see, always punch is going to have a smaller diameter than that of the what? Die. So die diameter will always be greater than punch diameter. So if you see die diameter is this one, punch diameter is d1, then you are going to have a radial clearance. So this term you have to very important for you, that is C is the radial clearance. So this is radial, so the diameter of the die is going to be twice that of this. Same way you're having, if the die diameter is given to you, then punch size is going to be less than by twice of that particular. D minus 2C will be the diameter of the punch. Now, how to provide these clearances, how you are going to decide the size. So the basic rule that you have to keep it in mind, that diameter of the punch decide the diameter of the hole, and diameter of the die decide the diameter of the blank, right? So if that be the case, then obviously diameter of the punch, since diameter of the punch decide the diameter of the hole, ideally this is going to be the situation. Then punch diameter is going to be equal to the diameter of the hole. Just take it. And obviously die is going to be greater than by the twice that of the radial clearance. Same way, if for example, if I have to make a blank of particular size, then if let us say diameter of the, if you have to make a blank, so let's say that is a blanking operation. This was the hole making operation, punching operation. So diameter of the punch will be diameter of the hole. When I have to make a blanking operation, the diameter of the die will be equal, decide the diameter of the blank. So in that case, diameter of die will become equal to the diameter of the blank that we have to make, and diameter of the punch will be smaller than this. By what margin? By this much amount. So first part is the basic theme that you have to remember in this topic is that punch decide the diameter of the hole and the blank decide the diameter of the die decide the diameter of the blank. Now in addition to it, what you have to take note of is the what? the allowances, that how you have to provide the allowances, on which you have to provide the allowances. You know, when you cut the material, it is going to recover, and as you know, when you will cut a hole and the punch comes out, then diameter of the hole is going to be smaller finally. So what do you have to do? Make the punch larger. So we say that in case of a punching operation where I have to make a hole, then allowance is provided on the punch. That means what you have to do, you have to make a punch of larger size by an amount equal to allowance. Why? Because when you create a hole is going to be smaller. So if you are taking a larger punch, then obviously when you will create a hole, when it will come out, then since it has to become smaller, so you can get the final dimension. So allowance is provided on the punch in case of punching operation, whereas in case of blanking operation, as you know, when you will create a blank size is going to be larger when it will come out because of the elastic recovery. So what do you have to do? Since blank will become greater after being cut, so what do you do? Just reduce the size of the die. By what amount? By allowance. So it means in case of blanking operation, allowance is provided on the die. That is, die is made smaller than the diameter of the blank. So keep note of that. These are the only questions that are framed from this section. So if you have that concept clear with you, I think your job is done. Now let's go to the cutting forces. Cutting forces, as you know, this is a shearing process. So depending upon what kind of shape you are producing, simply you can find out how much force you need to apply in order to cut the material. For example, if you have to create a hole, then if I say what is the force that you need to apply, you will say that if you will give me the stress multiplied by the area which is getting sheared, your job is done. So in this case, this peripheral area is getting sheared. If you multiply with this ultimate shearing strength, multiply the shear area, your job is done. So stress, which stress? Ultimate shear strength, because you are shearing the material, you are not elongating or compressing. That is why we are using the ultimate shear strength multiplied by the shear area. In this case, it is going to pi dt, whereas if you are creating a rectangular hole or a blank, in that case, it is the perimeter. Basically, perimeter multiplied by the thickness. So perimeter of this multiplied by thickness, that is going to give you the this area. So this becomes the area in this case, whereas in this case, this becomes the area. And this is going to remain the depending upon material. So these are the only formula that you have to make use of in case of finding out the cutting forces. And then you know you are having different methods of finding out reducing that punch force, how to reduce the force. So we say that one of the method is called as providing shear on the punches. That is, shear का मतलब है कि उसको थोड़ा slant कर दो, kind of like you are having a needle. So needle जो होती है आपकी इंजेक्शन की needle जो होती है उसमें क्या होता है, एंड वाला पोर्शन जो है स्लैंट कर दिया होता है. सो व्हाट इज द बेनिफिट ऑफ दैट? बेनिफिट ये है कि आपको जो मैक्सिमम फोर्स अप्लाई करनी पड़ेगी दैट गेट रिड्यूस. सो फॉर एग्जांपल व्हाट वी डू इज ओवर हियर when we provide a punch with that particular what do we call it as a shear, we call it as a shear, right? So जब भी पंच को shear दोगी तो what do you need to do? The work done will be same. अगर मैं बिना shear का पंच लेता हूं, if I take a punch without shear and take a punch with shear, then if I say that to cut the material, same material of same thickness, in which case work done will be more, you will say work required will be same. चाहे मैं इससे काटूं चाहे इससे काटूं, work required to cut that material will be same. So इसीलिए if you see over there, work done over here will be equal to this one, that is the force into the distance traveled. K is the percentage penetration inside the material and thickness of the material. But when I have provided this shear over here, so what do you need to do? The force will not be same. This force and this force is different. This force is the force when you are shearing that is providing the shear on the punch. Then in this case, this is the distance traveled. So force into distance. In this case, force into distance is going to this much. Simply since this work is going to be same in both the cases, whether you cut by this or this. So it means this work done and this work done will be same. And when you will equate them, then from here you can find out that what is the maximum force that you need to apply if you provide shear on the punch. So see over here in this equation, simply you need to remember this work done formula. If you can remember this work done formula without and with shear, just equate them, you can get the value of the what is the force that you need to apply when shear is provided on the punch, and this is the force that you need to apply when no shear is provided on punch. Rest terms you should be clear about. And if shear is too large compared to this, then you can ignore, but in exam don't ignore it, you just go ahead with this. Okay, so this is the formula that you can. And another method of like reducing the force, maximum force that you need to apply is the staggering of the punches. But anyway, here the question on the similar line, basic formula that you need to make use of will be this one only. Okay, so I hope you got it. So only in this case, two areas on which you need to focus. One is this, how to find out the blanking and punching operation, how you need to find out the dimensions, how to include the allowances. One part is this, how to find out the cutting forces. That is the second part. And the third part that you have to focus will be on this particular, if I will provide the shear on the punches, and what is the maximum force that you need to apply. Obviously, maximum force required part will get decreased when I am providing shear on the punches. I am denoting it with the F max I. And this is the formula that you are having. Don't remember the formula, just you can go ahead with that. So if you have don't know the concept, then just remember the formula. I think you will be able to get the answer. Okay, now let's go to the next section, that is the cutting. Over here, these are the formula that you need to remember, right? In the shear angle determination, क्या formula आपने use करना है? So just go ahead with this formula. That is the chip thickness ratio. Chip thickness ratio ये in terms of velocity, and this, what is the term जिसको हम बोलते हैं chip reduction ratio को क्या बोलते हैं, ये term पता होना चाहिए, and how to find out the this angle, shear plane angle. तो ये formula जो है आपके, this formula important, and how to write R in terms of different parameters that are given to you. And what is this? So chip thickness ratio and 1 by R, 1 by chip thickness ratio we called as a chip reduction factor. That also should be clear to you. So ये आपको invariably metal cutting में terms use करने पड़ेंगे. You have to use this formula and this formula also invariably. So just remember these formulas. Then another relation that you need to remember is the relationship between the different velocity. You are having cutting velocity, shear velocity, and you are having the chip velocity. So using the velocity triangle, you can make use of this particular formula which you have with you. So directly when he is going to ask you to find out the particular velocity, maybe cutting velocity or shear velocity or chip velocity, आप velocity triangle और इस formula का use करके इसको निकाल सकते हो. So this is another formula that is important from exam point of view. Another formula, very important formula, is how to find out the shear strain. So shear strain के लिए ये formula आपको use करना, phi tangent phi वाला formula I have already told you. So in case of metal cutting, orthogonal metal cutting, how to find out the value of shear strain, directly वो formula based question पूछता है. और also over here आपका जो है वो this shear strain rate आपको पूछेगा. So shear strain rate with respect to time, shear strain with respect to this, but final formula जो आता है हमारा वो आता है, that is the shear velocity divided by the shear plane thickness. Just remember this formula. ये दोनों टर्म क्लियर होने चाहिए. If I want to write the shear strain rate, so shear velocity divided by thickness of the shear plane over there. तो ये डायरेक्टली फॉर्मूला आपको पता होना चाहिए. यही दो इसमें से डायरेक्टली पूछ लेता है, either this one or this one. Now single point cutting tool geometry आपको पता होनी चाहिए, different angles आपको पता होने चाहिए. You must be knowing how is the position of the angle, different angles. For example, you are having जो sequence है, different cutting angles. You are having rake angles, then relief angles, and you are having cutting angles, then nose radius. So he can ask you, okay, you must be able to interpret this whole. So this is an ASA system. You are having two systems, that is ASA system and ORS system. So in ASA system, these are the you are having angles which are mentioned over here: back rake, side rake, end relief, side relief, end cutting edge, side cutting edge angle, and this nose radius. Same way, for the same tool in ORS, you are having this designation. This is how we denote, and these are the terms, or these are the angles name that we have given to these angles. Tool is same, angles are same. Only thing is that the planes that we are using to measure those angles are different. But again, these are for the rake surfaces, these are for relief surfaces, these are for cutting edges and nose radius. So more or less sequence is same. Just remember the name of these particular angles in ORS system. And when we have to change that, carry out that interconversion between ASA and ORS angles, so you are having these formulas which you can remember. So he may be giving you the angles from the ORS system, and he may ask you to find out the equivalent angle in case of ASA system. So make use of these angles and this. Now, the most important topic, if I say in the most important formulas that you need to remember in this particular topic, that is metal cutting portion, are that of the merchant theory. Okay, so merchant theory, this is the all the forces that, so in merchant circle, you're having all those forces on at that particular cutting point that have been shown to you, and this when you will represent all these forces over there in case in the form of a circle, then this becomes a merchant circle. So in the merchant circle, you must be able to display all these forces which are acting at the that particular cutting area, and these are those forces, and in the form of there, and then you are having finally the angles. In terms of angle, you can represent over there, and from there these are the formulas. So these four formulas which you may not be able to get directly from this. So just remember these four formulas, this one and this one. I think it is easy to remember if you see cos phi, this and this formula are more or less related in the sense this FC FT. Okay, sorry, not this one and this one. If you see this one, so FT cos alpha sin alpha over here, only difference being on in angle. So if you remember this formula, you can write this formula also very easily, only difference being you have to change the angle. Same way this and this, they are more or less related in terms, here you are having angle alpha, whereas here you are having angle shear plane angle phi. So these four formulas, just remember, because you have to use these formulas invariably in order to solve the question. So once you know that, other relationships you can obtain from the merchant circle, which I have written over here. So these are the different relationships between different forces, which you can directly get it from here, because all of them are in terms of like this resultant force. If you see, if I want to find out the cutting force, then obviously you will say that is the component of resultant only. So component of resultant what? Cos of this angle. R is this. R cos of beta minus alpha will become equal to FC. So R cos of beta minus alpha will become equal to FC. So it means all these formulas that I have written over here, you can directly, by looking at this particular merchant circle, you can write them. So you don't need to remember these formulas. You can get it very easily if you know how to draw the merchant circle, which you can draw within 10 seconds. But these four formulas that I have told you over here, straightforward, you cannot get it from here. So you may going to have the confusion. So that is why you need to remember them. Then okay, then there is a theory of Ernst and Merchant, right? And this is just written to just find out how to find out the area of that particular force required to shear the plane. So that, just remember this formula. Directly question is framed sometimes, that shear stress, shear force divided by shear area. How to calculate the shear area? Shear area is the length into width. So how to calculate, that is written over here. So this formula is going to be helpful for you. And then you are having theory of Ernst and Merchant, where you are having some assumptions which are not required at this stage. But for you, the important is these end result of that particular this Merchant's force analysis. So keep it in mind. So you are having Merchant's force analysis, in which you are having this result 2 phi plus beta minus alpha is equal to 90, or you can write it this way also. But these are also further they modified their analysis, and you are having Merchant's second analysis also. So Merchant's second analysis is this one. So remember this also. So until in exam, if he does not specify anything, which one to use and all that, then you will go ahead with the Merchant's first analysis. But if he say, let's say if he wants you to find something and ask you to say that, okay, go with Merchant's first or Merchant's second analysis, then accordingly you make use of that formula. But if he has not mentioned anything, he's saying use Merchant's analysis, then go ahead with this particular Merchant's first analysis. Then there is a Lee and Schaeffer theory also. That is the similar kind of analysis was carried out by these Lee and Schaeffer, and for that he has given this formula. And this formula is pretty similar to the same Merchant's first analysis. If you see over here, if you modify this one, you're having phi by 4 beta minus alpha by 2. This is the Merchant's first analysis. In Lee and Schaeffer, if you remove this one 2, then you're going to have from here, remove this 2, this becomes the theory of Lee-Schaeffer formula, right? Only thing is you need to rewrite in terms of radian, right? That is the only thing. So easy to remember, nothing this. So this is very important, and this is another relationship where you need to make use of. That is in case of turning operation, that is the orthogonal turning operation. So simple turning operation, when we are talking about for example, let's say this formula is used to find out the width of the chip and the uncut chip thickness when depth of cut is given to you and the feed is given to you, when it is a oblique turning, when it is a orthogonal, when it is not a orthogonal turning operation. But when you will make this orthogonal, so first is remember these formulas for oblique turning operation. That is why if it is written, if it is not written, somewhere here I have written. So this formula is for oblique turning. So this is oblique turning, and to make this oblique turning orthogonal turning, you have to make lambda is equal to 90. So when lambda becomes equal to 90, then it becomes the over here CS 0 or lambda becomes 90. So when CS becomes 0 and lambda becomes 90, the same turning operation becomes the orthogonal turning operation, and all those formulas that we have discussed, they are for the orthogonal cutting only. So it means if you want to apply the formulas for all those formulas, first you need to have that orthogonal turning operation. You cannot apply those formulas for the oblique turning. So it means for orthogonal turning, what is going to happen when you will put lambda is equal to 90 in this formula, then width is going to equal to depth of cut, and unkerchief thickness is going to be the feed per revolution. So just remember this formula. So it is going to be quite helpful when he will give you an example of this orthogonal cutting, orthogonal turning. Now these are the formulas of that you have to remember. That is the cutting power, how much cutting power you need to make use of in case of this. So you know, cutting power, that is power required to shear, and then you are having the frictional power over here. So this formula should be clear to you. Material removal rate in terms of mm³ per minute or per second. So remember these formulas. Pretty directly question will be framed based upon this formula. And specific cutting energy formula also, that is the cutting power with respect to material removal rate. And over here unit is going to come as Newton per mm². So sometimes he will give you this value, specific cutting energy in Newton per mm². So you may get confused. So don't get confused, because it looks like the formula for the stress, right? But you know, when you will input cutting power and the material removal rate, then finally you will adjust the unit, it will come out in this way. So if he is giving specific energy in terms of Newton per mm², don't get confused. It is basically the meaning of this cutting power divided by material removal rate only. Specific material removal rate, just opposite of it, right? So material removal rate divided by cutting power. So unit will become mm² by per Newton. Okay, so this is the metal cutting, that means the single point cutting tool, and related to that, all the areas from where the questions could be framed, or the questions that you could have. One more area which I have not forgotten to include is that is tool life equation, that is Vt raised power n is equal to c. So pretty simple to use. That equation is the simplest one that you can go through, right? So now if we move ahead, then we are having a question which is can be framed from this particular section called as cutting time. Cutting time in this case of cutting time in case of shaping or planing. So all these parameters you need to know. So the equation that you need to know over here is the machining time, that is this one, and this one, that is the time required to complete one double stroke, number of double strokes required to complete the entire to go through the entire workpiece. So this formula that you must remember, pretty based upon this, because everything you have to do in this particular topic, shaping and planing, based upon this equation only. You have to remember this in any case. And also the same thing, how to calculate the TDS, that is the time required to complete one double stroke. You can write it this terms in terms of this, that is a cutting ratio term में आप ऐसे लिख सकते हो. And this way, if you input this value over there, again it's the same thing, TDS W divided by feed per double stroke. So input that value and you will be able to obtain. Sometimes he may give you that cutting velocity you may need to find out. So in that case, sometimes he may give you the number of double strokes per minute. So if he has given that value, then cutting velocity you can find out in terms of that also. So just remember these formulas for this, and that one. So I think in this topic only this much is required, and only based upon these 2-3 formulas the question will be framed, or you will be able to attempt any question. Time required for the machining. Normally machining time will be asked, and for that you need to require this one and this one. Now let's go to the drilling. Again, drilling also he will ask you to time required to drill that particular hole, right? So you need to know this formula. Again, distance traveled, again this is same formula, similar lines like you are having earlier also. So distance traveled divided by the feed per minute. So distance traveled will be in this direction, as you know. So this is the feed direction. So distance traveled, how much the drill traveled, and then feed per minute, and in this direction what is the velocity. So distance distance divided by velocity, it becomes the time. So you have, or velocity is equal to distance divided by time. So meaning is same. So if you will want to find out how much time it took for this drill to cut this hole, then you will say that okay, time required to travel this drill from here to here will be equal to the distance, how much distance divided by with what velocity it is moving. But velocity, not cutting velocity, that is a feed velocity, that is feed per minute. So simply that you have to make use of, and rest distance traveled, how much distance is traveled, that you will find out. You can find out. Approach is given to you. Let's say he has given you the actual depth of the hole and then over travel that he has to carry out. So just you have to make use, and if he has given you the angle, this point angle, then from there you may need to calculate that particular over travel over here, breakthrough distance, which we call it as over here. So from there we can calculate this way. So from here you can calculate the time required for machining. So this is the only formula that you have to use in case of drilling. Okay, same thing I have written over here. This much, how much distance is traveled, this one, whole, over travel and breakthrough distance. Combine them, this is the total distance traveled divided by feed velocity, feed per minute. So you can calculate. Okay, so now, okay, so that is what you have to do over here in case of machining. Now we can move on to the industrial engineering portion. And for this, I think I have not included one more section over here that you can just go through, is the milling portion. Again, in milling also 2 or 3 formulas you are having, and from there question could be framed. Now let's move on to the this particular section, that is the industrial engineering portion. In the industrial engineering portion, you are having this forecasting, and in forecasting, now he has started asking questions frequently from this particular section. Pretty easy. So you have to go through what are the different methods. You are having trend data, non-trend data, and then you are having like these in no trend data you are having these methods, and on this over here you are having regression analysis and all that. So these are the simple average, you know, simply add them up, divided by number of observation. This becomes simple average. Moving average, depending upon how many average, this is the total data. He's saying 3 period moving average, take the 3 observation and add them up, divided by 3. He's saying 4, just add the, take the latest 4 data, divided by 4, add them, divided by 4. Latest 5 data, is saying 5 period moving average, add the latest 5 observation, divided by 5. So we call it as a K period moving average. That means the simply average of the latest data. How much data? That K period. K period means the number of periods. So he will specify the number of periods. Here I have taken the example of 3 period moving average, added them and divided by 3. Another method is the weighted average. Weighted average, different weights are given to you. So these are the demand data, these are the weights given to you. Simply what you do is, this weight will sum up to 1, 0.5, 0.3, 0.1, 0.1, let us say they will become 1. So what you will do? Multiply by the weight respective demands and then divided by summation of this. So summation of them is going to be always 1. So that is why over there, if you're going to have is 1 only. So it means simply in weighted period moving average, simply multiply by the weights. That's all, and add them up. So this is going to have the forecast for the next period based upon weighted average. Now weighted moving average, like simple moving average, you are having the latest data. He will be giving the, for example, you are having this data, and for the latest data observation, he has given you the weights. Total weights will add up to 1, 0.6, 0.3, 0.1, total 1. So what you have to do? Simply again, as per the weighted moving average, if you have to forecast for the next period, simply multiply by the respective demand with the that weights and add them up. It is going to give you the forecast as per the weighted moving average. Okay, similarly, as we move on, then we are having this exponential smoothing. Very frequently question is framed from here. So just go through this formula. That is the, if you want to forecast for the next period, so you are having this very sophisticated, basically is a improvement on the weighted moving average. So just I think we have done the from NPTEL also many questions on these lines we have done already. So anyway, forecast for the next period, demand for previous periods, and alpha is the this forecasting smoothing constant. Just remember this formula, and based upon this formula, directly question will be framed to you. Then one more area is trend. Let's say if there is a trend on the data, then what we have to do is we have to use the regression analysis. So on regression analysis, when we have to forecast for the next period, so we'll find the best line fit, and to find out that particular equation of line, we will write the equation of line, because when we have to focus for the next, I will make use of the equation of line to focus the next period. So for that, I need to find out the constants A and B. So you can find out the constants by making use of these equations, and then go ahead and focus for the next period by putting these values over here, and you can find out the focus for the next period as per the linear regression analysis. Now, at the end, you are going to have the questions directly framed from this particular area. यहाँ से भी वो आपको question जो है बहुत frequently frame करता है, where he will ask you to calculate the error. Focused error निकालने की बात करता है. So these are the three methods which you make use of in order to focus to find out the focused error, the error that you have in your focus. So remember these formulas and how to make use of that and all that, and also note in case of bias. In case of bias, he may ask you to calculate whether that bias is positive or negative, right? So what is the meaning of positive? When positive value will be there, then it is a positive bias. When negative value will be there, it will be negative bias. But you should know the interpretation of that. What is negative and positive? Positive bias means underestimation, and negative bias is overestimation. So that must be, you must be able to interpret this. Okay, so that is all. I think these are the method. One is the error part. Another is you could have from linear regression analysis. The second one, the other ones that you are having methods are for the times, that is the constant data. For example, simple average, simple moving average, weighted moving average, and exponential smoothing. These are the only methods from where the questions are framed. Now, let's go to the inventory section, right? So in case of inventory, as you know, these are the different costs that you must be aware about, which are given to you. And then this is the first basic economic order model. So there are 2-3 models on which the questions are framed. One is a basic economic order model. So in basic economic order model, you need to remember these formulas. The economic order quantity formula that you need to remember, and how to calculate the total cost. Economic order model, and then he will ask you the total cost based upon this particular formula. Let's say if you are ordering this much, then how much will be the total cost that you need to know, remember this formula. And number of orders, how much number of orders that you need to place if you order this much quantity. And then finally, what is the time interval between the two orders if you are ordering this much quantity each time, which we call as a economic order quantity. We also call this as a economic order formula for this Wilson formula for economic order quantity. On the similar line, similar kind of formula or economic order quantity that you need to find out for other models also. These are the deterministic model. So this is a very basic model, which we call as a basic economic order model, where you are having the infinite production rate and all that. Then second model that you are having is this one. There is the gradual replenishment model. So in that case, there was, if you see in first model, there was no gradually production and consumption. Total quantity is supplied instantaneously, and also you go on consuming it continuously. But in this model, you are producing as well as consuming in parallel. So again, you have to find out the same formula. What you need to do? First, you need to find out the economic order quantity. Then economic order quantity, again, the same similar kind of formula you're having, like 2dc0 by cc. In earlier model, it was 2dc0 divided by cc. Whereas in this model, this is the additional term. So in all these formulas, if you will see over here, like with respect to the previous basic model, you are having this term is going to be additional. For example, total cost, this term is additional, right? Rest interpretation is same. Number of orders that you want to find out, the time period between the two orders that you want to find out, and optimal production time, how much you want. So these formulas you need to remember. If you remember them for one model, for other models, it's going to be pretty simple. Now, as we move on to the next model, which we called as a deterministic model with the shortage is allowed. In these earlier cases, there was no shortage was allowed, but in this case, shortage is allowed. Again, see the formulas more or less on the similar lines. With the, if you remember the formula for the first model, only small additions are going to. This is the economic order quantity for first model, basic model. In this model, this term got added. Now see, this term got added additional. Number of orders, demand divided by order quantity. Directly you can get again how much time between two orders. But if you see the total cost, all that, again, this is the additional term. This was the same thing which we had in the first model also. And then you are having a max inventory where you are having this term. So just take note of these things that, okay, if you have remember the basic economic order that model where you have calculated these different values, in other models you are going to have pretty easy. So these are the three deterministic models, normally from where the questions are framed. Not normally, all the time the questions have been framed from these three models only, and 90% of the time, or rather say I will say 85 to 90% of the time, the question have been framed from the first model. So if you remember, so you are going to quite safe. These formulas in the first model, this formula, economic order formula, and these terms related with that. So I think you're going to be have a lot of benefit. So now, if you see, this is the one area from where the question is framed. Another area from where the question is framed is the discount model. In case of first model, the other models that we discussed, three models, there was no discount was offered on the quantity that you are purchasing. But in these, when you are having discount offered, then you have to go through this particular process. So I have already discussed one question from the NPTEL assignments. Over there, I have solved this question. I have made use of those steps. So what you need to do is just go through these steps. If time permits, or if you have already gone through, just revise it. It is going to be quite helpful. So when you are having single discount model, then these are the steps. And when you are having double discount model, for single discount model, this slide, and double discount model, this is the approach that you have to use in order to find this is approach till this point. So double discount model, this one, and this one. Then finally you will be able to decide what should be the ordered quantity, how much quantity you need to order. So that is all. So two areas, one is the discount model, the other one is the what? This is the deterministic model, three models that I discussed with you. And then one more, sometimes he can ask you from this, what is the reorder point and reorder level and lead time. So as you know, you can find out how much is the quantity that is left in your stock when you place the order. So somewhere you place the order. So if you know the consumption rate over here, if you will multiply by time left, which we call as a lead time demand. So if you multiply the consumption rate with the lead time demand, that is going to give you the reorder level or quantity left in your store when you place the order. So we call it as a reorder level or reorder point. That is how much quantity is left in your store when you place the next order. So that way, so multiply by the lead time demand with the consumption rate. So this also sometimes he frames the question. Then if you go to another area of this particular section, that is the queuing or the waiting lines. Now for waiting lines, you need to know these are the different parameters based upon the waiting lines is discussed. In the waiting lines, you must need to know what is the meaning of this arrival rate, mean arrival rate, and mean service rate, and mean time, and mean service time, and the mean arrival time, right? If you know that, then I think you can proceed. And the most important, sometimes now he's checking your understanding nowadays of your, like, what kind of distribution that you are making use of, right? For example, for the rates, we are using the Poisson distribution, whereas for the times, we are making use of the what? This exponential distribution, negative exponential distribution. So this distribution formula you should know that, for example, for Poisson distribution, how you define the Poisson distribution, and for how you have that probability distribution function. Basically, this is the probability distribution function for the Poisson distribution for the for the arrival rate, and for the inter-arrival time, you have the probability distribution, this one. So he is going to ask directly this question based upon these formulas. So just go through the probability distribution functions for this arrival rate and for inter-arrival time, how to find out based upon this. And then Kendall's notation, you must have gone through this. This is the different terms you must be clear about in Kendall's notation. And this is the model on which the questions are framed. 99.99% the questions are framed from this single model only, right? I think once there is a question from another model, but 99.9% your questions have been framed from this section, this model only, when you are having these notations, right? I hope you understood what is the meaning of MM1 and this. So now you need to remember these formulas for this particular model, right? So these are the formulas for example, line length or expected number of customer waiting in the queue, and for system, and Little's law. I've discussed in the NPTEL assignments also. So Little's law, these two formulas, if you know, waiting time in queue and waiting time in system, you can find out. And this is a system utilization also. I had taken one or two questions based upon that also. And these are the performance measures which you need to know, that what is the probability that how many number of whether there are any customer in the system or not. If there is no customer in the system, then what is the probability? And if there is, if the system is busy or there is at least one customer in the system, then what is the probability? And probability that how many, let's say, what is the probability that there is a one customer in the system, or what is the probability that there is two customers in the system? You can make use of this formula. So if you'll remember in this topic, if you'll remember these formulas, only these two formulas, and obviously Little's law, these you don't need to remember. If you remember this, if you know this, you can get this and this and these 2-3 formulas, then you can attempt any question from this particular section. So just remember for this particular model, these particular formulas. Okay, and this strength of material portion already Ruchin sir had discussed in the morning session only. So if you want to go through that, you can just go through that session also. That is already live, that is over there on the YouTube. So I am not going to explain it over here, okay, because it has already been discussed with you. So now I am going to discuss with you the machine design portion. So let me just discuss with you that portion now. Okay, so and this part and CPM already discussed with you in the morning session by Ruchin sir already, so you can just watch that session. Okay, now let's go to the machine design portion now. Okay, so I'm going to start with the this joint section first. Joint section is the most important section, as you know. See, from production planning and no, it is already there. It is not removed. That video is already there. Just check it for the that was taken for along with the industrial this civil engineering this. So in civil engineering video, this section was covered already. So just check it over there. It is already over there. Now you're talking about yeah. See, in production planning and control, only one, if there is a possibility of only 1 mark because of the theoretical section, right? So now let's come to the this joint section on the this in case of machine design. From joint sections, welded joint, riveted joint, and then you are having the bolted joints. Definitely there are going to be questions, and every year there are going to be questions from this section, right? So so that is the importance of this particular topic is. Now in case of riveted joints, as you know, first if you talk about, so riveted joints are subjected to, or in case of riveted joint, you are having shear stresses, compressive stresses, and you are having that particular or tensile stresses also. So all those stresses that we need to discuss. For example, when we are having these particular rivet, let's say whether it is a butt joint or rivet joints, how you find out the shear stress? If you divide by force divided by area which is getting sheared. So if you are having one rivet only, then you are having this simply shear area, that is one cross-sectional area. But if number of rivets are more, then you have to consider the N. N means how many rivets are there whose cross-section area is getting subjected to shear. So you need to take, in this case, all the rivets. So N is important factor, as you know, that how many rivets. The most important thing is to find out the, sorry, just a minute. Okay. Okay, so most important thing over here is to calculate the value of N correctly. So just take note of it, that what is the value of N, that how you need to find out. In case of this lap joint, all the rivets that are in the joints will be, N will be equal to the all the rivets that are in the lap joint. But in case of single riveted lap joint, this single strap butt joint, you are having the number of N is going to be the number of rivets in that particular plate, right? So N is quite important over here that you have to take note of. Simply, this is a case of single shear. That means only one cross-section area is getting subjected to shear. In case of lap joint and in case of single strap butt joint. But in case of a double strap butt joint, you are going to have the two areas which are getting subjected to shear. For example, each rivet is subjected to in shear at two areas, so you need to multiply by 2, right? So this is the cross-section area of one of that rivet at one point, and the other area, that is this. So you need to multiply by 2. Now, if in each plate there are more number of rivets, for example, in this case there are 3. So what do you need to do? You have to multiply this with the N. N mean number of rivets in that plate. So either this plate or this plate, not in both the plates. you have to consider separately. So that much I think you maybe have an understanding. So that is the only thing. Same way you have to find out the crushing of the plate. So individually he frames the question. Sometimes he checks your understanding based upon that only. For example, in case of crushing stress, how to find out that particular, again, the projected area. In this case, you need to take the projected area of that particular rivet, or maybe that particular for that particular plate, and n you need to find out accordingly. Similarly, sometimes he asks you to find out the strength of the riveted joint. So strength of the riveted joint is the least amount of force that particular riveted joint can carry. So you know, from the same formulas that we have discussed, like shear stress, crushing stress, tensile stress, from there we can calculate the maximum value of the force that you need to. So out of these three, whichever is minimum, right? So that is going to be the strength of that particular riveted joint. For example, over here 80, 120, 100. So this 80 is going to be the strength. So then there is one other term in this case is the strength of the riveted joint to the strength of the unriveted solid plate. So just remember this of how to find out the efficiency of the riveted joint. So first you need to strength of the unriveted solid plate, riveted joint to the unriveted solid plate. So strength of the riveted joint, as I discussed in case of earlier case, it is going to the minimum of these three. So minimum divided by the unriveted solid plate, uski strength se divide kar do, that is going to give you the efficiency. So this is one area where directly he is going to check your understanding of the stresses which are acting on those particular rivets or plate. And the other area is the eccentrically loaded riveted joint. So this you know already, this is eccentric loading of riveted joints. This topic is common with the bolted joints also. Sometimes he frames the question from this section, sometimes he frames the question from the bolted joint. So same way, for example, primary and secondary shear stresses you should know, and how to calculate the value of this particular forces, that is where in which rivet you are going to have the maximum value of the force. So in this case, as you know, you are going to have the shear stresses. So how to calculate those shear stresses? Same way, if you go ahead, okay, so that's all. So these are the two areas. So in this case, in eccentric loaded riveted joint or bolted joint for that matter, what you calculate is which is the most heavily loaded rivet that you calculate, right? Calculate that, and then accordingly you can find out the answer. Now let's now go to the another area from where the questions are framed. This area is which one? So this area is basically stresses in the bolted joint. So in bolted joints, as you know, three different stresses. One is this one, tension, tensile stress, simply diameter, minimum diameter of this. Same way in case of shear stresses. So how to calculate the shear stresses, you should be very clear about it. So how to calculate shear stresses in the bolt, and same way you are going to have the crushing stresses. So this is the formula for the crushing stresses that you will make use of. So these three stresses he can individually ask you to, or very frequently ask you the question from the tensile stresses, and he can ask you from the shear also. Then you are having torsional. Let's say how much torque. When you are applying the torque, obviously you are going to have the torsional shear stresses which will be induced in that particular this. Now, in addition to it, sometimes the question is framed from this section where you are having the bolt on the periphery of the flange of that particular cylinder. So from pressure you can calculate the force which is acting, and from there you can apply the tensile stress equation P by cross section, the area of the bolt and number of bolts. So from here you can calculate it. Same way, this is one area, that is the basic part. Then the other area from where the question eccentrically loaded bolts. One was the earlier case where we have seen in case of riveted joints. There is another way of this where you are having this kind of eccentric loading where you are going to have these bolts which are subjected to tension. So tension mein jab subject honge, to this is going to be the tensile load. How to calculate the tensile load? You can calculate from here, and the shear load which is acting over here you can calculate from here. These different types of loads are acting. So you have to make use of the principal stress theory and maximum shear stress theory, and to calculate the dimensions of those bolts, right? So यहाँ पर आपको शायद बहुत क्लियरली विजिबल नहीं होगा, बट इट इज सेम एज फॉर एग्जांपल यहाँ पर मैंने कैलकुलेट कर दी, इतनी स्ट्रेस इंड्यूस हो रही है, तो दिस इज गोइंग टू बी लेस देन द शुड बी लेस देन द अलाउबल वैल्यू ऑफ द स्ट्रेस, राइट? फॉर एग्जांपल शेयर स्ट्रेस है, तो दिस इज द मैक्सिमम वैल्यू ऑफ द शेयर स्ट्रेस इंड्यूस, so this must be less than the allowable value of the shear stress. Then strain energy stored in this. So you know bolt जो है that it acts as a elastic member. So what is the strain energy stored? External work done P delta half P delta. So अगर वो अलग अलग कर देता तो उस केस में जो है threaded portion के लिए अलग कैलकुलेट कर दो and calculate for the remaining portion separately. Add them up, that will become the total strain energy stored in that particular bolt. So on the similar line, for uniform bolt, you may be remembering this formula that अगर हमने uniform strength का बनाना है, then stiffness, again stiffness formula, force required to produce the unit deflection. So stiffness का concept you may have studied it in case of these springs also. On the similar lines, you have to use this stiffness concept by considering the each portion of that bolt as a spring. For example, this will be a separate spring, this will be a separate spring, that analogy. And for parallel springs, and this becomes a series. So how to calculate the stiffness? Total stiffness you can calculate. Now let's come to the welded joints. In welded joints, let's say this is a butt joint. So butt joint force is acting this way perpendicular to the welded portion. So you are having this transverse butt joint because load is acting perpendicular direction of weld. So now it is getting subjected to tension. Tension means force divided by the area, cross sectional area, that make use of that. And same way, if I am applying a load parallel to that weld, then this become equal to the parallel butt joint. So if I apply the load parallel to the length of the weld, so again in this case the weld will be subjected to shear. So use the force divided by, again area is going to remain same, it is going to change. So if you see this formula and this formula and this formula, they are more or less same. So it means only difference being this is for shear and that is for tension, because the loading over here is pulling it, whereas in this case loading is shearing it. That is the only difference. So this is a butt joint. Then you are having the fillet joint over here. If you see again the same analogy, in this case this is a parallel fillet joint. Why? Again the load is acting parallel to the length of the weld this way. So again in this case, since this is a fillet weld, so it is going to again force shear, getting subjected to shear, force divided by shear area. And I hope you know that relationship between the throat thickness and this. So throat thickness and the leg length of the weld. So you can calculate from here very easily. So make use of that and find out the maximum value of the shear stress induced in the throat of the weld. So same way we can have that transverse fillet weld. Transverse fillet weld means I am now applying the load perpendicular to the direction of the weld. Now over here also I am going to design it based upon the shear stresses. So again force divided by area. Area is throat thickness multiplied by length of that weld. So if you will see in case of welded joints, this that we are studying over here, simple welded joints, you are having only one formula. This formula is same with that of this formula, with that of this formula, with this that of this formula. So formulas are same, only difference being somewhere it is going to have the shear, somewhere it is going to have the tension. That is the only difference, right? Now let's move on to the eccentrical loaded. Like they were the simple loading cases. Eccentrical loaded, like we could have this configuration. So in this case we need to find out what kind of stresses are acting. So one is going to, in this case both are going to be shear, one is going to be direct shear, another is going to torsional shear stress. So here you have that formula, for example primary shear stress, secondary shear stress, how to calculate it. So you can make use of these formulas directly. And finally, like you have done in case of riveting, you can find out the maximum value. That is the point on the weld where you're going to have the maximum value of the shear stress that you can calculate from here. The same formula that you have for the force in case of riveted joints. Same way you are having that eccentrical loaded welded joint, but configuration is different. This was on the plane of the weld. See the configuration. This configuration was this was eccentric. Over here also it is eccentric, but its configuration is a little different. In this case, your weld is getting subjected to direct shear stress. So you calculate force divided by area, shear area, and then bending also, because it will bend. So when you will bend it, apply the force. So direct shear force and then bending also. So it is getting subjected. So two different types of stresses. So in that case, what you have to do is you have to make use of the theory of failure, either maximum shear stress theory or that. So you can like bending and shear. So here you are having one is direct shear, another is bending. Two different types of stresses. When you make use of the theory of failure, and like let's say if it is ductile material, we will make use of maximum shear stress theory to find out the dimensions. Then it can be subjected to torsion. So here you could have configuration. So this make use of this torsional shear stress equation and find out the maximum value of the shear stress on the throat of the weld by making use of this formula. So that is all in case of this joint section. So in case of welded joints, one is a simple loading cases and the other one are the eccentric, where one is matching, two cases are matching with your earlier cases, and another one is a torsional case that we discussed. Then let's go to the clutches. And I think this the question which is framed from this particular section is relatively easy and directly formula based. So you can just see these are the friction clutches that we are talking about. So we make use of the two theories, that is the maximum pressure theory and maximum wear, uniform pressure theory and uniform wear theory. So basically, in these cases, we try to find out what is the maximum torque that your clutch can transmit and what is the maximum force that you can apply. As simple as that. Two things you will be making use of over here. One is what is the maximum force that you can apply and on the clutch, and what is the maximum torque your clutch can transmit. That is all in each case. For example, you are having a single plate clutch over here and your uniform pressure theory. Make use of this formula to find out how much axial force you can apply to keep those plates together and what is the maximum torque transmitting capacity. So either you can write in terms of this formula or you can write in terms of this formula. So these two formulas in any case you need to remember if you ask based upon the uniform pressure theory. But there is another theory called as the uniform wear theory. Uniform wear theory. For the same clutch, you can use, if based upon the uniform wear theory, you have to make use of the formula, this formula, to find out the axial force that you can apply and the torque that you can apply, you can calculate from here. So two formulas over there, two or rather three also, because you can put it in terms of capital P also. One, 2, 3, and same way over here also in case of uniform wear theory, 1, 2, that is mu P by 4 D plus D, and this one. This is this and this is same. This and this is same. From here, basically we rearranged it and put it this value this way. And the same way, let's say instead of this single plate clutch, if you are having multi-plate clutch, so you need to have this clarity of rest. All the formulas are going to same. Torque transfer force value is going to remain same, whether it is uniform pressure or uniform wear theory. Torque transmitting capacity will get multiplied by the number of contacting surfaces. Now keep note of these are the number of pairs of contacting surfaces, not the number of plates. Z over here. That is the only mistake that you can commit. And number of contacting surfaces will be number of pairs. Number of pairs of contacting surfaces will be total number of plates minus 1. So that is the only thing you need to know. That is the, don't commit the mistake of this. So Z over here is the number of pairs of contacting surface, not plates. Then con clutch, again same kind of concept that you are going to use. And over here, in case of torque transmitting, I want to find out again same way. In case of con clutch, the how much force you need to apply and what is the torque transmitting capacity as per the uniform pressure theory, and same way as per the uniform theory, how much force I can apply and what is the torque transmitting capacity. So this formula should be you should remember. And there is one more clutch called as centrifugal clutch. And in case of centrifugal clutch, I think as if you have revised it earlier, already done it, then there is no issue. But if you are not revised it earlier, then directly remember this formula. That is what is the torque transmitting capacity of the this centrifugal clutch. By directly remember this. If you know the basic concept, then you can get it immediately by applying the concept also. But if you are not done, then directly remember the formula. If you frames the question directly, you must be able to solve it. So then, okay. So one area of clutch, from the clutch portion, if he asks the question, is going to be pretty simple. Same way, almost every year he frames the question from this particular block brakes. And they are the simple questions, right? Pretty simple, only difference being that, okay, 2-3 things that you have to take note of. That is, one is that what is the torque, how to calculate the torque transmitting capacity. So this, remember this formula, 2 formulas, 3 formulas that you will remember. Torque transmitting capacity, and this is the moment equation that about the hinge that you have to do. So just focus on this equation. You will all of you will be remembering this. The only mistake that you will be committing will be on this portion, how to find out the moment equation. If you will be able to write the moment equation properly, you cannot lose that particular question. So only mistake that you conduct over here is this one. Then what is the self-energizing condition and self-locking condition? Just take note of that also. And so in case of block brakes, this is a short shoe brakes. That is the one area. This almost very frequently question is framed, and you have to first draw the free body diagram and immediately write this torque. This should remember, and you must know how to write this particular equation, and that's all. If you know this one, then you cannot commit any mistake. Same way, you are having this simple band brakes kind of question which is framed. The only thing is first identify clearly the tight and slack side. Once you have found out the tight and slack side, You need to remember these two formulas, and again one moment equation that you need to develop. Breaking torque, this formula you need to remember, and this one more formula, because P1, P2, two variables, not known. So P1, P2, two variables. From these two equations, I will be able to find out P1 and P2. So these two equations you need to remember, and this third equation that you have to make use of will be from the moment that you need to take about the hinge for this lever. So that is all. Again, if any at all you can commit the mistake, you can commit mistake on this portion of taking the movement. These, any case, you have to remember. Same way in case of differential band brake, you're having okay, tight and slice hai, identify correctly tight and slack side, and from there again in this case also you are going to have the same, no additional formula like you have in case of simple band brake. First formula is this, second formula is this, third that you have to is the movement that you have to take about the hinge. Again, this is going to be the most critical part of your question, right? If you will take it correctly, the job is done. And if you ask for self-locking condition also, so based on the concept of self-locking, you can do that. So again, this is the same thing, only difference is I have calculated for the self-locking condition what should be the condition. Okay, so two areas from brakes. One is the short shoe block brake, from where question will be framed. Second is going to be the band brakes. One is a simple band brake and the other one is the differential band brake. These are the three areas from the where questions will be framed. Now let's go to the design section. That is, this spur gear design. Over here, just take note of this power equation. You must be able to write it correctly. That is, power will be, I think one question I have already done in case of NPTEL assignments, and this one is same. That is on gear and on this total power will be ideally same on gear as well as on the pinion. This is the basic part. When you go to the design part, you have to bending stress equation that you need to write, and from the simple bending equation, that is a simple bending stress equation, and what is the load that tooth can carry. So this is the equation that you need to remember, and some additional terms I have already given you. And what is the beam strength? You should know clearly this formula of beam strength from here. So, and over here, what is the value of Lewis form factor that I have given you? Just remember these values because he may not provide those values in the exam sometimes, so they're going to be helpful. Now, beam strength that is given to you based upon what? When you have to when gears are made up of same, that means these are some two statements which are given to you based upon which I have to design, whether should I design based upon gear or whether should I design based upon the pinion. So that statements are given to you over here. Just go through it and how to decide. Now first is the formula. Now just take note of this. It's a link. You have this formula over here, same formula will be written over there. For example, this is the maximum bending stress. If I want to write, I will have PT divided by BMY. Same thing has been written again over here. See, PT divided by BM. Over here, instead of Y, I have written J. J is a spur gear geometry factor. So if he has given the Lewis form factor, then you will write it as a PM into Y. As simple as that. This is the sigma B max as per the Lewis equation, beam strength equation. This equation you already know. Sometimes instead of Y, he will replace it with J. Spur gear geometry factor when you are having the stress concentration is given to you. So he will give you directly the value of J. So instead of Y, make value of use of J, as simple as that. Then dynamic effect. Now you know that earlier this whole analysis was based upon the static. Now when you have to include the dynamic load, you have two ways of including. Either include that particular by taking the value of the Barth factor kV, or you use the Buckingham equation. So instead of that, what you will do, these are the earlier equation. I have not modified. These are the earlier equation that I told you. In this case, it is Y. In this case, it is J. Now, after that, we are considering the this dynamic factor. For dynamic factor, you need to use the kV. So instead of PT, you will use the actual load which is acting, which is P effective. So that is a PT divided by kV. PT you will get from the power equation over here. kV from these you will get, input these values and input over here. So now I am modifying this by this, writing P effective over here. See, same equation, but only difference being instead of PT, it is P effective, which I have calculated this way. So see, P effective divided by this. Now P effective is PT by kV, PT by kV. That is the additional term which is coming over here. Same way, spur gear geometry factor is given, then you will write PT by kV. That's all. So he will give you the value of kV, or he will ask you to calculate the value of kV. PT you can calculate from the power equation. Now, so it means to consider a dynamic effect, I modified these equations. Another way is to calculate the effective pressure is, you know, Buckingham equation. You should know that these different terms that are over here, given over here. Right. So PD, that is incremental load, additional load which is acting on the gear tooth, that is given by the Buckingham equation. So P effective, you have two ways of calculating as we discussed. One is that basic, that PT, और उसमें एडिशनल लोड ऐड कर दो, एक ये तरीका है. दूसरा तरीका जो हमने ऑलरेडी देखा, P इफेक्टिव आप ऐसे एक्चुअल प्रेशर फोर्स यू कैन कैलकुलेट डिवाइड बाय PT डिवाइड बाय KV. सो आइदर डिपेंडिंग अपॉन व्हाट ही हैज गिवन, अगर KV दिया है तो यहां से P इफेक्टिव निकालोगे, इफ ही हैज गिवन यू PD तो ऐड करो उसको PT में, P इफेक्टिव आ गया. वंस यू हैव गॉट द P इफेक्टिव फ्रॉम हियर, either from here or either from here, then use that P effective in this equation that we have already discussed. As simple as that. So ये तो गया आपका gear tooth. Now there is one more way through which that particular gear tooth can fail, और वो fail हो सकता है आपका, that is from the wear. That means wear failure भी हो सकता है, pitting failure भी बोलते हैं. For that this Buckingham has given one equation to find out the wear strength. तो wear strength के लिए equation है, इस equation का use करो. Different terms are over there, make use of those terms and find out the value of wear strength of that. Okay, and okay, in any case wear strength should be greater than the actual tooth load which is acting over there. और gears के लिए which are made of steel and both gears are made of steel and 20 degree pressure angle है, तो यहाँ पर K actually इस equation में K जो है वो directly instead of calculating from here you can calculate from this also, directly from here also. Now so that is all in gears, right? तो गियर में सिंपली दो इक्वेशंस हैं, इफ यू रिमेंबर. वन इज जो बीम स्ट्रेंथ इक्वेशन है उसी को मॉडिफाई किया और इफेक्टिव निकालने के लिए, बट दैट इज ओनली वन एनालिसिस ओनली. सेकंड जो इक्वेशन है दैट इज द वियर स्ट्रेंथ की, जो लास्ट में मैंने डिस्कस की आपसे, ये वाली. दीज आर द सेकंड इक्वेशन, ये राइट. सो देयर आर ओनली टू इक्वेशन पर गियर डिजाइन, उसको यूज करोगे तो आसान. देन शाफ्ट डिजाइन में यू नो मैक्सिमम वैल्यू ऑफ बेंडिंग स्ट्रेस कैसे निकालते हैं, ये आपने सॉम में पढ़ा होगा. सिंपली क्या है कि व्हेन यू आर हैविंग दैट, इसमें बेंडिंग भी लग रही है और व्हेन यू आर हैविंग द टॉर्शन आल्सो, सो यू आर हैविंग दिस फार्मूलास व्हिच यू हैव स्टडीड इन सॉम. इन केस ऑफ कॉम्प्लेक्स स्ट्रेसेस आल्सो प्रिंसिपल स्ट्रेस और मैक्सिमम शियर स्ट्रेस कैसे निकालनी है, दैट इज द ओनली थिंग. जस्ट उसको प्रॉपर फॉर्मेट में लिखो. अगर मैक्सिमम प्रिंसिपल स्ट्रेस थ्योरी दी है तो आप जो है प्रिंसिपल स्ट्रेस कम होनी चाहिए यील्ड से, एंड अगर शियर स्ट्रेस है तो शियर स्ट्रेस उससे कम होनी चाहिए. दैट इज ऑल. सेम वे अगर मान लिया बेंडिंग में ही है तो आप शेयर हटा दो, जीरो कर दो, तो आपका क्या आ जाएगा, डायरेक्टली बेंडिंग आ जाएगा. अगर आपका लेट्स से इफ इट इज ओनली शेयर टॉर्क ओनली, देन सॉरी एज पर द मैक्सिमम शेयर स्ट्रेस थ्योरी, तो अगर इफ लेट अस से इट्स बेंडिंग तो शेयर जीरो होगी आपकी, तो मैक्सिमम वैल्यू ऑफ द शेयर स्ट्रेस विल बिकम इक्वल टू दिस. सो सेम इक्वेशन, केवल उसको मॉडिफाई कर दो, दैट्स ऑल. डिपेंडिंग अपॉन ये मेरी आई कहां पर आई, ये इक्वेशन, ये इक्वेशन. अगर मान लिया इफ इट इज ओनली टॉर्क ही लग रहा है, देखो इसी को मॉडिफाई करो. इफ टॉर्क ही लग रहा है तो इसको जीरो कर दो और इसको भी जीरो कर दो. पर अगर आपका लेट्स से टॉर्क नहीं है, ओनली बेंडिंग स्ट्रेस ही है, तो इसको जीरो कर दो, यही रहेगा. इसको जीरो कर दो, यही रहेगा. दैट्स ऑल. द सेम मॉडिफिकेशन हैज बीन डन ओवर हियर. सो इफ यू सी ओवर हियर, व्हेन यू आर हैविंग बेंडिंग ओनली तो ये जीरो हो जाएंगे इन दोनों इक्वेशंस में, और व्हेन यू आर हैविंग शियर ओनली, जब आपके पास शियर ही है तो उसको मॉडिफाई करके आपकी जो है प्रिंसिपल स्ट्रेस और मैक्सिमम शियर स्ट्रेस यहां से आ जाएगी. सो ये होगी आपकी मैक्सिमम प्रिंसिपल स्ट्रेस एंड मैक्सिमम शियर स्ट्रेस थ्योरी के बेसिस पे, राइट. एंड आल्सो समटाइम्स सेम इक्वेशन कैन बी मॉडिफाइड डायरेक्टली, अगर आपने जो है बेंडिंग मूवमेंट और टॉर्क डायरेक्टली इनपुट करना है इंस्टेड ऑफ कैलकुलेटिंग द बेंडिंग स्ट्रेस एंड टॉर्क. तो ये दोनों आपको इक्वेशंस पता होनी चाहिए आपको क्लियरली. देन सेम वे ये आपका हॉलो शाफ्ट के लिए है, स्लाइट मॉडिफिकेशन, जो अर्लियर दे वर फॉर द सॉलिड शाफ्ट, एंड ये हॉलो शाफ्ट का ही केस चल रहा है. And then okay, this is for the hollow shaft only. Same equations, original same equations, and then you are having this one, you know, combined है. Let's say if you are having bending और torsion दोनों है, पर ये distortion energy theory है. जो बाकी theories हमने दो theory देखी थी, the principal stress theory and the shear stress theory. यहाँ पर ये distortion energy theory है, basic formula है. इसको modify करके आपने इसको याद रखना है. But एक तो just remember this formula over here, जिसमें bending भी है, shear भी है, and you can convert it into bending moment and torsional moment. सो डायरेक्टली आपको क्वेश्चन फ्रेम करेगा, आप उसको मॉडिफाई कर सकते हो अकॉर्डिंगली. दिस इज फॉर द होलो शाफ्ट. डिस्टॉर्शन एनर्जी थ्योरी फॉर होलो शाफ्ट यूज कर रहे हो आप, तो ये है जिसमें टॉर्क भी है और बेंडिंग मूवमेंट भी है. ओके, नाउ लेट्स गो अहेड विद दिस पर्टिकुलर डिजाइन अगेंस्ट फ्लक्चुएटिंग लोड, राइट. Now fluctuating loads में you are having first जो concept आता है, that is first is of what this theoretical stress concentration factor. So theoretical stress concentration factor आपको clearly पता होना चाहिए. It is given to you over here, you can just skip through. And the second जो question frame होगा that you are going to have over here will be the SN curve. SN curve के बेसिस पे एक तो फाइनाइट लाइफ होगा जिसमें आपको इस पोर्शन का यूज करना पड़ेगा, इनफाइनाइट लाइफ के लिए एंड्योरेंस लिमिट का यूज करना पड़ेगा. सो ये आपको क्लियरली पता होना चाहिए, 10⁶ साइकिल एंड ऑल दैट, ये यू शुड बी क्लियर. एंड देन ये तो है फॉर द स्पेसिमेन, दैट इज फॉर द स्पेसिमेन एंड्योरेंस लिमिट SE डैश. बट एक्चुअल कंपोनेंट के लिए यू नीड टू मॉडिफाई, देन यू से दैट करेक्टेड एंड्योरेंस लिमिट, वो आपको फाइंड आउट करनी है, डिफरेंट फैक्टर्स हैं लगा के. Then KD over here is 1/KF, where we KF जो हम बोलते हैं fatigue stress concentration factor है. तो fatigue stress concentration factor you can calculate it from here. उसका यूज करके नॉइज सेंसिटिविटी एंड theoretical stress concentration का यूज करके निकाल सकते हो. So one question is going to be from right based upon this, where you have to design the component which is subjected to the completely reverse stresses, right? And endurance limit का यूज करना पड़ेगा उसको सॉल्व करने के लिए, उसको अप्रोच करने के लिए. So this is one set of the question जो कि फ्रेम किया जा सकता है. Second will be when your component is not subjected to completely reverse. Completely reverse नहीं है, but क्या है, this mean component भी है और stress amplitude भी है, that is the fluctuating है. तो fluctuating stresses के केस में what do you make use of? You make use of this particular these three concepts, designing component for fluctuating. मतलब beam amplitude of stress is also there and mean stress is also there. Soderberg, Gerber and Goodman criteria you use करते हो. These are the equations when you are not applying the factor of safety, and when you will apply the factor of safety, तो इसको मैं modify कर सकता हूँ factor of safety के form में अगर मैंने use करना है. Same way, let us say ऐसी situation हो सकती है कि up to this point हम यही बोल रहे हैं कि आपका जो है वो fluctuating है, but only one. या तो torsion है तो torsion ही fluctuating है, या तो shear this bending है तो bending ही fluctuating है, that is only. But there could be situation where a component है which is getting subjected to bending, torsion and axial, और वो जो सारी stresses हैं वो क्या कर रही हैं, fluctuate भी कर रही हैं. So यहाँ तो केवल एक ही थी, there was only one, but that was fluctuating. या तो either shear थी या तो axial थी, that was only, but they were individually they were fluctuating. एक ही लग रही थी उस component, only one stress was acting on that particular component and was fluctuating. But let us say you are having component, उसके ऊपर दो, there are 2 or 3 stresses, different stresses acting, and all 3 or 2 or 3 stresses are fluctuating. तो उस केस में we cannot design based upon that, but what we can do is we have to make use of the distortion energy theory, जिसके लिए आपको जो है modify करना पड़ेगा उसको biaxial state of stress में. ये equation आएगी एक, और फिर फिर हमने मीन और एम्पलीट्यूड निकालना कंबाइंड लोडिंग के लिए. एंड अगर वो मान लिया एक्सियल और टॉर्शन है तो ये इक्वेशन आएगी. यहां पर क्या था, बोथ आर एक्सियल, यहां पर एक्सियल एंड टॉर्शन है, दैट इज द ओनली डिफरेंस. तो उस केस में मेरे पास ये आएगा इक्वेशन, और इसका मीन कंपोनेंट एंड एम्पलीट्यूड ऑफ स्ट्रेस लेना है. एंड वंस वी हैव कंबाइंड यूज दैट, देन वी कैन पुट इट ऑन द सेम सोडरबर्ग, गुडमैन, और उसके ऊपर यूज करके हम क्या करेंगे. एंड जो whatever all those these जो इसका लिंक है, जितनी भी पीडीएफ, द होल पीडीएफ विल बी शेयर्ड विद यू, उसके लिंक में आपको डिस्क्रिप्शन आएगा. नाउ आई थिंक go to the examination hall with confidence. Tomorrow, day after tomorrow, you are having the exam, and जो भी rather हमने रिवाइज किया, rather NPTEL assignments, as you know, उसमें हमने डिटेल में डिस्कस किया. And before that also, rather if you some of you who are just watching our series and all that, Fundu, Fodu, and all those. Then after that, we went for the NPTEL assignments, and now we are just to make you revise and just go through it. Same, so just go through it and just revise it and go with confidence. And as you know, जैसे आप examination hall में जाओगे, and whatever is your result, just don't bother about results, because whatever is your result at the end of the day, based upon your best possible effort, so we can try to find out the options. Possible options आपके पास हमेशा हैं. It is not that only at a very high score is going to have the options. It is not that way always happen. So we will explore those options once you have come out of the exam, ठीक है, based upon how well you have performed. So हम उसके बाद post GATE counseling and all that, where we are going to guide you in a very systematic way throughout your journey. So as of now, I think आपका focus क्या रहना चाहिए? Focus should be just revise it well with full confidence, whatever your preparation level, because एक और दिन, 2 दिन में you cannot do anything much now. Only सिंपली रिवाइज करने के अलावा आप उससे ज्यादा कुछ नहीं कर सकते। तो अगर इफ यू विल गो विद अ पॉजिटिव स्टेट ऑफ माइंड देन डेफिनेटली यू आर गोइंग टू स्कोर बेटर, ज्यादा ही आप क्या करोगे, परफॉर्म करोगे। एंड इफ यू आर परफॉर्म बेटर टू द बेस्ट ऑफ योर कैपेबिलिटी, उसके बाद we will explore all the options that we are going to have after that, whatever is your score, as you know, as I told you. So I think all the best for your examination from YourPedia mentors, from all of the YourPedia mentors, on behalf of all YourPedia mentors. And we'll see you once your exam is over, and then we'll start next journey of getting the best out of whatever you're going to score. Okay, so see you at the next session after the once you are over with your exam. Till then, bye. Thank you and all the best.